Check 1 2 1 2 1 2. Check 1 2 1 2 1 2 2 1 2. One check 1 2 1 2 1 2. Check 1 2 1 2 1 2 2 1 2. One check 1 2 1 2 1 2. Check 1 2 1 2 1 2 2 1 2. Maybe try that. 1 2. Can you hear me? Hello? Can you hear me? Check, check. Check, check.
Yeah, so basically, we do have
3. Yeah. But just not blocking the camera.
Not blocking the camera.
Not blocking the screen.
Oh, okay, so
We're just trying.
so like sorry.
Okay. Let's start now. Guys. Yeah, that's all good. Would you like something more? Is that okay? Yeah. Attention. Hi everyone, can I get your attention please? Can we take a seat please? Cool. Great. Great. Ivor, good to go. Great. Welcome everyone to the first. Oh, a little bit of a delay. Can we take a seat, please? Two of me. Ivor, we good now? Yeah. Is it good? Great. Okay. Hi everyone. Oh. Okay. It is a good trick. There's a bit of an echo.
We're getting the live stream audio on the speakers.
We're having a few technical difficulties. Bear with us. So testing 1, 2, 3. Great. Okay. I think that's good. Okay, hi everyone. Welcome to the NHS R Community Python track. This has been organized by the NHS Python community. We are a community of practice of over 700 people who champion open health, Python and health and open code. We are very, very delighted to have a full packed schedule today. We have a wonderful lineup of speakers from healthcare, from academia, from industry, and we have topics ranging from geospatial to software development to privacy to neural networks. So we're very, very lucky today. There was a lot of people I have to thank for sort of organizing this conference. So I'm going to thank Craig, our co-founder, who has spent a long time sort of organizing this. Simon, Fires, Pete, Kabir, Oliver, Johnny, Mark, Sophie, Harris, Juan, Aruba, Mattia, Susan, John, Alex Chung in Hong Kong, and thank you for the NHS R team as well, Mohammed, Charlotte, and Chris Beatty. So a lot of organizations going into this. I am gonna get straight into the agenda today, but I just want to say that if you have questions, we want this to be as interactive as possible. Please raise your hand up. Someone will come with a microphone, and if there are questions from the audience online, we'll make sure that their questions are feeded through as well. Okay, I'm going to start the show. So our first speaker today is Sarah Culkin. She is the Deputy Director for Data Science and Analytics at NHS England. So Sarah, do you want to come with your keynote?
Hi everybody, can you actually hear me? That's the question. Not yet. How about now? Hey. Great stuff. Well, it is absolutely wonderful to be here, and I do not mean that in any way lightly, because number one, we are actually here in a room in person, which is just fabulous. And number two, I think the last time I came to an NHSR conference in person, there was physically no Python community. So it is absolutely wonderful and testament to so much hard work by a few very important people, I think we know who, that we are sat here in a room today with a packed schedule ahead of us to discuss all things Python, and that is absolutely remarkable and amazing. First of all, let me introduce myself. So I'm Sarah Culkin, as Mary says. I'm the Deputy Director of Data Science and Analytics. What that actually means is I head up a team of people that used to sit in what many of you may remember as an organisation called NHS X. So NHS X was set up about 3 years ago. It was a joint unit that brought together colleagues from NHS England and the Department of Health and Social Care, and its intention was to look after all things digital transformation on behalf of the health and care sector. At the time, I was working in NHS England and was actually working in a data policy team, and so was one of the NHS England colleagues that moved across to that unit. However, up until that role, I have spent my entire career working as an analyst and a data scientist in either the Department of Health and Social Care or in the NHS. I joined the Department of Health straight from university, where I'd done a PhD in chemistry, so it was a slightly different move, but numerate nonetheless, and has spent my time in many different roles, right from, I think when I first started, producing endless performance reports, looking at all kinds of different measures that they wanted to measure the NHS for at the time. I think a particular highlight and favourite metric at that time was whether a patient had had a packed lunch given to them if they were discharged before lunchtime, which is just beautiful, isn't it? So yes, spent a lot of time in the NHS, and it was actually in the Department of Health that I first came across a subject or a topic called data science, and got very excited about it. And long story short, managed to convince the chief analyst at the time to set up a small data science team, and that was in around 2015. At the same time, the government digital service was running a data science accelerator program, which is still operational today, and many people in this room, I can see lots of nods, may have even taken part, and I know for a fact a few of my colleagues are even mentors on the program. So number one, if you are starting out in your data science journey, do check that out, because it is absolutely open to all public sector workers, including people that work in health and social care in the NHS. But number two, the reason I tell you this rambling anecdote is because this is when I first became aware of and had my first interaction with something called Python in 2016 on the Data Science Accelerator. And I'm not going to lie to you, I had done a bit of programming in R before then, but this was my first interaction. I'd applied to the scheme, I'd got accepted, and I was going to make an app. Yeah, I did actually make what you could very loosely call an app using Python Flask, uploaded it to GitHub, it was deployed on Heroku, so it did work. I basically hacked it together, I'm not going to lie to you. And I also used pandas for the first time, and thought, as someone who'd used spreadsheets an awful lot before that point, what a nightmare is this? Trying to get your data to load, and you can't see your data, and you've told it's in some sort of format, but actually someone stuck a load of nulls in what's meant to be a numeric column, and it doesn't load, and you can't see it. I just think this is an absolute nightmare. Nonetheless, I was with a cohort of lots of other very nice, clever people, including a particular chap who was from what was now, at the time, was called Public Health England. And at the end of the sort of accelerator program, you have to do a big presentation. And I remember sitting in the audience as he did his. And he and his team spent an awful lot of time putting together these big PowerPoint packs of public health information. I think they did this once a year, and it was a whole range of different public health information that had to be given out to every different local authority or region. So it was cut by each different local authority. It came from everywhere. It was a huge cottage industry. and he had to be part of this team. And so he thought, right, I've done the data science accelerator, I can now use Python a bit. I am taking this and I am running with it. And I remember sat there to this day. His presentation was up here, a bit like this. He'd called it something beautiful like moving at warp speed. It had a big picture of the enterprise on there. And he talked us through how he'd use Python to essentially automate the entire process of pulling in all the data, building the PowerPoint packs for each different local authority, presses of a button. I remember just sat there watching it. He did some sort of video so you could see the PowerPoints being made in real time and being assembled, and it was genuinely like something out of Harry Potter. I remember, you know, the scene where all the things in the kitchen are just moving around and all the cleaning's happening and you're just sat there having a coffee. It was like that. It was a beautiful, beautiful moment. And I think it was really at that point that I thought, okay, Python's very cool. So yeah, fast forward a few years, I find myself in NHS being asked to set up an analytics team, and I'm not going to lie, given a fair amount of leeway as to what that analytics team looked like. So when I said set up an analytics team, I said, I think you mean a data science and analytics team, and shoehorned in quite a lot of data science in there too. And it was in setting up that team that I had the very, very, very good fortune of employing one Craig Shenton, who arrived with me as a data engineer, and also some truly awesome apprentices in the way of Mary, and also at the time another colleague, Aruba, who has also moved on to amazing things. In fact, all three of them have now sadly left us and gone on to bigger and better things, but I'm not surprised in the slightest. But it was in setting up that team, and they came to me one day, and I think Craig said, got this idea of setting up a Python community. It'll be a bit like the R community, but for Python. And I think at the time I just went, yeah, great, yeah, lovely, do that. And they really did. They really, really did. And I just want to take a little moment to really pay tribute to the enthusiasm and hard work and just general brilliance of Craig and Mary and Aruba and all the people that have been involved in setting it up, and Alex from Analyst X, who was also there from WordGo, wasn't he, and who's in Hong Kong today. So if I could just take a moment just to give those guys all a quick round of applause to say well done. How are we doing for time? Okay, so we are here. We have a Python community, and it is wonderful. And I just wanted to sort of draw your attention to my one slide for the day, which I think really sort of summarises what I've just said, that sometimes if you want something to exist, you just have to make it yourself, which is a lovely example for this community, but it's actually also a very nice way of describing what you can do with Python, which is, to a certain extent, pretty much anything. And we are going to hear today a whole load of examples of exactly that. I must give credit to the makers of this badge, which is a group called the Arts Emergency, who are on Twitter and all of the social media platforms. I particularly came across this at a Joe Lycett gig I went to recently. So I don't know if many of you have also seen this same badge and how he talked about how he kind of took inspiration from it, but I also thought it was quite a nice analogy for today. Okay, so today, believe it or not, there is more to this talk. I want to talk a bit about, essentially, to orientate yourself, a bit about the past, a bit about the present, and a bit about the future. I've probably covered quite a lot about the past already and how we've got here today. So let's move on a little bit more to think about where we are here today in the present. So we're here, we're having a Python community talk for the first time ever, as I said. It's a wonderful thing. And I'm also very pleased to see, shortly after me on the list, we have some other titles that also have analogies to moving at speed. So I'm delighted that the tradition continues. So we have, I believe, Adam Carruthers, turbocharge your development with Visual Studio Code. Lovely, lovely bit of turbocharging. And Mark Bailey with A to B but faster. So very much enjoying all of that. And if anybody throughout the day is able to either get a Star Trek reference in or just a general reference about speed, then 10 extra points to you. Nonetheless, I'm sure that the other non-speedy titles will also be excellent. But the Python community isn't the only thing that I think makes it very exciting to be a data professional in health and care at this moment in time. The fact that, you know, the NHS R community exists and the NHS R community has helped the Python community to exist is a nice example of how things that go on historically, footsteps help others to grow and for things to continue. And there's lots of things that I think are, at the minute, starting to kind of build and mean that it is a very exciting time to be a data scientist, a data engineer, a data analyst in health and care sector at the minute. Some particular things, not wanting to spend too much time plugging up my own unit, but I'm going to anyway. We also, as well as having a data science team in the unit, and we also have a data analyst team and some data engineers, we have specifically a work stream dedicated to developing data analytics as a profession. This is led by someone called Sarah Blundell, who, if you may have come across, but she does a great amount of work trying to really develop what it means to be a professional working in data in the NHS. And I'm going to spend a little bit of time just talking about some of those things. And a real key thing that we have done recently is that we've been developing and testing out in the sector a set of competency frameworks. Now, this may sound like a fairly kind of obvious and potentially even dry thing to do, but I genuinely think that this is the foundations upon which a very strong, recognised and well-used data profession can be built for the health and care sector. The competency frameworks that we've built are for data scientists, data engineers and data analysts. And for those of you who are familiar with the DDAT, the Digital Data and Technology Framework developed by GDS, you will note that they very beautifully map into the data family of that programme. And that is quite deliberate. We are intentionally trying to align with wider work going on that was originally led by HEE and commissioned by NHSX and is now a kind of HEE, NHS England kind of programme looking at really strengthening and growing the wider digital workforce for health and care, recognising that actually a digital workforce is a really key part of digital transformation in health and care, and we think that the data family is absolutely a vital member and part of that digital transformation programme. So we have these competency frameworks written. The data science one, for example, I think has about 6 different competences that will take you all the way from kind of your data engineering type skills, your coding skills, your understanding of analytical approaches, your ability to communicate your work, and it is, I think there's 6 competencies split about across those kinds of things, and it's also done by a different level, so you can go right through from what a sort of an apprentice or new to the role data scientists would be expected to be able to do at those different levels of competence, and will actually show you all the way up to a sort of deputy director, band 9, head of service type role. That also exists for data analysts and data scientists, and so you can see that with these in place, you have a way to both join as a junior data scientist and see how your career could progress more senior in that same grade, or you could actually think, as a data scientist or as a data analyst, I want to become a data engineer or a data scientist. How do I move across? And there's a consistent way to do that. And so this is what I mean when I say this is now a sort of a really solid foundation from which to grow this profession. Once the competency framework exists, and it's in its very last stages of testing, it's just been tested out with about 44 different organisations across health and care, and the data science framework was developed by a set of data scientists in health and care, which in itself is an exciting development, that we've got enough data scientists spread across different organisations that they can come together and write a data science competence together. In itself is huge progress. that's not where we want to stop. We want this to be used. We want it to be used in job descriptions, in development, but also crucially, we want it to form the absolute backbone of the training offer to people in health and care. And so we are involved in, with Mary as well, all kinds of things to do with Python training, with our training. There's lots of other people in this space as well. I'm definitely not pretending we're the only people doing this, because we're not. There's loads of good stuff out there, but what we actually need is a consistent way to map it and say, this particular piece of training here will contribute to this competency here that will allow you to move to this level here. And these are all the sorts of things that we think need to happen and we want to be part of. We also have the Analyst X program, which I don't know if anybody of you have come across this before, but this is another thing that was set up during the pandemic at the time, just to share information on models and data that different analysts are using in different parts in response to the pandemic. And it has now been kind of converted to something that's called Analyst X. It has about 16,000 members, and it has on it a vast amount of L&D open to you for e-learning and different things, and also loads of different events that happen, huddles, mini huddles. There's Machine Learning Mondays. The data science community is a sort of fledgling community on that, which has now got its own kind of breakout website and area, which again, it may be of interest to those of you in the room. So that is probably where I will leave talking about the kind of the present and what we're doing in terms of the profession, but always happy to talk more if you find me in the coffee break. I'm here all day. But also let's think a bit more about actually Python in the present day. We've talked about, isn't it great that it's now here in the NHS, but obviously Python has been used for a very long time in very different ways, and in loads and loads of different industries and in very, very cool ways. So for example, Google use Python a lot. But a little bit of audience participation. Ready yourselves, introverts, because I thought first thing in the morning, second day of the conference, let's get a little bit engaged. So if I may ask you, please, does anybody have any interesting examples or industries they know are using Python at the minute? I can see one already.
I know that Instagram was originally built using Django, which is a Python framework.
Nice, thank you very much. Oh, one at the front as well, Andrew.
You can do a mean line in modding Minecraft in Python if you really want to.
Say that again?
You can do a mean line in modding Minecraft if you really want to in Python.
Yes, you can. You can. That's true. My children told me that. You can hack the back end and make it rain diamonds. Yes, go it. Truth. Anybody else? Can anyone beat raining diamonds in Minecraft? Come on.
I'll just quickly say you can save on your energy bills by writing your own thermostat program.
Nice. That's topical. Okay. Anybody else got anything to add? Go on, Johnny. You've got something.
I just think any form of visualization, any form of layering up of all different sorts of mapping tools, I really like to see. Yeah, the interactive nature that can come off the back of that, off the back of layering.
Thank you. Okay, last call for fun or interesting or just any use of Python outside of health and care.
You can do 3D modeling with like Blender and Python.
Thank you. There might be one at the front.
You said fun, so I'm going to go for a fun one.
Brilliant.
My son and I use Python to write an automatic Nerf gun using a BBC microbit. That was lots of fun. I'll show you the video.
Okay. We're not going to be beating that anytime soon, so let's... Oh no, we've got a contender.
Of course, you can use it in Lego robotics along C as well, but definitely Python is very easy.
Nice. Okay. the one thing I found on my quick search of the internet was NASA's use of it, which is pretty cool and fun and amazing and all those kind of adjectives. Particularly with its program to put a rover on Mars. I believe it put stuff out on GitHub to the community, and they didn't realize they were doing it at the time, but they were helping to write a program for the drone. And then upon the successful use of the drone on Mars, the next day, all these people on GitHub had a special badge appear that they didn't know about that said that they'd officially helped put a drone on Mars, which I thought was just amazing. Okay, thank you very much for your indulging me there, and I definitely learnt some things about Nerf guns that I will not be telling my 7-year-old boy. Okay, so present day, we've got a lot of stuff going on in data and analytics, in health and care. It's a beautiful time to be alive. We've got Python being used in Nerf guns and putting drones on Mars. So let's think a little bit more about the future for the last bit of my talk. And I guess where I get a little bit more serious, really, because the future holds, I think, probably all kinds of things that almost certainly are going to be involving an awful lot of Python. It got discussed a little bit yesterday, if you were here for the R Day yesterday, but the Goldacre review has all kinds of stuff in there about reproducible analytical pipelines, the use of secure data environments, trusted research environments. And we've also had legislation put in train to establish the integrated care boards, integrated care systems, and within that the expected use that they will use data collectively across their patch to do things like population health management. And taken all together and based on where I sit in NHS England, I think reproducible analytical pipelines, they are very much here to stay. They are very much the future. They are going to happen. The use of trusted research environments and secure data environments, again, those policies are already being published. They are happening, and in both of those cases, Python almost certainly is going to be at the heart of doing that well. Already we see in Open Safely the need to use both R and Python to use that TRE effectively. And I think the more that we link data up in ICSs and ICBs, again, the more there is options to really learn about important behaviours and relationships and patterns longitudinally across a population that can genuinely make huge differences to what we know about the planning of whole health and care services, but also for individuals' health as well. And so it is genuinely a very exciting time, I think, to be part of the NHS Python community. So number one, congratulations for being sat in this room today, and number two, it's just very exciting what the future may hold in terms of reproducible analytical pipelines, secure data environments, ICSs, population health management, the move to a more digital profession, the use of open code and RAP in data science. Again, data science and data scientists, their numbers just continue to grow and grow off the back of the Goldacre review. On behalf of Ming Tang as the Chief Data and Analytics Officer in NHS England, I am leading the setting up of an open code and a reproducible analytical pipeline oversight group with members from this very good audience, and also looking at various parts of the commitments to the profession in Chapter 1, which also relates a great deal to how data science, open code, open analytics, and reproducible analytical pipelines get delivered. So it is genuinely, I think, a very, very exciting time for us all, and I'm really looking forward to the day ahead and many more of these types of events. So happy to take a few questions, but I will leave it there. Thank you.
Thank you so much, Sarah. Hello? Great. Thank you so much, Sarah. What questions do we have? Does anyone have any questions? Yeah, okay. Tiago, did you have a question? No? Adam?
What are the main hi, I'm Adam, NHS Digital. What are the main challenges that you see for sort of implementing RAP on sort of like a trust level, and how do you think we're going to overcome those?
I think the challenges to implement RAP at a trust level are basically the same challenges to do a great deal of the kind of data science, open analytics type things that we talk about. And the GDS, the Data Science Accelerator, talks about, and I always remember this, it's a very nice way of thinking about it, the 3 T's, tech, time and training. And I think that applies in so many cases and particularly applies here. What can we do to actually get the right tech to colleagues' interests? What can we do to actually give them the right training? And specifically with training, that isn't necessarily about sending people on courses, because in the Data Science Accelerator, you don't actually get sent on any courses, but what you do get given is an appropriate technical mentor who is always there for you, who will always ask you questions, who's done these kind of things before. And that is a really hard challenge, I think, in trusts, to get that kind of technical mentoring in place. So the tech, the training, and then obviously just the time to actually do something that's not necessarily going to work, that is going to be harder the first time. My example of using pandas, it was so much harder than doing it in a spreadsheet the first time, to the point where it's almost, too much of a high barrier to entry. And many people will, if they haven't got that time and they don't feel the confidence to take that time, just won't bother. And so I think, those 3 things together are really what we need for the actual analysts themselves. That in isolation also isn't enough, because you need the wider thing of actually senior managers seeing the point in this, seeing the point in investing in the time, the tech and the training as well.
Question at the back.
Okay, so sort of off the back of that, and this isn't overly a question, but feel free to respond. How do we make sure that when we are demonstrating our work and giving examples, we're pitching it at a right level that invites people to use it, but is also professional? So when we put the examples out, we've spent a lot of time developing them into really nice tools, but actually that then looks like quite a barrier to a new person at times. So what's that sort of level of sharing really good quality stuff versus sharing stuff that people will be actively ready to just engage with quickly?
When you say people engage, just to be clear, are you meaning other data professionals to take the work and use it, or you mean senior colleagues to think that's good?
No, more other analysts across the NHS, more data scientists, anyone who's actually going to use the tool.
So, for me, the ability to actually very easily explore under the bonnet before. I think it was one of the talks yesterday. One of the clinicians said, "Give a man a fish, and he'll, give him a rod." And it's a similar thing. If you just give them a finished product and go, "Isn't that great?" It'll, they'll think that's nice for 5 minutes. But if you can in any way help people to see under the bonnet more easily, that is when it's much more easily used. So there's 2 things there really. As we were talking about yesterday, it's not a novel idea, but how you actually annotate your code and actually how you lay out your code is a huge thing to allow people to follow it. And then number 2, and it's like you've planted this question, Johnny, but you genuinely didn't. You actually need some kind of almost dummy data that you can then use alongside the tool, like synthetic data that can then be plugged in alongside it, so that you can instantly see, oh right, that goes there, I see how it works, I can now see how my own data could potentially work with that.
I've got a...
Oh, there is one more question.
As a clinician, I could add to this last one. So one way how to make it easy is to put out variables that you will allow the user to change into a properties file or some form of text file that they can easily change without being intimidated by the code. Dummy data is extremely important, and you should have an easy method. Let's say you are kind of analyzing something of time value. You should have an easy method how you can update this dummy data for data to be today's data. Basically move all the data kind of from last year to today. because it's very, very convincing. And then if people run some visualization, and if they have changed some data, it's extremely impressive that they can see the immediate changes.
Thank you.
I've got a question from online. Could I have the mic, please? Thank you, Pete. So somebody asks, how can a junior data analyst sign up to the data science mentorship to help learn more about the subject?
Well now, so I know we're in the Python room, but I think we are friends enough with the NHS R community that we're allowed to also plug their stuff. And I believe that they have a mentorship scheme that's about to get up and running. I think the Analyst X, as I said, the Machine Learning Mondays and their data science community is a great place to go. All the different Slack channels for Python and R are a great place to, number one, pick up hints and tips, but number two, from that, you will probably realise who's going to be being the most helpful and perhaps worth also sort of following up with further questions. Obviously, apply for the Data Science Accelerator if you really want to go that path. As I say, it is very much open to people that work in health and care in the NHS. And then finally, perhaps not quite a mentorship if you're already a junior data scientist, but probably worth being aware of the fact that we, within our unit, run by Johnny and also supervised by Dan and Paul, have a PhD internship scheme for data scientists who are currently studying data science like PhDs, and this is a great way to come in and understand a bit more about actually how the NHS works, the data it holds, and from our point of view we get the absolutely fantastic skills from academia for a flexible placement, and in that respect the relationship is such that they get the mentorship of one of our senior data scientists. But in return, I think it'd be fair to say that our senior data scientists often learn a lot from our student placement, so it's a really mutually beneficial kind of arrangement.
So we're going to take a break until 10 o'clock to just set up the panel, so feel free to have coffee until then. Thank you very much.
Mary, just to point out, 32 minutes. Oh.
Need to run this script, whereas if I give it a text file with specification,
I just remembered the W in this change the value of V.
change the probabilities, add some, make these records the same.
I'd forgotten that.
Some natural language stuff.
So more usable.
Yeah, the barrier to entry is just so much lower. The adoption is
Definitely.
so there's definitely a challenge in throwing
And to be honest with you, this is certainly the future. I don't know if you've seen some libraries like GPT-3, and so those are some Python libraries for natural language processing. So on GPT-3 there is a paper where someone built a whole system and the database out of AI. So the person just typed what it needed, what it required, and then the code was completely automated, because essentially coding is a series of repeated tasks. So there is little creativity in the code itself, the creativity is in the algorithm, you see.
Yeah, but it's that debate, Copilot, Copilot?
Yeah, exactly. Yeah. I agree.
It's like,
I agree.
It's the machine learning really just regurgitates the code that someone else wrote without attribution, without any sort of respect from the licenses. So there's a minefield.
Yes,
it's a bit like with AI generated images, like the artist community is very much against it, because it penalizes the maybe junior artists that denies them the entry into the industry. Right? Because you can just
Though we disagree with Mark, because there's a difference in terms of you could compare that as automating car creation or car engineering they're slightly different because the arts has the artistic component. But what I'm saying is, because of that, instead of going too deep into the code details themselves, we could make a more interactive software, interactive solution, just as you say, a higher level interaction. That's essentially the reason why a lot of people prefer Python to C or C++.
With kind of governance changes across the NHS,
exactly. C is 100 times stronger, and you can do so many more things with C and C++, but it's less usable. So that's the reason why Python wants higher adoption. So maybe if we could even go to a higher level,
so that we can spin up
both Python having
over the
automated
next
scripts,
It's almost like because I would like to have it so that the process can run last summer is an annual thing. So we just keep on getting input on it, we keep on having a public consultation on it.
Exactly.
Yep. And then every
and
year,
it's quite
if
similar
there's something
to
substantive that we can make a change
those
to,
pivot tables from Excel as well, and those tables that people like to use a SharePoint or those automated Power BI,
so that's
which
a
is
very big conversation to have.
glitchy, but people like to use Power BI simply because it's so much easier.
Drag and drop.
Exactly. So that's where I see code going in this automation.
The issue with
so I'm not going to talk about
That's right.
But
should I test? Is it working?
website
Looks like
that Sarah
it.
mentioned
Good.
earlier,
Thank you. Thank you.
I've tried to ensure that there is kind of strategic engagement with large-scale NHS products
and
to try and make sure that some of our big flagship headline things become open source. And although I've not said so specifically,
I love Power BI because I work with Tableau quite a lot.
So, although I've unfortunately not been responsible by Kevin Murray, which is kind of good, but I've given him much to do.
Heavily the self-analytic.
Well, I was saying, like, there's an idea of like, why do people? Because so I've had this idea.
Can you hear me now? Yeah, the mic. It's the mic.
have thought of developing. Whereas the more people use that and high levels of abstraction that can help with that.
Hi, Pavel. Could you just test?
Test, test.
Awesome. Thank you.
Okay, everyone, we're going live in 5 seconds. So 5, 4, 3, 2. Great. So the next section is a very, very interesting panel talk. It's going to be chaired by Sarah Cooking. So Sarah, I'll leave it to you. I think to ask questions to Pavel, you need to use this mic. So that's just something for you to be aware of.
Okay. Brilliant. Okay, thank you. With the three of you sat there, it is giving me kind of blind date kind of vibes, but you know, we'll move on from that. And apologies to anyone a lot younger than me that doesn't know what I'm talking about. Okay, brilliant to be here. We have a fantastic panel lined up. I'm going to ask them to introduce themselves properly in a minute, but we have Pavel Orzechowski joining us live. Is that, have I butchered your name there? Brilliant, fantastic. Andrew Harding and Tiago Viana. So first to introduce themselves, let's go to Andrew, please.
All right. I'm Andrew Harding. I'm the Open Tech Lead in Transformation Directorate, the body formerly known kind of as NHSX. And in theory, that's a strategy and governance role in the main. So I'm kind of tinkering behind the scenes, trying to make a better environment for sharing open code in general. Basically, my mandate is let's try hard not to buy the same thing twice if we can avoid that. Luckily, though, I also happen to be an analyst. Specifically, I'm a physicist. But the problem is, when you train as a physicist, they lie to you pretty brutally. Firstly, they tell you that Fortran's the best language on Earth, which clearly it isn't. And secondly, they tell you that you're going to be doing physics when actually you're going to be doing statistics most of the time. I'm a thermodynamicist. I'm going into climatology. That's what my doctorate's in. But you wind up, again, lied to, because most of the good work in climatology is actually in policy, not so much in the science. There's enough much better scientists than I am, but not very many people who can do both science and policy. And that's why I wound up in government support. I've been through the Canadian government, the Scottish government, the UK government, regulation. My last gig was for a little thing called the Centre for Data Ethics and Innovation, which you might know about from their algorithmic bias report. And over the course of the last couple of years, I've been trying to formulate an open source policy for the NHS, and a couple of other things that undoubtedly we'll talk about over the course of this panel.
Thank you, Andrew. And Tiago, to you next, please.
Yeah, thank you very much, everyone. My name is Tiago Viana. I am a senior lecturer at the University of Gloucestershire and probably an intruder here, because most people are from health or NHS or areas related, but hopefully a good intruder. My background is in software engineering, computer science, software engineering and programming, security, privacy and security, and quite recently in health technologies, especially in network security for healthcare. I have a couple of papers and research projects in the area in terms of using zero trust in the healthcare, which is quite challenging but super, super interesting, as well as data and machine learning, data analytics for image recognition, for cancer as well. We recently published a paper on using AI for early stage cancer detection as well. At the University of Gloucestershire, we have recently started a master's in health technologies, which one of my colleagues, Mark Bailey, is here as well, and as part of the program where we are working with the local NHS in Gloucestershire to build projects. So this is a 100% project-based course, so no lessons. It's here's a problem, what do you need to learn to solve this problem? Let's solve this problem. And then we use Python, we use R, we use so many other technologies that we would think that is interesting and relevant for the area. Also the courses for our digital forensics course. So I have some forensics background as well. Been working, I'm from Brazil, so really looking forward for the World Cup, where hopefully we're going to get this one. But there you go. Been working for 15 years or so in industry and academia, in Brazil as well, and in the UK with different organizations, industry and academia. Have been lied to many times as well. I've realized how many things are different from academia, industry, and quite recently the NHS. So we're finding how things are working differently. But here we are, happy to be here in this panel. I'm really looking forward to interacting with you all.
Thank you very much. And finally, to Pavel, please.
Right, let's check if you can hear me first. Can you hear me right?
We absolutely can, yes.
Oh, awesome. Thanks for having me, sir. Hi, everyone. Apologies, I cannot be there in person. So my name is Pavel Wojciechowski. The name is long in Polish and it means walnuts, but it's unpronounceable if you didn't have luck of being born in Poland. I'm a lecturer of programming in business school of Edinburgh University, but also recently I've been lecturing in the med school here, and in literature and in politics, and I'm lecturing Python. So basically what I'm doing is I teach Python to people who this is not their main craft. They're not like coders, they're business people or doctors, nurses, or health professionals that need it as a tool. And what I've been doing over the last few years, I've open sourced, so basically released for free, all of my notes, all of my videos, and all of the code, which is also available to you, and that's partially why I'm here. It seems like that my superpower, my gift, is that I'm quite good at getting people into coding, at getting people sort of that make first steps and start thinking about it as storytelling exercise. Because coding is literally telling a story to someone. All of my notes are on codestorytelling.com, so it's in the name. We'll talk about this maybe a little later. I'm also the head of technical team in Feeling Good app, which is something that Scottish NHS uses, like a well-being audio program. But I'm basically working every day with people in health and in programming, and sort of that's where I find my joy, and hopefully I'll be able to share some of that joy with you all. Thank you for having me here.
Oh, thank you. Sharing joy is definitely something to aim to do. Okay, so we have a few pre-prepared questions before we move to the audience for any questions you have to the panel. And the first question is to Andrew. And it is very simply, why now? So I should provide some context to that question, and just to reiterate that the title of this panel discussion is the impact of upskilling the health sector in open source. So why now? Why use Python or open source software in health and care?
Okay. It's a surprisingly complicated answer for such a simple question, but so the tech hasn't really changed that much in the last 5, maybe 10 years, but the way it's organized really has. So first of all, we've got all of these interesting initiatives around secure research environments and trusted research environments that you mentioned earlier, which gives us a place to kind of build communal code around, which is super interesting and super useful and a lovely place to get involved. Related also to the tech, we've just got VS Code and Git on the NHS England kind of provision. So for the first time, you can actually get straight into it via the medium of NHS England resources, which is lovely. But that's not really the good answer. The good answer is the community is in a better spot than it's been pretty much ever, which is thanks to folks in this room and folks in the next room. That's unparalleled and really neat. The amount of innovation that's coming out of that community is wild. I mean, we've heard some yesterday, we'll hear more today. That's everything from kind of back office, enterprise support, through to ophthalmology, through to everything. There's large contribution into that from academia. So the code that went into Q-COVID came out of risk assessments that was university-based in the first place. And that's been leaked into an NHSD kind of development process, so that is really nice. There's more private support than there ever has been before. So we're seeing stewardship, we're seeing kind of consortium-ready private groups who are ready to help support, and open-ready private companies that are ready to work with us. So Linux Foundation for Public Health, Public Code, a handful of other folks who are ready to go. And we've got Mandate as well. So you line up all of those things with Data Saves Lives, Goldacre Review, which we heard some about yesterday, some about in your talk, our response to the Goldacre Review, which is ongoing and bold and I'm very pleased about. We've got open source policy in draft, which I can talk more about if anyone wants to come talk to me about it. We've got so many examples, which I should plug, open source playbook being published pretty soon. Everything is lining up in a way that it just has not done prior to this.
Lining up is a nice way to describe it, and the mandate is so important. I can see a few people, well, I can see that Pavel and Tiago were nodding on a little bit there. Is there anything you'd particularly like to add to that question? Or if not, we can move on. Anything further to add? Is that a yes from both? Okay, gosh, right, it's good. Our cup runneth over. Let's go to Tiago first, then Pavel.
No, it's the best moment, isn't it? So there is no moment like now. We cannot do anything about yesterday. We cannot do. I know I'm quoting a movie, but there you go. But it's the best answer, isn't it? There's nothing we can do about yesterday but learn, and there's nothing we can do about tomorrow but hope. So we have to do something. I go back to what your lovely slide. If you want something to be built, you need to build it yourself. So essentially, it's the best moment now.
Indeed, thank you. And Pavel?
It's quite amazing that everything I do right now with teaching and with spreading stuff, I couldn't have done 5 years ago. So now it's just this sort of golden moment when the tech and the open source community and everything just caught up. And also things got cheaper. So now you can run things like Jupyter notebooks for free out there. While this used to be prohibitive, you needed a PhD in computer science to do this proper. And now it's just available to everyone. So it's a perfect alignment.
Yes, that's a very good point. We haven't really dwelled on much, but actually just the fact that other stuff is now much more readily available is so important. Okay, let's move on to our next question, which is specifically to Pavel, but again, very interested if others have further thoughts to add at the end. But Pavel, your thoughts on how to start? So what could be the first step in getting going with Python in your experience?
Nice. Thank you for the question, even though it was prepared. So in my head, when I'm starting my people coding, and I must have sort of made my way through about 1,500 students by now in the last bunch of years, you need the resources and you need the environment to do stuff. And by environment, I don't mean coding environment, I mean people around you. So community like this one, it not only gives you the reason to do stuff and a lot of good examples of people doing stuff well in coding, but also it's a sort of motivation. So I encourage my students, but also my health colleagues to volunteer in places, but also go to communities where you can practice. And you have many of these at home. So this is me talking about environment, about people you learn with, about your cohort. Even if you're not within the uni or within a particular course, just having some people like you who are going through the same journey. One of my stories that really sort of brings warmth to my heart, which we need now in Scotland, as you can see, it's raining on site. I teach an MSc Data Science for Health and Social Health at it's purely online, so to fit within the schedule, busy schedules of people who are practicing medicine. And quite often my students show up in scrubs to the 2-hour coding session, and I'm thinking, okay, what can I teach them in these 2 hours that's more meaningful than saving lives that they were doing just out there? So somehow, and yet they come and yet they do it. So for me, the first thing to do for you is or to friends and family that you know, or colleagues that want to start, is to find an environment, a community where you want to sort of do it. And it's gonna be undervalued, like theoretically, people do go to the gym, but theoretically you can do most of these exercises in your bedroom, but nobody does really, do they? So that's one big thing, as far as having the motivational environment around you. And another one is the resources. So you probably all experienced when you were starting your journey into coding that most coding courses are terrible. They're just like unusable, because most coding courses are for people who can already code, and they're written by people who've been coding for 20 years. So it's wild. Like I can't understand it. It's just so beyond me. So it was quite, when you want to start, go for high school Python books. They're just really well written, and they're written for people who really need to be constantly motivated and explain things well, but also very sharp and quick, which all of you are. So start with Python books for high schools, and then basically hop into any Python book, preferably just poking your eyes into different ones. Libraries have a lot of them, by the way, at least in Scotland. There are these sort of online resources like my Code Storytelling, where people try to write programming courses, but not in a particular language. So these are courses that teach you to think like a coder. And this is quite an amazing skill, really. Like, I strongly believe coding, programming happens on paper. Like, programming happens when you make doodles, when you start solving the puzzle on a whiteboard and fridge magnets with your colleagues. The rest is just typing. For typing, you can hire someone to do typing, but programming is where you are. So to start that journey, I really believe start simple, like don't be shy about high school notebooks. Also find a community. When I do stuff, everything I do really with all of my students is we're using a paradigm called pair programming, where I randomly pair groups of 2 humans at one computer, and they basically pass the keyboard around every 10 minutes. I have this gigantic clock in my classroom, and it beeps every 10 minutes, and you basically pass the keyboard around. So think about it to finish this answer to the question how to start. Think about it. Every 10 minutes, you're the person typing, and someone standing next to you is sort of asking you questions. And then in 10 minutes, it's them who's typing, and it's your role to be like their navigator. They're, like angel and a devil in a cartoon sitting on your shoulder. So that's type of metaphor where you basically, you need someone to talk to, really, because programming is a community experience. It's a storytelling that you do with other humans. The final thing I wanted to say about resources, it's not just about books or videos or courses. It's also about the coding snippet, that's coding examples, and obviously the internet is full of them, but you need to run them somewhere. So this is something you might have experienced in the very beginning, especially when you're working like most of my students on NHS computers, where you cannot just install Python on your computer, because at least the ones I work with in Scotland, it's all blocked. You cannot just install stuff. So finding environments where this can happen online through the web browser, you do need to be online for that, but you don't need to install stuff, and that's basically the Jupyter notebooks things. So find other people and talk to them how they started, how do they run their code, what are the books or podcasts that they listen to, and hopefully that's going to start you. But be aware that starting with a programming tool, you have 80% chance it's going to be unusable. So just sort of keep in mind that the programming books will be useful to you once you know how to program, but the initial steps are all about joy and community. I hope this answers a little bit. I'm imagining that other panel members are also nodding and have something to chip in, and I wonder how everyone else started in this one.
Well, exactly. I was just sat here thinking I'm really meant to be hosting this, but can't. I feel like I need to give my 10 pence worth too. That was really interesting, and I think will probably resonate with a lot of people in the room about actually you pick up a textbook and it's just impenetrable. The idea that you can just start small, and for me, it was actually just trying to reuse the code that someone had put on a blog post for my own purposes and actually reuse someone else's code rather than start from scratch is definitely a way forward. you mentioned, of course, that a lot of people, and again, this will resonate in the room, will have struggle getting Python actually installed onto their laptop, and therefore online is better. Do you have any specific online sites or tools that you can recommend?
Absolutely. So I'm quite lucky that I'm within one of 5 or 6 unis in UK who have access to this online hosting environment called Notable. I think it was originally built in Edinburgh Uni, and now they're sort of renting it out. If you gather critical mass of people who are within NHS have subscription to it, you probably will be able to get it. So that's Notable. There's a bunch of online platforms that start being free, and inevitably within half an hour, within half a year of existence, they introduce paid tiers, and within a year of existence, they stop being free. So it's often about changing what sort of platform is currently free. I always update it on my Good Storytelling blog, so there's always a link to which one is free right now. I think Deep Code or Deep something is the one I'm currently recommending to my students. But what's really nice, if you manage to gather a bunch of people and share either a resource or even a subscription to something, or to get your organization to get you it. I hope that helps a little bit. So basically, I'm trying to always have what's the currently free one, and I'm absolutely in love with Notable.
Brilliant, thank you. Okay, Tiago, Andrew, anything to add, or any sort of thoughts on your intro to Python? Tiago?
Yeah, no, it's great. I mean, this is one of the things I agree a lot with you, Paul, which is coding is about solving problems, right? The rest is a language that you're using, the same way as you can say the same thing in Portuguese, in French, in Japanese, in wherever. You can say the same thing, so the same idea will be there. You asked, we all brought ideas on what we can do with Python, and everything that you've mentioned we can do in R, we can do in Fortran, we can do in assembly, we can do in C, we can do in C++. Some will be easier, some you're going to want to kill yourself because it's super hard. Some will be more complex and so on, but you can do anything. Having the idea is what matters, and we are in a room full of incredibly smart people, intelligent people that will certainly be able to do whatever you want to do in programming. So just don't be afraid. You literally can do anything. You can start from wherever it works for you. At the university, we work a lot with project-based approaches, which sometimes is much easier because we have this disciplinar approach, which sometimes doesn't work because let's learn just coding, let's learn just database, let's learn just this. And then the problem is, okay, how do I put it all together? And ultimately, the word is not disciplinar. The word is multidisciplinar. So sometimes it's much easier to learn when you have a project. This is what I want to build. What do I need to build this? The solutions here is in my head. I know exactly what I want to do. I know exactly how this is going to work. I know exactly how this is going to behave. I just need some way to put it into a code. How do I do it? And it's a nice way of starting as well.
And Andrew?
I'm going to disagree just a tiny bit, which is that just like spoken languages, programming languages give you a way to see the world, and Python is a great way to see the world. It's a great one to start with. So my first point of this is like, do start with Python. It's great. The spirit of Python is very much, there must be a way to fix this, and that's lovely. Whereas the spirit of Fortran is, let's hit it with a hammer until it breaks, which is not so good. That's thing number one. Thing number two, if you do not have any peers to talk to around your coding, although that is obviously the best thing to do, absolutely, not least of all because a lot of documentation is terrible, the rubber ducky method is my favourite thing on earth. You can have a little inanimate object on your desk, and as long as you explain what you're trying to do to that object, you will then understand it, and you will be a better coder for it. I have a little Pac-Man ghost on my desk that I explain problems to, and then that helps me with that stuff. But the last thing is, please don't contribute to the problem. As you're coding, please make your comments the thing that you're explaining to your Pac-Man ghost or rubber ducky or whatever it was. Because a lot of the documentation is terrible, and the more we collectively try and fix that, the better it will be.
Wonderful. And as we continue the panel, please do also chip in with your own thoughts on how best to get started. I suspect there's an awful lot of insight in the room. But let's move on to our next planned question. I think this is our sort of final planned question, and that is to Tiago. How can universities and the healthcare sector work together?
That's a very good question, and you know, there's so many things university and not only the healthcare, but so many other organizations can work together. We go through research, which is a great way of testing things, of discovering new things, and there are so many projects, so many things that can be built together. KTP projects that will generate solutions, which is great. We have great bright minds in the university, in the healthcare, which can work together. A very good, brilliant example is the example that Mark's going to give in his talk. So Mark was able to develop such an amazing solution, and this was built again with the support of some students. So we had some students who helped Mark, and again, going back to what I said before, all the idea was in Mark's mind, so he had, this is exactly what I want to build, but obviously, you know, in terms of the coding and some of the frameworks and stuff like that, that's when some of our students, myself as well, and other people, we were able to help, and then Mark, alongside those students, were able to build this solution and learn and work together in such an amazing solution, and it's going to be a great talk, I'm pretty sure, about that. So we have placement students, apprenticeships, I think. Yeah, we had the lady here, which I think she is doing or was doing an apprenticeship, isn't it? Apprenticeships, which are a great opportunity. I mentioned the masters as well, and going back to what Paolo mentioned, there are so many levels you can enter, you know, in with regards to short courses, longer courses like a BSc or an MSc. As I said before, the MSc we're proposing is project-based, so you can focus on the project, you can focus on the solution you want to build, and this sometimes motivates a lot of people to get into coding and progress into coding, because one of the biggest challenges that people have with coding is, okay, I know how to do hello world. How does that help me? This doesn't really help me at all. The other thing, obviously, is the different learning styles, which is interesting. Andrew talked about Python as being a good entry level for your experience. Other people would have, you know, different experiences. Python is a good programming language to start because it's very English based. And there are so many courses that the university and universities as a whole can help with, short courses as well. Research, as I mentioned, and projects that can be used in practice. One of the things that really make me sad is to see such amazing projects that students do in dissertations, BSc dissertations, MSc dissertations, PhD theses. And great, we had a Viva, you got a piece of paper, thank you very much. This goes into the library, it goes into the online library. So many good stuff, you know, that are published out there and are used, you know, integrated with the NHS. So in other words, we can work together in so many levels to produce, to build, to test, to work, and just to tick a very important box, resistance is futile.
Brilliant, sorry, that's pleased me a little bit too much. Okay, I do wonder if anyone else on the panel has anything to add at that point. Pavel or Andrew, anything to add on universities working with?
I got one thing, because I think Pavel's going to be a better closer on this. Just that working in the NHS, the one thing that we are in short supply of is time. And I think clearly there's lots of folks in the academic sector who are aching for good projects with good application that can then be used. So I think buddying up with your local university and offering them things that you do not have the time or capacity to work on is productive for everybody. I think it's really useful.
For sure. Pavel?
I really like how Andrew is promoting this idea of delegating. But the nice thing about working with the uni, if you have one nearby, is often they have infrastructure. For example, place who run your notebooks, or some data sets that they have available, or students who just have a lot of time and sort of energy on their hands to work on stuff. So I know this as a person from uni who works with healthcare organizations, but also as, you know, the CTO of that health startup who works with a bunch of unis. It's just a mutually happy work. So it's again just spreading your sort of tentacles and seeing who is there to cross-pollinate ideas with. It's quite nice. I liked something that I think Diego said about you know, why Python, that sort of it reads a little bit like English. What's nice about it, and that's why people use it to teach. That's why it's popular with universities, luckily for you all, us all. Python is kind. Like it really tries to help you. It's like a clumsy best friend. It's this. There's something that people who are trying to use Python for real useful stuff, like this community, but also students who share a lot of things that we have in common. So it would be about finding these things in common.
Absolutely. Good points, I think, on particularly the fact that all these projects get done that could be used, and the data sets as well that are held. Absolutely, I could not agree more. We have some questions and feedback from our online community, so hello out there, everybody watching online. The first thing to say is, I think, if you could make sure you talk up quite loudly when you're answering the questions, please. And the second is a question from Mohammed about security, so people who typically work in the NHS find it very hard to get things on their laptops, in particular Python and open source tooling. Have you got any comments or thoughts on how best to overcome that? Anybody want to go first on this one?
That's me.
Go on, Andrew.
Okay. This is going to be a perennial problem, I think. But the way that the NHS is restructuring at the moment, I think, offers a helpful avenue there, because although at the moment it's very much a question about proving the point. I think Johnny said yesterday about proving the point to your local kind of IT support team and making sure that they understand what it's for, and that will help to get the right tools. I think when we have more kind of place-based, region-based cohesion around how things are structured, that will help us make those points, those justifications to larger groupings of organizations at the same time. So hopefully we're going to be in an increasingly good spot where we can communicate to the folks who are in charge of various security protocols of this kind, that this is, that we're doing these things for good reasons, that there's huge amounts of value to get added for this stuff. We can get increasing buy-in from senior management that can then help work that around. So yeah, I think things are improving on that front. There's a second part of this question, I think, which is what do you open and when? And good modern coding practice is definitely to modularize your code. So we can start with the things that are less contentious and move into the things that are more contentious as and when it's appropriate to do so. So obviously you should be keeping your secrets and your keys and all your credentials kind of not published. That would be a dramatic error. But a lot of your processing work, a lot of the analytical work, a lot of the algorithmic work that you're going to do, that absolutely you can open up. It doesn't pose a security threat under most circumstances. Thinking about the one thing that's maybe an exception, which is counter-fraud work. But yeah, I think we're in an okay spot and it's getting better, and part of the point of justifying ourselves to folks who are in charge of our security protocols is that this can be progressive, it doesn't have to be all at once.
That's quite a good one, especially because one of my areas of work. I think one of the benefits of using Python and open source is this, isn't it? Because when you do it open source, it's thoroughly tested, it's thoroughly understood, it's thoroughly analyzed. So if you have a solid open source solution which has been properly tested, this should provide a bit more of confidence to implement it in the NHS. I go back to the university as well as a good test bed, as a good environment to test as well, and to work with solutions and make sure they are safer. I give an example of software that it's being produced. People are getting a lot of money because of that, which is a lot of people is afraid of some Python libraries because you don't really exactly know what's happening in the background. And there are some new solutions being built to abstract security for you. So these solutions would be interacting with the libraries and your code to ensure that no security threat happens in this interaction. Because sometimes your code is safe, but maybe the library that you're using is not so safe as you would like to be. And it is possible to have this bridge in between to abstract it. And this is the beauty of Python, isn't it? it is a more abstracted solution, which is interesting.
So can I just add one last?
Go on, then I'm going to go to
Just
Pavel.
very quickly, also helping this is we've got a bunch of national level policy and guidance coming out,
Indeed we do.
which you can very merrily put under the nose of your local IT team and
Yes.
point them in that direction. So just a quick plug.
That coupled with, I was going to say, sort of previously successful, for want of a better word, business cases that have been used in similar organisations. IT, IT are ultimately, quite rightly, very defensive. They don't want to be the ones that are told off for doing something terrible and putting the whole system at risk. So if they can see it's been done somewhere down the road very similarly, they all of a sudden are a lot more reassured. If it's coupled with national policy as well, definitely helps. You've already given us a lot of good thoughts on this, Pavel, but anything further to add here?
Yes, actually this is something I'm super passionate about. It used to be the case that security by obscurity was the way we did security. Hide your money under your bed. That's how we did it. And now you're thinking, actually, when it's out there online, if you do it properly, it's safer than on your own laptop. But what fascinates me with the security and sort of accessibility element of the data, you all probably know Shiny apps, right? That amazing thing that our people in the other room have. And you probably heard that they just released Shiny apps for Python, which I'm so excited about, and I'm just in the process of writing a course about. But it's this idea that your data and what the user sees are divided completely by this firewall of impenetrable sort of access. So you can show what you built, you can show graphs or whatever, but a person will never see the raw data of your patients or GP practices or whatever. So it's like Andrew just said, people are creating infrastructural wastes. So even if you do something very, very silly by accident, it's still not going to leak your data because there is this sort of very clear division. And I strongly believe doing it online is the way to go.
Brilliant, thank you. Okay, let's go to the in real life audience and ask if there's any questions for the panel, please. Are you?
Thanks. So we've talked about the impact of open source on upskilling Python. I'm thinking in terms of building in open source and maintaining. I don't want to say funding, but who are the maintainers? Should it be owned by certain people? And how do we do this? Any thoughts on this?
That's a very interesting question. I think we could go back to what was said in terms of you are all so busy and having the support, and I believe the partnership with universities can help a lot. You see, you have, as I said, placement students or undergrad students, postgrad students. We even have now the bootcamp programs, which are quite good, and we have a lot of people coming from so many different backgrounds, learning Python, learning coding, and so on. So this is a good opportunity, again, to interact. Obviously, personally, I believe that the NHS can also have a group to work with that. The clinical informatician has to be, in my point of view, a core job, a core career within the NHS. There is so much universities can help, certainly, but ultimately I also believe in that.
I mentioned stewardship and why now? It's a real hot button topic in open source right now in general. We've got a couple of things really helping us out there. The first one is that this is NHS Digital's bread and butter. That it's really, we're going to spend so much time doing maintenance, doing update, doing kind of quality control as things get renewed and updated. So we've got so much great practice to learn from. GDS, pretty much the same, and they've published no end of material on how to do that right. So we've got some really good experience on which to draw. In the public domain. In the private domain, we see a handful of large-scale organisations that are really stepping up into that space and having those conversations with us. So it's a timely question, thank you. But I think we do have the expertise and we do have the infrastructure to draw on.
Pavel, anything to add?
Just a quick one. So, I'm maintaining the open source project that I started, so I know how it works. It's a little bit like having a tree or a bush, you know, in your garden. You really need to trim it, you need to prune things. So it's important to have a core team of people who maintain and manage something. And one nice way to get involved is to help these people, even by finding typos or stuff. So I'm not sure if I answered the question, but it was like about who should own, who should run the NHS or other open source projects. The answer is you just find a way to get involved. I'm not sure if NHS projects do that, but some open source projects I donate to them, literally, so they can figure out what's the best thing to do with their money, even if it's buying coffee. But yeah, we all maintain these projects, even if it's indirectly.
Thank you. And I think there was another question from Mark. Go ahead. Red light.
Hi, can you hear me?
Have you got a red light on?
Yeah, can you hear me now? Fantastic. Thank you so much. It's been a fantastic panel. I've learned so much. I hope other people online learn from this. I want people to watch this later from the recordings. I'm going to say something today which I've been shunned for in my trust.
Oh, gosh.
I love open source. Now, as a clinician who codes, I get shot down daily for saying that, if I did say it daily, but I have been shot down many times online in my trust and so on. I just want to say that here because I feel that this is the right place to say it. Now, this leads me on to my question, which is, may I point it towards Andrew and break protocol towards Sarah as well. I know you're chairing, but I would love to hear your input on this. I love open source. We should do open source. You've talked about policy. You've talked about waving it in front of, you know, senior digital people in trusts. My worry, and something that I see, is there's a lack of teeth behind it. And we're putting lots of money into proprietary systems, £360 million towards Palantir, if I may say that in front of all these data scientists here. £170 million for an EPR in St Thomas's, 12.2 billion pounds for National Programme for IT, all proprietary systems, you know, no open source, very little that we own. How are we going to have teeth behind making open source happen in the NHS? Thank you.
I feel like I should take that one first. This wasn't part of the planning. No, I'm joking. I think I absolutely do see what you're saying. Just put that one out there first of all. On the other hand, there's open source and then there's open source, right? If we're talking open source in terms of using R, using Python, using reproducible analytical pipelines, using TREs, using GitHub, I think that's all what I would call open source. And the expensive platforms that you talk about, I'm not going to personally comment on because that is so far above my pay grade. But what I would say is that actually within all of that, that money is being spent. I genuinely believe that within all of that there is actually the infrastructure being built to do open source and work openly within that. As I said in my talk, the move to reproducible analytical pipelines and the use of TREs like Open Safely, that absolutely relies on the use of Python, R and GitHub. And the platform that we've talked about and the ontology behind it actually brings the infrastructure, the cloud infrastructure, the data curation to actually get going with some of those things. So yes, the stuff itself costs a lot of money, but I would actually like to say that it would, in the end, support the use of open source. And open source doesn't necessarily mean free. It just means open. So yeah, I think actually the two work quite nicely together and can do and should do. Andrew.
Yeah, okay. I think I'm gonna try and take on this second part of that question, because although if it's above your pay grade, it's very far above my pay grade. Nonetheless, within the public domain, the thing that you do that gives things teeth is make statements publicly. You say this is true, or we're going to do this. And as organisations change or ministers change, those consistent statements are your North Star, the things that allow you to keep on doing work I would direct you towards Data Saves Lives, which is the data strategy, which you're nodding, so you clearly know what it is. Within that are a series of public commitments related to open, and while other things may change, those statements are in the open, and we're publicly committed to, accomplishing those things. That process by which we come towards those commitments and we act them is ongoing. We're engaged in it. We will continue to be engaged in it through this year, next year, hopefully the year beyond. But yeah, look at them. They're pretty toothsome, I think is maybe the right word. They've got some great potential in them. We're working on replying to them as fully as we can.
Yeah. And a policy, as you say, is only as good as it gets used. It's that ultimate kind of, can be used, I think, as a bit of a catalyst. It can just, sit on a shelf and go, that's lovely, or depending on who gets hold of it, it can be that little kickstart to get going. And this is a personal opinion now, but I think there's something to be said, a little bit like the badge that I put up. If you want to do something to exist, maybe just make it exist, and once that thing exists and it's doing good and it's helping, it's really hard to put it back in the box.
Yeah, I also think that it's all about the community, isn't it? Because open source is community. So if everyone's working together, building strong solutions, that's the power of open source. If you go to Linux as an operating system, it's one of the safest operating systems, or some of the safest operating systems are Linux-based, so they are open source-based. So you can make it very secure, very reliable, strong, fast, as a community. And if I go back to your presentation, and Sarah as well, if you want something, you build it. So, as a community, good examples, good case studies, things that work well, have the potential to change the world. So, ticking the box again, you've built the enterprise. Now, 5 years to boldly go where no one has ever gone.
I'm just going to plug off the back of that again, because I can. Within hopefully the next couple of weeks, if not the next couple of months, we've got an open source playbook coming out. You folks might be familiar with digital playbooks thus far. Generally speaking, they've got about 12, like a dozen or so examples of them. We've got 16, and there are lots that we couldn't include because they're just starting up now. Those examples of really innovative, really great open source work are there. We're promoting them. We're trying to kind of convince people that this can be done, that it's being done, that it has been done. Once you've shown a thing can be done and it's done well, it's hard to put it back in the box.
Indeed it is. And that is actually us at time. So I want to thank all of my panel members today. Any final sentences to wrap this up? Pavel, I'll come to you first.
Right. I'll use my final sentence to answer the previous question, but it really encapsulates what I wanted to say. You know how you try to ride a donkey and you have a carrot and a stick, you want to get your organization to use open source or use Python, but one thing you also need to ride that donkey is the road and the road signs. So finding the environment of people who help you. Like I couldn't do my stuff if not for the support of main library of university and the amazing people in it. So it's not just carrot and stick, it's finding environment in which you can ride that donkey and you know where to go. That's my main message. Community.
Absolutely. A lovely way to end that. Any final words from Tiago?
Yeah, no, I think that's it. So we're here, so the universities around the UK are here to help. I'm sure all of them would be more than happy to interact on education level, research level, building projects, building products, and again, going back to what Andrew said, the moment you can show that something is safe and secure, works, then you have a good case study to go forward, and that's a good thing to go. One thing that came to my mind, which is getting started, and you talked about the security and installing things. Another open and web-based platform that you can use is called Replit. Don't know if anyone has used Replit. You don't really need to install it. Jupyter as well has some online thing to work with. So we're here to help. By all means, just get in touch, and it'll be a pleasure to help.
Wonderful, thank you. And a final few words from Andrew.
I'm going to bring it back around to the top. Now is the time. It really is.
Wonderful stuff. Thank you very much again to my panellists for taking part, and thank you for your questions.
Thank you so much for, can you hear me? Yes. Yeah, for a great, I could ask any panel members to just go to the back to just take off their mics. That would be really, really helpful.
Hello, my name is Adam. Can you all hear me? I have 30 minutes. I want to help you code faster and better. So I'm here today to talk to you about Visual Studio Code, which is a code editor, as many of you probably know. It is popular because it is fast, because it is full of features, and because it is open source. And a consequence of that is also that it's been extended a lot, so there's a lot of publicly made extensions that help make Visual Studio Code a lot better. Visual Studio Code is the most used code editor amongst Python users, according to a survey by the Python Software Foundation. You can also trust this survey because the survey was actually done by JetBrains, who are VS Code's competitor. But, you know, I don't want this talk to be just about VS Code. I hope today that you learned something new about Python, or about Git, or about testing. And there'll also be a hidden message sort of deeper below all of this technical stuff that I hope that you take away too. Let's get into how this is going to work. Most of the rest of this talk will be a big, long, live demo. I'm going to chuck out a lot of ideas at you in the next half hour, but I'm not going to be able to go into depth about any of them. The idea is to introduce you to a concept, and then you'll be able to go research it in your own time. There's concepts for everyone, hopefully, for beginners, for more advanced users. In order to make it easier to digest everything that I'm saying, there's going to be a big text explanation of what I'm saying on the screen here. And you should also be able to see the keys that I'm pressing to do everything in the bottom right of the screen, sort of here. And with that said, let's get going. Would it be possible to get this mic working, just because I'm going to need to type? So. Right, okay. Wow, okay, cool. Let's get going. Okay. In the NHS, we innovate, you know. When we face challenges, we make it work. Okay, so I've got Visual Studio Code open here. This is what you'll see when you open it up for the first time. The first thing that I want to say is just on the right here, there's a bunch of tutorials, and actually they're really good. So don't skip them. You can probably learn a lot of useful keyboard shortcuts. Highly recommend. But let's open up a project in Visual Studio Code. You work in projects, which are in folders. So you can open up a folder many ways. You can just do the normal like file, open folder thing, or you can press Control O. I'm going to go to the recent tab because this is a folder I've opened recently. Now that we've opened up a project, let's get oriented. On the far left pane of Visual Studio Code, there's many sort of useful views. So this one up here is the File Explorer. It shows you all of your files and folders. Search allows you to look for text in all of your files, and also do things like search and replace. Source control is to do with Git. I'll get into that later. Let me just do that. And run and debug, I'll also get into later. And extensions, I will have briefly mentioned. We'll get into that later. So Let's start with the file explorer. It really encourages working in multiple files, which is good for when you get onto more complex projects. It's easy to create sort of new folders and files. So I've got this subfolder here. I'm going to right click it. I'm going to go new folder. I'm going to say demo folder because I'm really original. And I'm going to say demo file inside because I'm really original. Demo file.py. And you notice that as I create this file, it opens up in this main area. So this is your sort of main code editing area. You can type, you can say print hello, and that works fine. At this point, you will probably want to install the official Python extension. It's like made by Microsoft, and it's pretty essential to working in Python in Visual Studio Code. So you'll have a pretty empty editor without it. I've already installed it to make stuff easy. And when you have that extension installed, it can help you out a lot. So here's like my main file.py. If I go down here, like one thing the Python extension gives me, if I hover over this function here, it will show me the docstring, and it will also show me sort of like the parameters and stuff like that for the file. And I can do things like if I hold down Control, this sort of function name becomes a link, and I go through, and it takes me to the function definition. Which is really useful when you are getting more complex projects. It can do things like show me variables I haven't used. So if I say middle name equals Joseph, because that is my middle name, it will sort of show up in this gray because I've defined this variable, but I've not used it. So middle name is not accessed if I hover over it. It will show us syntax errors. So I have taken away the closing string, and it shows up in a red underline. I think that's the minimum we kind of expect of a code editor, that it shows you syntax errors. It can auto-complete functions from modules and also methods on objects. So I'm gonna say random here. This is going to show up with a red underline because I haven't imported the random library. So I'm going to go up here and import the random library. And I can do random dot, and then if I start typing like randint, it's showing me all the methods that start with RAN. So I'm going to use randint, and I start typing, and now it's showing me the docstring again because it's really useful. But it's more than that. So, you know, Visual Studio Code is actually clever enough to know that this fake input function returns a string. And so I can, because it knows it's a string, if I do first name dot UPP, Visual Studio Code knows that upper is a method on strings, and so it's able to autocomplete that for us and show us the docstring and do loads of wonderful autocomplete type things. I'm going to take that out though so it doesn't break my tests. While I'm here, just want to briefly mention that down here on line 32, I'm using a thing called an F string. This is the cool, new, and best way of inserting variables into strings within Python. If you don't know what they are, just recommend that you look into them, Google them. They're super simple to use. Now that we've seen sort of what we can do in one file, I'd like to talk a bit more about working in multiple files. So in this submodule folder, I have othercode.py. I can click on it, and it sort of opens up here. We have various different tabs. I'm sure you guys are used to tabs from things like Chrome. But I can do more than that. If I drag this tab, I can sort of open it on the right here and get this sort of split screen view. It's a bit cramped because I've zoomed in for the demo, but it makes it really easy to work on multiple stuff at the same time. And since I have this stuff that is in another file, I'm going to close the Explorer. So this is in another file. Visual Studio Code is able to understand your file structure, and so I can do from dot submodule, because I need to import it from dot submodule because it's in like this other code is in a subfolder. If I do from dot submodule dot other code, import some constant. See, it was able to also complete some constant for me because it's able to read our own files. And I would like to say that control click also works quite well with this. If I control click some constant, it will take me to the definition in another file, and it will take me to the correct one. And also, Visual Studio Code is smart enough to know that some constant is a string. So if I do some constant.upp, it's able to also complete the string methods. Using F2, well, I can smart rename things. What does the smart mean? So in this example file that I've got, I've actually also defined some constant in this file. if I press F2 or if I right click and go rename symbol, I can rename this to some other constant. And it's renamed it in othercode.py, but it hasn't renamed it in example file.py. That's because Visual Studio Code is kind of smart and it knows where things have come from, so it'll only rename like the one that you meant to rename rather than renaming everything, which is much better than using sort of like find and replace. And so what we're generally seeing here with this autocomplete stuff is this idea of what's known as IntelliSense. Essentially, Visual Studio Code doesn't just see your code as like text. It goes in, it actually understands what the symbols mean, and it can really help you by giving you intelligent selections and helping you giving you lots of actions that you can take. I'd like to take a brief interlude to talk about virtual environments. So let's go here, and let's go on. So in a computer, you have like a main installed Python version, and you might be working on like multiple projects. The default in Python is that your multiple projects point towards your main installed Python version, and everyone's using the same thing, which normally works fine. But like, let's imagine in our main installed Python version, we had Pandas version 7. But oh no, project 1 is complaining because it actually needs Pandas version 8. So we go and we update Pandas to version 8. But now we have a problem because project 2 actually needed version 7, so we have this sort of incompatibility. The standard and recommended solution to this problem is to essentially create a virtual environment which is like a copy of Python that lives inside each of your projects. And then in each of these projects, you can install the specific version of Pandas that you need, everything works well. For those of you who already know about virtual environments, can I just recommend the tool Poetry? It is better at handling dependencies than pip, and it has sort of like a lock file. It just tends to work a lot smoother and install stuff quicker than pip does. So if you already know virtual environments, check out Poetry. Back to Visual Studio Code. So in Visual Studio Code, we can select our virtual environment. If I press Ctrl-Shift-P, which is a command that's very useful, it shows all the commands you can do in Visual Studio Code. I can select Python Interpreter, which allows me to select my virtual environment. I already created one earlier. Or also, if you're in a Python file, it often shows up on the bottom right-hand corner. Down here, you can see it showing the virtual environment. If I click it, I can select my virtual environment. And once we select our virtual environment, Visual Studio Code will do a bunch of helpful things for us. When we, for example, I haven't installed the package requests in this virtual environment, so if I try and import requests, it gives me a yellow underline and it said it couldn't be resolved, so it gives me warnings about that kind of stuff. But also, when I hit any type of run button, it's going to automatically run it in my virtual environment with those packages, so it's always good to select your virtual environment. It's time to run our code. So there's many ways of doing this. I could click this run Python file symbol, and that would be a very, very easy way to run it. But also, Visual Studio Code has an inbuilt terminal, so essentially a command line built into the program. So I'm in my command line, and I can run Python. I'm going to run it with -m because it uses modules. Modules are a great thing to learn about if you're more experienced with Python, because they're generally a better way to structure imports. But demo VS Code.main, and it runs my spectacular program. Cool. Let's talk about Git, because Visual Studio Code was designed with Git in mind, and from the very base, it's all over. So by default, if you're in a Git repository, it will highlight all the files that have sort of changed. So this main.py is being highlighted in yellow. That's because it's been modified. So it was there before and it's been modified, but that file we created earlier, that's highlighted in green and it has a U in it for untracked. And also I have a git ignore file, which tells Git to not save certain files in my repository. And this git ignore contains the virtual environment folder. And that means the virtual environment folder shows up in gray and isn't saved to Git. Which is good because, like I say, virtual environment contains a copy of Python, and you wouldn't really want to upload a copy of Python to Git with everything else. It would get a bit messy. We can easily manage the Git branch that we're on from the bottom left. So I'm going to create a new branch, and I'm going to call it demo2 because I'm original. And now we're in our new branch, I can go to this source control tab. Here's another place we can see all the files that we've changed since the last commit. And it's very easy to choose the files that we want to save in this commit. This is where you do git add if you were using the command line. So you can hit the plus button, or I can just hit this plus button here to add them all in one go. I choose a message, my commit message, because I'm original. And I hit commit. And voila, I've done the commit. And I can even hit this publish branch button, and it would open up that branch on GitHub or GitLab, depending on whatever you're using. So there's a bunch of extensions that can also add to your Git environment in Visual Studio Code. The Git Lens extension is one of the most popular extensions in Visual Studio Code overall. On the edge of every single sort of line, you may be noticing there's sort of like a faint text that says my Git username, and then it says when I've changed this line of code. So we added this line just now, me 3 minutes ago, but this line down here was added 6 days ago by me. I had a commit and I called it added more files because I'm really great at writing commit messages. So this is called a git blame. It's called that because when the code breaks and it's one particular line's fault, you can work out who wrote it. And it also, this Git Lens extension, it adds some stuff to help you with things like stashing, which is good to know about, but I don't have time to go into now. The Git history extension, if I open it up here, this allows me to see like the history of all the changes that have been made. So I can scroll through it like a sort of timeline. I can see where all my branches are. This is also useful if you're a more advanced user of Git. I'm going to mention that there's a 3-way merge editor, but I do not have the time to like create a merge conflict to show you how it works. But I will say it's very neat and a really great visualization to sort out those tricky merge conflicts that you sometimes get. Visual Studio Code and the Python extension come with a debugger that allow you to walk through your code and see what's going on. So I'm going to put a little red dot here that just shows up when I hover my mouse over here. This is called a breakpoint. It's a place where where if I run this code in debug mode, it's going to stop and let us see what's going on. So I'm going to go to the Run Debug tab and hit Start Debugging. Immediately the code, immediately Visual Studio Code has hit my breakpoint. I can now step through my program one line at a time, and it's sort of running stuff. So if I step over this line, it's going to print your name as full name. On the top left here, I can see what the local variables are. So I've defined a variable called full name, and you can see what its value here. But the really cool thing you may not have known about, if I step into this function that does panda stuff for no good reason other than that I needed to demo this particular feature, I create a variable called Titanic, and I fill it with a pandas data frame. So this local variable here is a data frame. I can right-click it and I can say View Value in Data Viewer. And this allows me to see my local variable in this data viewer format. This data viewer format is great. It allows you to sort really easily through our data frames. I can even filter, so I can filter for Abbott. And this is great if you're trying to debug what's going wrong in a really long and complex like wrap pipeline, let's say. So let's stop the debugger. Visual Studio Code encourages testing. So I've got the testing tab down here that comes with the Python extension. This is showing me all the tests in my project. I configured it earlier. I've got this test main.py. I've just clicked the Go to File button, and it has 2 tests within it. I can quickly run any of the tests in that file, and it will give me a nice green tick, which gives me a nice dopamine hit. I can also run them by clicking on the thing in the margin here. Yeah, I'm using PyTest, which is a really popular library for doing testing in Python. Highly recommend. And in it, you sort of like you make assertion statements about what you want to be true. So this combined names John Doe thing should return John Doe. If I put a space in here, I'm just going to make it fail for people's interest. And you can see I get a really nice message. It's telling me exactly what's wrong in this statement, which will help you if you make a refactor that then causes a problem. It should hopefully give you some really useful information. But yes, let's fix that, and we get a green tick again. Okay. When I was giving this presentation to my mentor, he said that I should put in a little bit of a break because there's just so much in it. So we can all take a moment to sort of. Okay, now I can go back into it. So Visual Studio Code can open Jupyter Notebooks. Pretty simple. I've got a Jupyter Notebook here. I open it. You can see all the cells. I can run the cells. I'm also going. I also want to mention that you can actually see all the variables, your local variables in your Jupyter Notebook. So I've got this Titanic variable, and if I go to the ... and then click on variables, you can also get it down here. I can see the message variable is type string and it's got value hello, and I've also got this Titanic variable which I can open in the data viewer again, which is extremely helpful. Also, Visual Studio Code works super well with Markdown files. Markdown is a way of writing documentation, but putting it within your sort of, a sort of formatted document. It's written as a text file that looks something like this. There's like this hash behind this demo VS Code. But if I right-click here and click Open Preview, you can see that that turns into like a heading. I can also add, say, I can make this text here bold by putting 2 asterisks. And if I go into the preview, you can see that it makes it bold. And I can have this preview and the actual README open at the same time by doing that split screeny stuff, and it will show me live changes. And Markdown works really well in GitHub, so really strongly recommend if you want people to be able to read and understand your code. I also want to briefly mention that there's an extension called the Draw.io extension. If you know Draw.io, it's a tool for making flowcharts. It allows you to edit, this extension allows us to edit the flowcharts within Visual Studio Code. So I've got this flowchart here. I'm going to say start coding. I'm going to change this to say start coding Python. You can see the README has this thing here that references that image. And if we open the preview, now the flowchart has shown our change. So this is a really great way to improve your documentation. So, I've got like 5 minutes left, so I'm going to very rapidly run through these features. Look into type annotations, they're great. Visual Studio Code can't work out what these parameters are because Python's Python, and like it lets you put whatever you want anywhere, but you can actually add these things called type annotations, which have been a part of Python since 3.7, and you can say first name, no, first name should be a string. And now Visual Studio Code can do all that autocomplete stuff that I mentioned before, really helpful with date frames actually. But also if you turn on type checking, which is a setting, if I put like 5 and then hi in this thing, it's going to red underline my 5 because it can actually tell me that I've done a wrong type thing. And that's very helpful because it helps guard against accidental errors. I run a thing called a formatter. Formatters, they change your code when it's formatted in a really ugly way, and they sort of spread stuff out so that it follows the Python style conventions. If you hit Shift-Alt-F, or if you right-click a file and say format document, you get to do that. You can also install these things called linters, which can search for other problems, including security issues, if you set that up correctly. Once again, I'm going to leave that for you to Google, but you can do Control-Shift-P and select linter, and that will there's many to choose from. PyLarm is a quite good one. Quickfire VS Code features. The search feature, you can use regex in, going to mention that. If you click and hold Alt, you can create multiple cursors at the same time, and then you can sort of do this weird multi-editing thing, which is really quite fun. If you press Shift-Alt-Right, it can intelligently expand a selection to like strings, and then the entire like dictionary and stuff like that. Highly recommend it. And if you press Control-P, you can open a file you recently had open. Let's go to main.py. If you hold down Alt and press the up and down keys, you can move a line of code around. And if you hold Shift-Alt, you can make copies of that line, which is great if you want to totally ignore the principle of do not repeat yourself. And in the help menu, there's a playground, and you can learn a lot of these keyboard shortcuts. Also want to mention some extensions. There's some spell checker extensions out there. There's live share that allows you to code with other people. And there's GitHub Copilot, which is a very cool extension that can use AI to help you write code. I was going to demo it, but it's also quite dodgy, so I don't think I'm brave enough. And you can also edit other languages. So this presentation that I've got on the right here is written with HTML and CSS. HTML and JavaScript, and also a bit of CSS. So I edited that in VS Code. I'm currently on a team that is developing the new secure data environment. We use this thing called Terraform. We're working with AWS. I'm using Visual Studio Code. You can basically use it. You can use it for most languages, C++, blah, blah, blah. And we're done. That's the entire demo over. So, I hope today that you've learned some new technologies. You've maybe learned something about testing or about Python, and I hope you've taken at least one useful thing away today. As we see the technology sort of scrolling along the screen here, I want to tell you that sort of secret moral of the story I alluded to, and that's that intelligent people out there are building tools that massively enhance our development, and we as developers are sort of stronger when we build on each other's work and use each other's tools. We need to take advantage of these tools to build the NHS, the high quality services that it needs. And if I can be a little bit cheeky, we should go out there and we should convince our bosses of the value of this as well. So yeah, thank you very much.
Great, thank you, Adam. Very impressive presentation. Does anyone have any questions for Adam? No? Okay, I've got a quick question from online. What alternative IDEs would you, so integrated development environments, would you suggest for using VS Code if you might not have access to it?
Well, funnily enough, you can actually use VS Code online because so there's an online version of VS Code. I'd highly recommend using that. But also, off the top of my head, there's some new, so Google Colab is a quite popular tool that I'd recommend. That's also really good if you're learning. And there's some quite exciting tools coming out there. Essentially, people have now made a Python interpreter that works on the web. And so we should be seeing some tools coming out. I've already seen some protos, they're getting better every day, that allow you to sort of run Jupyter notebooks, but you don't even need a server to connect to. You can like run it locally using sort of JavaScript wizardry. So yeah, those are the tools that I'd recommend. But definitely get used to using Visual Studio Code because it's great.
Thank you. One last applause for Adam. Great. So we're going to move on to our next speaker. So our next speaker is Dr. Mark Bailey. Mark Bailey is a specialist doctor in respiratory medicine in Gloucestershire. He's a doctor and he codes, which is like a level of intelligence that I can't comprehend. And Mark has been very interested in all things digital for most of his life, and he's been a big advocate of clinical informatics. He's a council member for the Faculty of Clinical Informatics, and he's a board member of the NHS Python community. He's also a current student on the NHS Digital Masters in Digital Health, and is a visiting fellow in clinical informatics at Gloucester University. Over to you, Mark.
Thank you. So I'm using the handheld mic, am I? Okay, thank you. Thank you for that nice introduction, and good morning, everyone. Nice to see you all. So I've given this talk before, and I apologize to you that have seen it before, but there is a twist at the end, so do listen, okay? So, oh, is my slides not on the screen yet? There we go, fantastic. So what I've been doing for the last 2.5 years is trying to figure out how to treat lung cancer, digitally speaking, automate it, make it faster, because it's very slow. It's not being treated fast enough. And I'll go through the details on that. But I think you've already gone through my next slide, actually, which was a bit about myself. Clinician who codes, the lesser spotted. Though I'm starting to spot a few in the room, which is lovely, because in my trust there's no one else, so I feel a bit alone. But here I feel amongst, you know, people that that understand the pain that I've gone through with my trust and so on. So let's talk about lung cancer. It used to be the third biggest, let me move this chair, the third biggest killer in the UK. It's the fourth after COVID now. And in Gloucestershire, this is a graph of referral to treatment times. And 62 days, before 62 days is what the national guideline says we should do to treat lung cancer, because you get a better prognosis. Unfortunately, you can see in the bottom right, there's one at 250 days. Now, patients that are treated, 38% of patients breach that 62-day window, and it's going to shorten down to 49 days from other bodies in the NHS. So that percentage of people breaching is just going to get worse and worse, and there's not enough time, there's not enough money, there's not enough doctors, nurses, admin staff to do this. Why not digitize? Why not automate? And that's what I've been thinking about and working on, and what Tiago alluded to earlier, over the last 2.5 years. Now, lung cancer, I know there's not 87 steps on here, so bear with me, but lung cancer has 34 to 87 separate steps to get a patient from a referral, having their symptoms at the GP practice and needing a referral, to getting ultimate treatment, so surgery, chemotherapy, and so on. Now, it's because of this box here, there's so many steps. In that box there, we have all of these things that need to be requested. Patient needs to get the letter to come in, they need to come in, they need to have the test needs to be looked at, it needs to be reported, it needs to be then, a decision needs to be made from that, and so on. And then there's all these other people you need to refer to. Now, this is a busy slide, but it's intentionally busy. There's 14 different systems that we use in Gloucestershire Trust to get a patient through the whole pathway. Now, they're all digital apart from the top right, paper-based, but they're all digital. All different systems you need to log into, you know, wait to load, find the patient, get the details, request, look, whatever. 15 different staff members to liaise with, and the patient. You don't have to read all these things. These are things that we thought about. This is just a handful of the things we thought about. It's a huge bag of things that we could automate, digitize, to speed up the pathway. So we built an app. Thank you, Sarah. I was about to clap, I can see. Now, we called it Spiritum Duo. Spiritum is Latin for breathe. I'm a respiratory doctor, so we thought we'd go with that. And Duo, this is the second time I've tried to do it. I did it in Microsoft Access before in VBA. Ouch, that was painful. But it was as a prototype. This is a prototype as well, but it's going to be in production. I'll talk about that in a sec. So Spiritum Duo, this is built, if we go on the next page, looking like the NHS website, looking like the GDS website. It's using the NHS React components, so it has the same look and feel and functionality. And this is the home page, and it shows you the things you need to look at. This Catherine Jones needs the CT looked at, and so on. And you can quickly see what's going on there. And this next page, this is the one-on-one page. Seems familiar? And then this is one of the modal pop-outs that is looking at, well, showing you, instead of those 14 different systems, having everything in one place, showing you all the results in one place, letting you make all the requests, this is just scrolling down the page, in one place. Click submit, send it off, it sends off the requests and so on to the back end in the trust and makes it all happen. Why not have WhatsApp built into one app? The way we do it at the moment is a respiratory doctor will email a radiologist to say, look at this scan. A few days later, he looks at the email, replies back saying, which scan? And then you can imagine these things happen, and then these emails get deleted, and then you can't remember what correspondence that's been had. For audit purposes, it's in the right place, secured, encrypted, all in one place. And why not have it so it actually connects to your phone? Bring your own device. And let's say the PET CT is back, so this is a scan looking for active nodes in your body. You can get notes in the middle of the ward round if you're happy to receive it and go, yes, let's go to the next thing. Let's organize an E-bus. That's a camera test into the lungs. And instead of waiting hours and days, oh, just do it on the ward round. It's done. It's all sorted. saving days, saving patient lives, because it is all about prognosis, about getting to the A to B faster. And why not let the patient know that this thing's been organized? Send them a text message with a video saying, here's the hospital, here's the reception, here's the front door to the scan you're going to have, and here's the scan. Virtual walkthrough, take away some of the angst, let them not get lost in the corridors, which they do all the time. And this is a graphical representation of the pathway. What this really is trying to show in a graphical version, this is all fake patient data, by the way, that this is how far the patient is along. 62 days is where we need to get beforehand. We don't want to breach that. Now, of course, it's all fake patient data all added at the same time, so the bar's at the same point. But you can see who's approaching 62 days, who needs more input to try and get them treated. MDT, so multidisciplinary team meetings. It's built into this prototype. Further ideas, which we haven't built in the prototype yet, but just putting notes in there. Actually, that's quite a big thing. We haven't really got anything in Gloucestershire where we can put electronic notes. Graphs and statistics, audits, and further research as well. Speed runs, this is a fantastic idea that I've been talking about with Tiago. Why not use gamification to try and get you through this pathway? I mean, speedrun is about getting Mario from the beginning of the game to the end. Why not get the patient, the Mario, through the pathway as quickly as possible, using the same ideas that use for gamification, tool-assisted speedruns and stuff like that. I used to be a vivid gamer. If people that saw me in the arcade yesterday might say, yes, I was. Oh, Mario was there. Yeah, we had a great time. Right. Now, these are the sort of things that clinicians like to throw out there that we're aligning with national standards, and I think these ones are important. But Gert, get it right first time. Let's get it right now. Let's make this system work for everyone. It's open source, it's modular, any disease can use it, any trust can use it. We'll talk about that. So also the NOLCP, they're talking about taking the pathway from 62 to 49 days. And the NHS service manual says use open source. I love open source. And aren't we all the same? And I was alluding to this before. All pathways are the same. A patient has a symptom, they see a doctor, they get referred to someone, they have tests, they have a discussion, they get treatment. Spirit and Duo is built to be modular enough to do all that. Of course, we haven't tested it in real life yet, but we're getting there. Potential benefits. Faster pathways leading to improved patient prognosis, better patient experience via the tailor-made patient information videos like I was talking through the virtual walkthrough. Reduce staff workload. And this is the really big problem. The lung cancer coordinators, there's 3 of them, spend 8 to 12 hours a day just chasing test results. Imagine that's just all automated and gets pinged to the clinician who asked for it that actually, here it's back, what do you want to do? I mean, that's just so much time saved, and be more patient-facing and talking to patients through the difficulties of lung cancer instead of, sorry, I'm too busy trying to find out if this scan's happened or not. So yeah, improve the patient experience, the staff experience, and aligning with the NHS national digital strategies. Now, the build. The last time I gave this, it was a long talk about the digital architecture. I'm not going to go through that today because I haven't got the time. But open source and modular. TypeScript front end, Python back end. Hence, I can talk about this at a Python conference. And we use DevOps methodologies. I had 2 computer science students that Tiago helped get for me. Fantastic computer science students. I'm so sad they left me in September. Yeah, and we use agile methodologies, all part of the DevOps team. This is quite a busy slide, but this is the front end of Spirit and Duo with the TypeScript. This is the back end with all the Python in it. And this is all the data stored in the different data repositories in the trust on this lower level, apart from this one down here, which is the Spirit and Duo PostgreSQL database. So the front-end stack, let's quickly go through this so we've got some time for the questions. Single-page application like Facebook. progressive web application, so it's downloadable, installable onto your iPhones, onto your desktops, so you don't have to go for either App Store, don't have to have different versions for different OSs. TypeScript, like I said, React, NHS React Component Library, Storybook to help with the actual React components, Redux for the state management, and Apollo GraphQL for the API between the front end and the back end. The back end, like I said, Python, and for those that you know these frameworks, Starlet, ASGI, Ariadne, GraphQL, and also the Trust Adapter, which helps. So Spirit and Duo is built to be modular and independent, decoupled from the back end, and it's the Trust Adapter that's the only thing you need to change. And I heard someone in the NHS R conference yesterday talk about this, just changing the adapter bit for the different trusts. So that's the only thing you need to change, technically. Right, so this is the twist. So I built, well, I didn't build it, my students built it, but I worked within the team that built Spirit and Duo in Gloucestershire. That story's come to an end. There's no funding there, there's no support there, hence I'm asking the question about TEEF earlier. So my colleague Grant Valance, who helped me build over the last year Spirit and Duo, really wants Spirit and Duo in Oxford, and that's where it's going next. That's where the story continues. Now, it's going to be used to treat hematology cancers and prostate cancers. 21,000 anti-cancer drugs are prescribed in March of this year. Routine blood tests every 3, 6, and 12 months, and patients fall through the net. And all of this is done manually at the moment. There's not even a spreadsheet. We just book a clinic for the blood test to happen. A clinic for a blood test. And we haven't got enough clinic rooms. You know, we've got backlogs. This could all be done in outpatients without clinics, on a spreadsheet even, you know. Well, let's use Spirit and Duo, but as a fancy spreadsheet, for this at least, and build functionality on top of it. And patients are surviving longer because of the anti-cancer drugs. And the management of these patients is just becoming impossible. Now, we've spoken about funding today. Funding is an issue. We currently have no funding anymore. I had funding for 2 computer science students last year, but nothing at the moment. This is just pure passion, sweat and tears now keeping it going. But it's going to happen in Oxford. We're going to have the stakeholders meetings. We're going to be using the same methodologies that were described today. I want to thank all these people. Any questions?
Thank you so much. Could we firstly give Mark a round of applause, please? Cool. Kabir, I think Adam has a question, so could you give the microphone to him, please?
Hey, sorry. Maybe you want to follow up after, but I'm really curious how you do the integration with those 14 different systems and where your data source of truth is. Like if you're storing state in Spiritum, or whether you're pushing it all back through HR7v2 or something else. But that might not be a short answer.
Can you hear me? No, good. So it's a prototype at the moment, and we haven't actually used any real data. Now, the thing that we want to do all the time is have a single source of truth, not having the same data stored in different places that get slightly altered differently, you know, different versions. Very much on everything stored in the back end. Now, there's 14 or 13 different digital systems, but there's not 13 different databases. So what we're trying to do in Gloucestershire, at least, in Gloucestershire, is have a single repository, building towards that where all the data is stored, mainly in the EPR, the electronic patient record system. And that's where I want it to be, and that's what we're going to try and do in Oxford. And no, we don't want to store it within Spirit and Duo, we want to store it in the proper back end, wherever the trust decides is going to be, trust repository, trust database. So yeah, it was a short answer. Thank you.
Thank you for that incredibly interesting talk. Interested to hear just a bit more about how the relationship with the students, the computing students, came about, how that worked, and any kind of further advice you have for people thinking to do similar.
Getting money is hard work. I say that straight off. If you're going to do it, you need to be stubborn as hell. That's what I did. I'm half Finnish. My mother says it comes from that side, that I was just stubborn to get this money. I wasn't stubborn enough to get money this year. I was also very lucky to bump into some people that thought this was a good idea. So the Swag Cancelized group, and also the CEO for the trust heard about what I'm doing, mainly because I bugged them, and said, this is what we want to do. We want to build this prototype, we want to test this, we want to improve this. You've got, and the CEO, unfortunately, is the lead for Swag as well, and into sorting out cancer. So basically, if you want to do this, you need to go just knock on every single door, and I'm still doing that, knocking on every single door, trying to find money. We're trying to get money out of the Thames Valley Cancelized at the moment, which is where Oxford is. It's not easy getting funding in the NHS for these kind of projects, and I hear of so many people with great ideas who can't find this initial funding, which for my two students, it were £18,000 each a year. I think that's a bargain. 36 grand a year to build this prototype, which I think is amazing, and I praise what my two students have built every day. And Joe, one of my students, has now been offered a job and taken it in Oxford and working with grants, continuing through to do it. But of course, he's got many other things to do, and it's going to be maybe a fifth of his time can be dedicated to Spirit and Duo. A plea to the top if anyone wants to shout along with me that actually we should try and fund these projects. Not just mine, everyone that has these projects. Some are crazy, some are bad, some are good. But we should try and fund them. We should try and fund them and make them happen. Any other questions?
The backend, that's usually some sort of proprietary system, Rio or something else. Yeah. Did you have any interest from the backend kind of developers, a company actually to integrate the stuff?
Can you hear me? Yeah. So commercializing what we've been doing, is that what the question is?
No.
No.
The question is, in this process, obviously, you have to integrate with the backend, with SQL databases, yeah? And for that, you need to interact with a company that actually runs this stuff. Mm. So what was your experience about their interest to help this project go along?
Okay, so in terms of the data, where's it stored and so on? It's a very complicated answer, and it's very political, and I may not be able to answer it right here, but maybe later over coffee. But vaguely, the trust wants the data to be stored in the EPR, the electronic patient record system. Now, I've got people arguing against that, even within the trust, and I would argue against that because that's almost vendor lock-in. And shouldn't data be vendor neutral? Now, in Gloucestershire, they want it in the EPR, and because of that, it's very difficult, but also they want everything, functionality and data to be EPR. So hence, Spirit and Duo, the story of the Spirit and Duo died in Gloucestershire because they don't want it because it's not EPR.
Any other questions? Question at the back.
Right at the back.
I think that's smart.
Hi, I think we met yesterday, but just really echo your thought about clinicians working. Can you hear me okay?
Yeah.
Completely agree with clinicians and coding and how we need to get more people involved in that journey because it's very, very hard. Certainly my experience in places like London has been often clinicians having to sacrifice using clinical time to do academic work, and then some trusts have been very, very good at offering like sort of fellowship roles where you do a lot of clinical work for the trust, and then in return they'll give you protected time to do research or informatics, which I found quite good. I guess my question was also around integrating GP data with this system and how you managed to do that at all?
Two great questions. So the first one is very clear to my heart. Specialization accreditation of initial data computer sciences. Oh, they're really not working. Like this. So two great questions. The first one very dear to my heart. The first one about accreditation and professionalization of clinical mathematicians. I'm on the Council of Clinical Informatics, and we're working on that right now. We want to have training programs for training numbers for doctors, nurses, midwives, anyone that's clinical, to train, to understand digital, to actually train up and be competent in these things, to actually understand what digital can and cannot do, what AI, which is a big buzz term at the moment and used too much at the moment, what AI can and cannot do. And I think it will happen in the next 5-10 years. You can be a consultant clinical mathematician, and that's what I want to happen. Consultant nurse, consultant, pharmacist, and so on. Now, in terms of GP data towards Spirit and Duo, oh God, I would love to have a holistic program that starts where the patient just says, I've got a symptom, and that the whole thing is managed by one system all the way through to the end.
But culture gets in the way. It's a pipe dream. I would love to make it happen. And if you want to get involved, please do.
I think we have a question right at the back of there. And then that, I think, would be the last question.
Yeah.
Sorry, Mark, we can't hear you.
Mic's not working.
Hello?
Oh, there we go.
Hello?
Hi, Mark. Thank you very much. That was very insightful and interesting presentation. I was just wondering about medical device legislation on a sort of high level, how you've managed to navigate that, and any tips that you've got for yourself, where you're starting out again from the very start.
Good question. Oh, I'm loving the questions today. So if you're building don't quote me on this because of course it's a medical legal thing, but what I understand is if you're building a medical app and it stays within one trust, it's not a medical device. Now, if it's, as soon as it's two trusts, then it's a medical device. You need to get MHRA involved. But also, it depends what you're using this for. So if we're just using Spirit and Duo like a spreadsheet to actually just manage when blood tests need to happen and chasing when they happen up, it's not actually giving any treatment to patients and so on, then it's less of a medical device. It's not doing any calculations, less of a medical device. It's all quite a grey area, as you probably appreciate. And when we want to put it in Oxford, but also go to another DGH. So we will have to talk to the MHRA sometime next year and say, we're doing this, how do we need to sign it off? Can we get the CE also a certificate as well, which you need to have stamped onto your medical devices? So yes, I'm very aware of it, but at the moment in prototyping and building stage, we don't need to be too worried, but it will be something that we'll be tackling definitely next year. Thank you.
Great. One more clap for Mark, please. Thank you. Great. I'm gonna ask everyone to have a break until 11:45, please. So have a break until 11:45. Thank you.
your coffee or listening or both. Slightly out of the program. Are we streaming now?
Hello, can you hear me? Yeah. So there were a number of questions for you, Mark, and we want to make sure the online audience is included. There's like more than 100 people. And we just before Stephen's talk, we're just going to quickly ask you some of these questions. So how is the technology being maintained in terms of keeping up with security, since there is patient data? Is there a team maintaining the code?
Well, sort of to kill that question straight off, it's fake patient data. So there's no worries for any patient to be harmed by inappropriate access. One of the students working on this was a security science student, so we've had his input on building this. But it's literally just been 2 students building this over a year with my input for direction. So it's not any high-level security input or anything like that, but what we're going to be doing in Oxford is definitely automating testing for that. There's already unit testing within it. Maintaining the code, well, it's going to happen in Oxford with me, Grant, and Joe. If we get any money from the Thames Valley Cancer Alliance, it's looking less likely because we're not getting an answer, and we were supposed to have got an answer a month ago. Then we can actually get in a computer science student, full-time computer scientist to help just actually make sure this is working really well and very secure and functionally adequate for what we need it to do. To start with, it's very simple. It's literally order a blood test when it needs to happen and check when it's back and let someone know it's back. But there's so much functionality like the things I spoke about for lung cancer that we want to add on top. But we're going to have to start small and simple and build up from there because we just haven't got the time or the money at the moment. But we want to show benefit in a very simple way to then get further funding.
Great, thanks, Mark. Other question is, has there been any requests to integrate into hospital clinical systems?
Has there been any what, sorry?
Has there been any requests to integrate the software into hospital clinical systems?
So from the trusts, no, is the short answer. From clinicians, so when I say trust, I'm talking managerial and digital teams, no, because it's not EPR. If you, outside of the data world and analytical world, when you're sort of in trusts and GP practices and so on, we are EPR-centric, EPR mad. I'll get shot for saying this, but anyway, I'm saying it today. Yeah, and so, but the clinicians want it. It was my boss, Henry Steer, who was the lead for respiratory medicine, and he's the lead for lung cancer in the Southwest now. He said, Mark, here's a piece of paper that we need to fill in for lung cancer during our clinics. Can you digitize it? I said, Henry, I can do much better than that. I can automate your whole pathway. And that's what I've been doing over the last 2.5 years. And him and all the lung cancer team, the medical director of SWAG, Helen Winter, have been all saying, Mark, do it. There is such a push, such a drive, such a want, such a passion for this. But I've come across so many barriers from high up management, from the digital teams that are stopping this. Hence, it's not going to happen in Gloucestershire. My plan at the moment is make it happen elsewhere and bring it back home. Football's coming home. Spirit and Duo's coming home. Hopefully one day. Yeah.
Thank you, Mark. And this is the final question. It's quite niche, so do tell me if it doesn't make any sense. So, is HL7 integration for Somerset Cancer reinsuring the bundle supported?
So they're talking about the Somerset Cancer Repository, I think. So I'm very much aware of that. We haven't tackled that at all because that's next level stuff when you're actually talking about real patient data. I know there's a lot of data scientists here, and yes, data is extremely important. Interesting thing I'd like to add is I think functionality is just as important, because if you had bad functionality for the end user, the data you're going to receive from the programs that they're using is going to be poor because they just hate the systems. And most doctors hate EPRs. Why not have something better? Now, you could argue Spirit and Duo is just an EPR replacement, or it's just another EPR. I think of it more of a pathway than a single patient record. a lump of notes. It's actually a holistic approach to the patient going through their disease journey. I'm just trying to spin everything on its head with Spirit and Duo.
Great, thank you, Mark.
Thank you.
Your questions are over. Thank you very much.
So Stephen previously studied chemistry, then later hedged his scientific bets in postgraduate research, applying physical chemistry approaches to the study of biologically inspired materials. He then thought he had left university behind, working on data-focused projects in a software company. Last year, he proved himself entirely wrong by returning to university, working at the Bennett Institute for Applied Data Science at the University of Oxford. He's a software developer there in a technical team that supports healthcare research, and he does a lot of work on Open Safely. So please, Stephen, go ahead.
Oh. Hello, hopefully you can hear me at the back, I think. Yeah, excellent. So yes, as I was introduced, I'm a software developer at the Bennett Institute, which I will shorten to just Bennett if I'm referring to it in future, just for keep things super quick and moving. I've done a lot of work on documentation for the Open Safety platform, but it's definitely, as we'll see, a team effort. So it's not just my work, there are other people involved as well. So what I'm going to cover in this talk is initially just explain Open Safety very quickly, because I think most people probably have heard about Open Safety from one of the talks or just from other information they already know about. I'm then going to talk about how we're building the documentation with Python-based tooling. And then finally, I'll move on to a little bit of just a wrap up and talk about documentation as code, what that means, and how what we do at Open Safely kind of fits in a bit with that, and the approaches you might take away to think about doing your own documentation. So Open Safely, really quickly, it's a trusted research environment. We already heard about it, I think, mentioned in the keynote this morning. A trusted research environment for working with electronic health record data. So a way for researchers to query GP data and make use of that information while still respecting patient confidentiality and privacy. And it's been interesting on two different kind of axes. One of them is that it was developed in response to the COVID pandemic. So a lot of the research has been done. You can see some on this slide here. There's lots and lots of papers that are being published relates to COVID and COVID's effects on different patient groups and NHS services and much more. The other aspect, which is quite interesting, is this model for working with sensitive data in a way which respects privacy and enables researchers to work with that data without them having to download all the data onto their laptops. So even the name Open Safely, the two parts of the name, the Safely part refers to that aspect. So researchers are not just downloading all the data onto their laptops, they are writing their study code on their own machine or wherever they want to work. There could be a cloud instance, it could be on their own laptop. And then they take their study code and then they send that study code to where the data is held, so they don't get access to the underlying data. And after the outputs are approved, they then get those outputs and are able to actually publish them in scientific papers or other work reports that they're working on. The open part is referring to aspects of transparency and accountability. Open Safely, you can actually see all the jobs that are being run on the Open Safely server, that you can just log on to the job server without needing a login and see what's being run right now, if there is a job being run right now. You can see all the study code that's been run there because that gets published, and all the research outputs are public as well. So there is this idea of all these things should be out there in the open. There are advantages. We've already seen that mentioned in the panel talk as well earlier, that the sharing of code is a really useful and powerful idea. Not having people siloed solving the same problems, but actually reusing code that others have already developed is a much more efficient use of your time. So documentation is really important generally for software projects. Any kind of moderately complicated software project, documentation is a useful feature to have. This is Open Safely's documentation, if you haven't seen it before. Links to everything are on the slide deck, so if you need to links to things to see them, then look at the slides later and you can totally find that. Open Safely comprises a number of different systems as a platform. So to get a job running from a researcher's laptop all the way to running on the data backends, there are several steps involved. The researcher needs to know how to write the study code using the libraries we provide to query the data. They need to know how to use the command line client, which is this package called Open Safely. It's a Python bit of software, to be able to actually run that code locally in the same way that it runs on the backends. they need to know how to get their code onto GitHub, and then to submit the code to the platform to be run, and how to get their outputs, and various other aspects. So there's a lot to cover. We do provide some support to people via various means, via Slack and via GitHub discussions, and there's an onboarding process where people get some time with an initial co-pilot. But obviously having people be able to learn this stuff themselves and self-teach and be able to get support themselves is a valuable thing to have as well. We can also view this through the lens of who is documentation for. Documentation often has more than the obvious kind of potential audience. So the most obvious, if you're going to do the family fortune style top answer, you'll probably come up with this one, which is users. So we have lots of users. Internally at Bennett, we're supporting quite a lot of the researchers who do a lot of their work with Open Safely. There are also users at other organizations, either NHS affiliated organizations, other universities who are using Open Safely for their research, where we also need to support. But it's not just users, it's potential users. So people may just be interested in what your project is doing and if it's useful to solve their problem. So having your documentation in public is not a bad thing in terms of it makes it discoverable. People can find your documentation. It gets indexed by search engines. People can stumble across it and see what you're trying to do. It's also useful for people working on the project. So people like myself who have worked on the project, as an onboarding process, you need to familiarize yourself with the project and start getting to grips with it. And having good documentation is a way to speed up the process. Developers and other organizations may need to understand how the system works when they're integrating their data with Open Safely. Managers and academic supervisors may not be even the potential users, but may have like employees or people they manage who may want to use it, and so that they need to determine whether it's a valid use of their time or not. We're an academic group, so academic reviewers and funders we're interested in, they may be interested in seeing what we're actually doing. And other people work on other projects. And the general public, because Open Safely is using data from the general public, and so people who are concerned about privacy and are technically minded may be interested in looking into our documentation, see exactly what we're doing. And again, having it out there for everyone to access on a public website, so you can just go to docs.opensafely.org. You don't need a login, it's just all up there. Means people can just look into this and see what we're actually doing. And you can do much more with Open Safely as well. You can run all the code and things locally as well. But just having the documentation out there is a useful start in itself. So yeah, the documentation is open. It's developed in this GitHub repository. You can see, like I said, there are a lot of contributors. So they're like on there, I think listed 34 contributors. Like I said, it's a big team effort. And we'll see some more of that later on. So I'm going to talk about building Open Safely's documentation. And then how do we pronounce this thing even here? Someone actually asked on Twitter, they asked one of the developers way back, which seems really archaic now, like given the state of Twitter. But they asked, do you pronounce it MakeDocs or MKDocs? And the developer replied, I use McDocs. So I'm going to use McDocs because it's quicker than either of the other two to say, and time is short. So this is McDocs. McDocs is a static site generator, if you're familiar with those already. If not, what they do is you write some content in some kind of markup language like Markdown, which we heard mentioned in the previous talk on VS Code. It's relatively simple to do. It's much easier to write in that kind of markup than in raw HTML. You then feed your content through the static site generator, and it gives you out a load of HTML, which you can then do with what you want. You can put it up on a website, and all you need then is a simple web server which can serve files. You don't need any fancy application server to actually run that server. This is the theme we use, which is called Material for McDocs. It's a very popular one for actual documentation projects using McDocs. And then you put those two things together, and then you get the documentation, and I'm done, I can just walk out. No, I'm not going to, I'm going to carry on talking. So I'll explain a bit more why we're actually using McDocs. So originally, the nice thing about having your stuff in Git and version control repository is you can go back in time. So this actual commit is from before I started working at Bennett. This is from 2020. I started in 2021. So I didn't even know the reason exactly why they were using McDocs originally. So initially this repository, if you can't see it, there are a number of Markdown files in this repository, and that's it. It's relatively simple, which is a good enough bootstrap if you're starting from nothing, then just having Markdown files is totally a valid thing to do, or some other kind of simple content that you find useful. That's all there is. There's a README file which links to the Markdown files, and that's it. And GitHub is actually very good at showing rich previews of even things like Markdown. So even having those files in a repository is quite a valuable thing as a get-go. And I think it was in this state for about 4 or 5 months. I think the repository started in May 2020, and then the state of it here was from around October 2020. But the problem that was being solved here, after speaking with Seb Bacon, who's now the CTO at Bennett, who made this change, is that we're trying to go from stuff on the left-hand side, which is a bit of Python source code, and you can see the documentation string, which has all been lovely written out by one of the developers, to something on the right. So we can include, rather than having people having to delve into the source code to see this stuff, or mandate that they have autocomplete functionality already configured in their development environments, they could actually have a reference where people who are don't even have the software installed can go and refer to it and see what we can do. And also that there's just a nice bit of reference for people there, so they can always just go back and look at it there, which is sometimes a bit more friendly. It's also formatted in a very nice way as well. So that's the problem that was being solved. And actually the change that was required, as you can see in this pull request, which is linked in this commit here, is very simple. All that happens, if you can't really see, is that the documentation files that were already there, the markdown files, get moved into their own directory. We add some other files around structuring a Python project, so now this becomes a Python project rather than just simply a collection of markdown files. So we add some requirements, and we add a Python version file. And then the only other thing we need to add to get this to work with MuckDocs is this YAML file, which is very simple, just key value configuration, where you specify the site name, you specify the hierarchy of the pages that you want to display in the index, and you specify the plugins you want to use. One of them is this MuckDocStrings plugin, which is the thing which does that magic conversion. And that's pretty much it. And from there, you can then use this special kind of syntax, which is at the bottom of that screenshot, which we can highlight here. And that's it. Then what you get is something like this. Very, very simply indeed. So that's like a really strong selling point of using tools like this over just raw Markdown. So that was back then. Why are we still using MuckDocs now? It's 2022, it's getting into 2023. We're still stuck with the same system. It's worked pretty well with us. Why has it worked well? So we can go back to this screenshot of the MuckDocs page, their home page, which details the features. So one of them is, it's relatively simple to get going with. It's just a static site generator that takes Markdown and simple configuration files we've seen. It also comes with a built-in development server, which helps you can write content on your machine. When you save the content, it will automatically reload in your browser, so you can have the two side by side and see your changes apply pretty much near instantly. There are other tools out there. So Python, the other big documentation tool in Python is called Sphinx. Sphinx is a bit more heavyweight. Sphinx by default uses a markup language called restructured text, which is, I can't even remember the syntax of that if I'm ever using it, but it's more powerful, but then is a bit more difficult to get going with initially. So there are definitely trade-offs in the tools you choose. There's not necessarily a right tool or a wrong tool, it's just there are different tools with different trade-offs. And we can see again, so this is how you would set up a project, a MuckDocs project, really simply. So we saw again in the previous talk on VS Code, we saw talk about virtual env. So all I would do is create a new virtual env for my documentation, install the package, MuckDocs material, which also installs MuckDocs as well as a dependency. And then you can run the command, you can use the MuckDocs command to create a new project, a skeleton project, and you can see we have this, we just have a simple YAML file and one placeholder stock page, which we can then fill in with our actual content. And we could serve it, but then actually one other thing we need to do is change the theme as well. And we can change the site name to reflect what we're actually doing today. And that's it. That's all you need to do to actually get your project up and running. And from there, you can just add more files in quite simply, as simple as that. So if you need to add more Markdown files, you can do, and you can just link them into the YAML file, and that's all you need to do to continue to expand your site. So it's quite easy to use. So another powerful thing is there's lots of customization available. People have spent a lot of time making themes. MuckDocs has been around for a while, so a lot of these things are quite mature. And it's easy to customize. And one way we can see this is through the theme we're using, which is called MuckDocs Material. On the left-hand side, I'm not going to go through all these things in detail. This is the menu you get if you refer to their documentation of all the different features you can get. And on the left-hand side, they've done a lot to expand the HTML and JavaScript over the stock, what you would get with some of the bog standard themes, to give you things like a cookie banner if you should wish to add one and or require one to be compliant with different legislation. You can customize the colors and the fonts and all these kind of things without needing to be a web developer. I'm not particularly a great front-end web developer, so these kind of things make it very easy to just customize them. On the right-hand side, we can see a lot of features which are around the way you write your documentation, so the way you structure your pages, the way you structure your actual content. These features, things like fancy buttons and admonition boxes and diagrams, etc., are often provided by extensions. So Markdown's strength and weakness is that it's really simple. So by default, Markdown is very limited in what you can do, but it also makes it very easy to learn and to make documents very quickly. How people typically get around this in static site generators is by using extended forms of Markdown. And when they do this, you end up using slightly different syntax, which tailors your content more to that specific bit of software a bit more, which can be a bit of a downside if you ever want to migrate, but it's probably fine if you're sticking with the same thing. This is an example of some extended Markdown, which is included in our Getting Started guide. So at the top, we have this admonition box, which is a note, which has it's like a box out to give some extra context to the text. And we also have this, below that, we have a tab section where you can switch between the two sections and click on them. And all we need to do to actually include that is just, I don't know what's happened with the formatting here in how the slides have been translated, but it's relatively simple. You can just add the 3 exclamation marks or 3 equal signs, and then what you get is that kind of appearance of this kind of nice layout without having to do much work at all. Another reason for using McDocs is in Python, and that's not just me name dropping to try and engender great good feeling and popularity for my talk. It's actually a thing that a tool that everyone in the Bennett team the technical team is really familiar with, because the projects we all make are with Python. That's been a decision as a whole in our team. And because we're familiar with Python collectively, it means that we're familiar with the tooling already. We already have Python installed. We're also familiar with installing packages, so I showed you I was able to install pip install, and I know how to do that. I don't have to go and look it up. We're also familiar with errors because we're software developers, so of course we're familiar with errors. Yeah, just being familiar with those things is less of a barrier and less intimidating than coming across maybe some other language where something suddenly goes wrong and you don't know how to fix it, and you spend lots of time panicking about how to even understand the error. With Python, because we know Python already, then that's not so much a problem. And the same goes if you're more familiar with R, then maybe that's a reason to choose more of an R tool. It also means we're familiar with the language used to write McDocs as well. So if you need to delve into the actual source code because you want to understand the behavior of the software, that means you have the confidence to be able to do that, which you might not if it's a different language, or maybe only one person in the team knows how to do that if it's written in Go or if it's written in Ruby or whatever language. It also means we can extend McDocs as well. So on the left is a small snippet. It's not the complete source from some templating plugin that some of my colleagues wrote. And what we were trying to achieve was pulling information into the documentation. This is a new page I'm kind of working on. They're pulling information from one repository into another. So the thing on the right is detailing a new thing we're working on, which is an electronic health record query language. And it's included in a new package called Data Builder. So we're pulling information out of the Data Builder repository from the tests. So the content on the right primarily comes from specification tests which detail how the language behaves. And we can have very simple code on the left-hand side which then just pulls out that information into the documentation, which is really, really useful. I would say there are advantages to having all the documentation in one place for users. It can be a bit more complicated from the point of view of us managing it as a platform because we are pulling information from disparate bit packages and sources. That can be a little bit gnarly to get in, and also I think there are definitely questions on how we manage versions of subcomponents, which may be the case with this new Data Builder package in future, which we have to think about. But for now, it's kind of worked pretty well. So having said all that, in the last, hopefully, few minutes, I'll just cover the idea of documentation as code. This is a new term to me, but not necessarily a new concept. I was reading a lot more about documentation and watching talks. I did a documentation course, and from that I did a bit more reading, and from that I saw this term come up, and I was aware of infrastructure as code, but not documentation as code. And as it turns out, what we've been talking about in the last few slides pretty much encompasses a lot of the ideas people are referring to when they talk about documentation as code. So documentation as code is the idea that you should be writing documentation with the same tools as code. And on this slide, they also give you a bit more detail of specifically what they mean. So they mean using an issue tracker, they mean using version control, they mean using text markup, they mean using code reviews and automated testing. That is to say that you're writing documentation with the same tools as code, and not just that you happen to be using the same tool to write both, and you don't end up using a word processor, and I'm sure Adam would be horrified at this, to use Microsoft Word or something to write all your code and your documentation, and that is maybe not the actual intent here. You want to use the same tools for documentation as for your code. So we'll look at each aspect of that and how that impacts on what we do. So we already said we're using a Git repository, which is really useful. It gives us advantages. We currently, for some reason, have 19 branches on our repository. Some of those are probably old, but then some of them correspond to open pull requests and independent things people are working on. It means people can work on things in parallel and independently. We can pull all those things in together. It also means, like I said, we have lots of contributors who all work on this project. Primarily that's me, but then lots of other people contribute as well. We have an issue tracker, so all of this is open. You can just, it's a public repository. Anyone can see the things we're intending to work on, and we're tracking all the work we're doing in those issues, which is nice because it's a centralized place. You don't have to keep moving around to see where things are. We're also using pull requests to get code, the changes to the documentation into the main branch. We also, once the changes are into the main branch, they're automatically deployed, which I'll talk about in a minute or two. Here is a conversation between myself and my colleague Caroline. It's nice that all this stuff is just in the open and you can see it happening. So if you want to see why something happens, in the same way I went back to show why we use Mercdocs, you can see the reasons for that decision. You can also see what we're intending to work on. So that's really useful. I'd also mention this commit suggestion. I don't have time to go through it, but this magic button here on the Git pull request review feature, which is a commit suggestion button, so you can select lines of a diff in the pull request. You can then press this button, and then you can give a suggestion. You can change what someone's written, give them a suggestion which they can then include into their pull request, which is really, really good for text edits and small changes like that, rather than having to say, oh, you spelt a word wrong, can you change this word, please? And then the person has to go and then change it themselves. It saves a lot of time. So yeah, I don't know if anyone actually knew this, but GitHub actually has VS Code Editor just built in. So if you change .com to .dev in the URL of a repository, you can just go to, and you're logged in, you will get the Visual Studio Code editor in the browser, and you can have a more complex editing experience than just the bog standard GitHub user interface, which is really, really useful. GitHub also have a feature called Code Spaces, where you can run code on a remote server in the same way and use this editor, and I think they've made that free for some limited usage now for everyone, so you get like so many hours per month, which is a way of running stuff without having to even install it on your computer, which is really cool. So you could get people and non-developers and get them configured in a way which they can run all this stuff without needing a setup themselves. For publication, so we talked about Mercdocs as a static site generator. We just have HTML, we can host it anywhere. We use GitHub Actions to publish this stuff automatically. So on pushes to the main branch, this stuff gets deployed very, very quickly. There's no delay between those processes. There's no extra step. It's all automatic. This is a little bit of the workflow that's used to do that. It's the main core part of it. It's very simple. We just pip install the dependencies. We run Mercdocs build to build the site, and then we push it with this special action which pushes it to a service called Cloudflare Pages. GitHub also have a service called GitHub Pages, which you could equally use as well. Cloudflare Pages does have this advantage that you get these pull request previews, which are quite useful if you're working with other people, or people are not necessarily proper developers, they're just users and not really interested in the technical side. They can then see a preview of what they've changed without needing to run anything at all. And we also get these automated checks at the bottom, so we know the site is still working and it hasn't been broken by anyone changing anything. They haven't accidentally deleted the configuration or changed something in a way which breaks it, which is really good reassurance to have when you're merging stuff in, and it's the kind of ideas you use when developing code as well. So maintenance, again, we have more of these checks. So there's this extra check here which says check code snippets. So one thing I'm working on again for Data Builder is to have these code snippets which are samples of this electronic health record query language. We want to ensure that these continue to work and they don't break for any reason, either because the library changes or because someone accidentally edits them and changes them. So these get run every time someone pushes commits to GitHub. It runs the snippet, it checks the output against the existing output, which it knows about, and if there's a difference, then the check will fail, which is fairly rudimentary, but is sufficient to pick up simple errors like that. Another thing I've added recently is a link checker. So this is like a third-party thing. It's really cool. It runs super quick. This is an example of a check that we have. It takes like 30 seconds to check 600 links on the OpenSafely documentation. And here, the bottom two errors are because I am silly and forgot to rename links in the actual documentation, even though I changed the file names. The top one was actually an NHS link writing some COVID-19 information, which has actually changed. And with that, you get, what you get is then you get the opportunity to discuss with people who are writing that content if that's still relevant or not, because you know the link has changed, maybe the context, surrounding context has changed, especially in a medical kind of context, things can change. In the technical context, things could certainly change. There are lots of other automation tools which we've talked about, including which we haven't got around to, but you can do things like spell checking, style checking, consistency of markdown, capturing screenshots, all these kind of things which you could include in your workflows. And just to say, contribution, all this stuff is really cool for developers. You might want to think about what actual non-developers, the experience of them. They can make small edits in GitHub's user interface. You could train them to maybe use GitHub's Visual Studio Code Editor in the browser or GitHub Codespaces. Some of the automated checks we've talked about really help. And the markdown, as we've seen, is relatively simple, but you still might need to give people some support and training in how they actually work through this workflow when they're maybe used to working in content management systems. So just wrapping up and summarizing, that's just about everything now. I'll just summarize what we talked about. So I think there are definite benefits to publishing non-sensitive and non-classified documentation openly. It promotes your work, it proposes collaboration with others, and provides transparency for what you're doing. I have some prompts here, if you want to refer to the slides, of things you might want to think about when you're choosing your tools. My goal is not to say you should use McDocs, it's that you can pick from these documentation as code tools as you like and find something that suits you. If you're more from the R community and you just find yourself in here because you're interested, then maybe some of the R-based tooling is something that you'd be more interested in, the Python tooling, and that's totally fine. Finally, yeah, documentation as code is a really powerful idea. That should be something that people should be thinking about more. We talked about a lot of these aspects, using text markup, using version control, using issue tracking and pull requests, checking in deployment. You can host a site, it costs you basically nothing to do so, and you can pick and choose the tools you want to use. And some things I've used as inspiration. There's a book called Docs Like Code, which I've skimmed very quickly and seems really good in the overall core. Explaining the core concepts is a bit dated because it's like 5 years old and a lot of things are kind of on the technical side have slightly changed, but as an overview to get a feel for what's involved, that's really good. There are several talks by the Write the Docs conference, loads of talks there which are really useful. I wrote a post on using the Lychee link checker based on what I've done with OpenSafely, and look at what software companies are doing as well, because they've got lots of money and time to spend on this stuff, and using what they do as inspiration is a really good idea as well. That's it. Thank you very much.
We have time for one question in the audience and one question online. So there's a question that says, should there be efforts to use a single standard for creating documentation across languages?
Ooh, that's a good question. That's probably a tricky one. I think the thing is, again, I think it comes back to this idea of documentation. I mean, there are some standards, so there are ways in which people will work, and people will use certain tools and gravitate towards certain tools. But I think being really prescriptive about a single way of doing things is probably fraught with danger, because people always have their own requirements. So some of the tooling I've talked about integrates with Python really well, but then again, if you're using like the R tooling, I don't know how you'd easily get the R documentation into, there may be a way of doing it, but maybe not. And you might have other caveats where maybe having to prescribe. I think the flexibility of that approach is like the strength of it, which it doesn't say you must use this tool and this tool and this tool, but you're free to pick and choose the tools that do work for you.
Great, thanks, Stephen. Does anyone have a question? Yeah, okay, Johnny's got a question. Pete, can you help me, please?
Okay, thank you, Stephen. Yeah, always been very impressed with the OpenSafety documentation, how much you've put out. So, yes, thank you for going through all that. Very easy question, hopefully. What's it not good at? So, what should we avoid? Embedding interactive code chunks? Maybe not. PDF, LaTeX, trying to connect those in? Maybe not. Formatting equation? Which things should we avoid trying to sort of squash McDocs to do and do somewhere else instead?
That's a really good question. We haven't really, I mean, like I said, the main problem that I found is this, that is not really the McDocs problem. So McDocs does maths, you can do that. So I think there is like a math plugin, like it uses MathJax or similar. So you can do that, and these tools are pretty flexible. Certainly the Python Markdown extensions give you a lot of extra flexibility in things you can do. What else would you not do? I think, like I said, the problems that we found are probably more around the structuring, the documentation, and that's where my head is more at. So that's like not necessarily a direct answer. We haven't hit anything where we've found that a real limitation. The limitation's been around how you would structure organising documentation a bit more, where you've got this platform rather than a single project. So I think for simple projects, that kind of approach works incredibly well. And where you have the complication is where your thing does not map to that simple project, and then structuring it and organising it is maybe not quite so simple. And you have to think a bit more about how you organise those things. So it's more the organisational level rather than what kind of content can you not get in here. There's probably some other kinds of like multimedia content or something which are possibly not the most suitable ways of doing that. And I guess the other problem is making sure you can publish it in a way like that. There are ways of publishing that into some kind of document as well, but I haven't looked into those, and maybe that's another limitation, which is not so easy to do. Like you can have a collection of HTML, but then maybe someone actually wants a PDF with all this, which you can probably do other ways, but yeah. Yeah. Thank you.
So we're a little bit behind schedule, but don't worry, lunch is only in 2 speakers' time. Just want to make sure that Charlotte is around. Charlotte, if you are here, show yourself. Great. So I just want to introduce Charlotte James. So Charlotte is a senior research associate in medical statistics and health data science at the University of Bristol. She is a researcher in residence at BNSG ICB, Integrated Care Board. Working within the modelling and analytics team, Charlotte's research focuses on the application of machine learning for decision support, risk prediction, and operational improvement in healthcare. So, Charlotte.
Thank you. Cool. Hi, so I've never actually been introduced as a conference before, so Mary's done it for me. Sorry, I've also never spoken into a microphone before. So yeah, I'm a senior research associate at the University of Bristol, and also based in Bristol, North Somerset and South Gloucestershire ICB. So my role as a researcher in residence, it was quite nice hearing people talking about researchers working with the NHS earlier. That's kind of my job, so I take on projects that are maybe a little bit more in depth than what other people in the team might normally do, so take a little bit longer and are of interest to both the ICB and the research community. And this is one of those projects I'm going to present. So it's a model to forecast long-term emergency department demand. Okay, so the motivation behind this project, it came from a conversation of, can we do something better? So what's currently done at the ICB when they need to forecast future ED attendances is they break past attendances down into age bands and forecast, fit a linear regression to what happened in the past to predict the future, aggregate up at site level, and that gives you an idea of what might happen over the next year, over the next 2 years, which is important for budget allocation, service planning, etc. And that seems to do quite well, so there's not a problem with it, but it's assuming that the only real driver of ED attendances is population growth. But what about, for example, if I tried to call 111 and couldn't get through, and I was really worried, would I take myself to the ED? Or quite topically, if you called the ambulance service and couldn't get through, would you take yourself to the ED? So it's quite possible that the capacity of other healthcare services impact how many people attend the ED department. And then also on the other side of things, if you have two equivalent populations, so same number of people, but say in one population only 2% has had a flu vaccine, in the other population 20% had, would you expect the same number of ED attendances from those two populations? Possibly not. So it's possible that the capacity of other healthcare services and population health might impact ED attendances along with population growth. And so this project was to, was I on the right side? No, okay. Sorry. And so our approach was to try and model future ED attendances incorporating these sorts of variables, so population health and service capacity. A slight challenge which I'll get on to is that population health obviously varies at a much very different rate to service capacity, and if you try to come up with an intervention to change or improve population health, then that would happen over a much longer timescale than any change in service capacity. Cool. Okay, so the data, all the data was publicly available. I quite enjoyed, there was a talk yesterday about using publicly available data and the kind of minefield of downloading it and processing it and combining it into an aggregate data set, which I went through. So yeah, data was publicly available. I used data from 2018 and 2019 because of COVID. So unfortunately, or unless you're answering a research question around COVID, then the COVID period in terms of the data, when you're thinking about health services, it's not actually very useful because it's not typical of what would happen outside of a pandemic. So yeah, data from 2018 and 2019, because that was what was available at the time. So the capacity variables that I used are the number of 111 calls offered. That came from the NHS 111 minimum data set. The number of ambulance calls answers, that came from AMSIS. The number of GP appointments available, which came from appointments in general practice. The population health variables, they came from the ONS's health index, which is quite new, and it's meant to be it's kind of updated from IMD or index of multiple deprivation, so they're trying to take it forward rather than using IMD. It can be broken down into 3 components. So there's people, which is health outcomes, and that's things like life expectancy, mortality, suicide rates. Places, which are wide determinants of health, so that's access to green space, distance to your GP or to your A&E department. And lives, which are health-related behaviours and personal circumstances, so smoking prevalence, vaccination uptake, prevalence for obesity. And I also included population in the model because that's what's been included so far in the past. And obviously my dependent variable is ED attendances per month. That's what I'm trying to forecast. As a little small caveat, I started this at the start of the year when CCG still existed. So for the rest of the talk, I'm going to refer to monthly ED attendances per CCG. Obviously, CCGs now don't exist, but it's more, CCGs are a geographical region, and this model can easily be used for ICSs once the data is available. Cool. A slight aside on capacity versus utility. So you might think that, or it's fairly easy to justify that the capacity of other health services could impact ED demand or ED attendances, but so could the utility. So if I increase the number of ambulances available by 50%, bad example. If I increase the number of 111 calls available by 100%, if the number of 111 calls also increased, then that's not going to have any difference. And so there's, these variables are highly correlated, as you can see from the plots. And I originally intended to incorporate both measures of service capacity and measures of service utility, but because they're highly correlated, it masks, if you have highly correlated variables in model, it masks the effects of the other one. So I kept the capacity variables in, scrapped the utility, mainly because GP utility wasn't, in the publicly available data, wasn't recorded for the second half of 2018, so I had a lot of missing data. So keep the capacity, but they are highly correlated. Just one other thing to point out on this plot you might have noticed is that the ambulance service is always running at capacity. So yeah, capacity is always lower than utility, or capacity is always lower than demand for the ambulance service, which I'll come to again in a few slides. Cool. Okay, so candidate models. It's a regression problem. I want to know the number of attendances per month. Obvious choices, so a linear regression, that's what's been done previously, and variance, so things like lasso and LARS. And multi-level regression, so because the data set I created has one row per CCG per month, per year. So there's one row that this is all the variables for BNSSG in February 2018, etc. So there's obviously groupings in the data because there's years and there's CCGs. So a multi-level regression might make sense. Random forest plus variance. Why random forest? Because it can deal with non-linear relationships. There's no guarantee that any of these variables are linearly related to ED attendances. I've put a star there saying capacity only. That is because of the way we constructed the data set. The population health variables only vary annually. So if each row is a single month, then you have, for one CCG in 1 year, 12 rows or 12 data points have the same value of the population health variables. And that means, so all the models I've fit using 5-fold cross-validation, and when you split the data into training and test sets, if you have variables that are constant across groups of data points, then you find that your model actually performs very well. You can suddenly explain or predict the number of ED attendances per month with like 99% accuracy. Okay, and how do these models perform? So the linear regression did best, R squared or variance explained of 0.53. Multi-level regression didn't do well at all, and the random forest, so when I say plus variance, that includes extra trees, gradient boosted trees, other boosts, all ensembles of decision trees. But it was actually the standard random forest that performed best with an R squared of 0.41. So from the coefficients of the linear regression, it looked like the measures of service capacity were more predictive of ED attendances than measures of population health, including population, which seemed a bit strange. So the researcher in me wanted to understand what was going on. So I looked at the mutual information between each of my independent variables and ED attendances. So the mutual information tells you how much knowing the value of one of these independent variables tells you about the value of your dependent variable. And it can deal with non-linear relationships. That's the difference. And what mutual information told me was actually the population health variables are far more important than capacity variables. So it's just maybe we want a non-linear type framework. Obviously I've said that we can't, because of the fact that the variables kind of change at different rates, so population health changes annually, service capacity changes monthly, we can't put them all into a random forest together, so why not have separate models? So I spent a while thinking about this. This is my kind of non-linear machine learning version of a multi-level regression. We have a capacity model, which obviously takes in measures of service capacity, and that predicts the monthly ED attendances for each CCG. And then the population health model takes population and measures population health in as independent variables, and it predicts the mean monthly ED attendances per year per CCG. And then these are very imaginatively named. The combined model combines the output of both. So it's just a linear regression. Essentially, you can think of it as the capacity model. The predictions from the capacity model are being kind of improved by this expected mean number of ED attendances over the course of the year. Okay. And a quick aside on a random forest. Random forests are made of decision trees. You can think of a decision tree like a flow chart. And each tree in the forest is trained on a random subset of the data, which say they're far less likely to overfit your data than a single decision tree. And if you put, say, you put a data point through a decision tree, it would come up with a prediction for the number of ED attendances. Each tree in the forest would give you a slightly different prediction. And then around the forest itself, the final prediction of the number of ED attendances per month is just the average of the predictions from each tree in the forest. And sorry, there's like the classes on the image. That's obviously a classification forest, but mine was regression. And then to evaluate the model, say for each component model, I looked at the R-squared, the variance explained, and used repeated fivefold cross-validation. And also for the overall model, again, assessed it with the variance explained. Obviously, the point of the model is it's not just a regression, it's for forecasting. So to assess the forecasting accuracy, I used the mean absolute percentage error, training on 2019, and training on 2018, forecasting 2019. And then for the feature importance, so for the component models, the population health and the combined model, you can use the built-in feature importance from scikit-learn. I should say that all of this is done in scikit-learn. Scikit-learn is great. But because the NHS R is a kind of bespoke ensemble, there's no built-in feature importance, so I use the permutation importance. That's you randomly shuffle each feature while keeping all the other ones fixed, and the drop in model performance after the feature's been shuffled is a measure of how important that feature is. Cool. And the results. So I've already said on a previous slide that the capacity model around the forest fitted to capacity variables could explain 41% of the variance in monthly ED attendances. The population health model can explain 61% of the variance in mean monthly ED attendances, and combined I get an R-squared of 0.75, so the NHS R and full can explain 75% of variance in monthly ED attendances per CCG. Okay, there's also some outliers in this plot, and when I look closely at the data, they're Liverpool and Hull, kind of wanting to understand what was going on, why they're outliers. So it turns out these CCGs have particularly low values of people and lives, which are the components of the health index, or not necessarily, they're not low compared to all other CCGs, but the relationship between their values of people and lives and the true number of ED attendances a month, which is the x-axis in these plots, is different to other CCGs with low values of these variables. Also, just as an aside, something interesting to note from these plots is the population one on the bottom right. You see that, so I've scaled, I should have said this earlier, I scaled the population and the capacity variables by population, so everything's in units of 10,000 people. And so I was actually predicting the number of ED attendances per 10,000 people for each CCG. And you see that the CCGs with smaller populations, so they're the darker red spots on the bottom right plot, they actually have more ED attendances, which I find quite interesting. Cool. So forecasting performance, I trained on 2018, predicted on 2019. The mean absolute percentage error is 4%, which I was quite pleased with. Feature importance, this is permutation feature importance. Shuffling each feature and looking at the reduction in R-squared for the whole model. Population is the most important, followed by lives, which are risk factors such as levels of smoking, alcohol misuse, and then ambulance capacity. Cool. And then finally, did a little bit of scenario modelling. So what might happen in the future or over the next 4 years if we increased capacity of services. So that's an instant increase. So say next month ambulance capacity is increased by 10% everywhere, and that's sustained over the 4-year period. Or we improved population health in regions where it was below average in 2019, and that's an incremental change. So month on month it's improved, sorry, year on year it's improved slightly until it reaches the kind of 2019 average. Population growth is do nothing, so all of the other scenarios also include population growth. And we found that increasing the capacity of other services largely doesn't do anything, except for the increasing ambulance capacity leads to an increase in ED attendances. And that is because from the data, the ambulance service is always operating at capacity. So that's what this forecast tells us. Because it's not in the data, the model can't tell us what would happen if the ambulance service wasn't operating at capacity. And they were actually, yeah. Cool. And then, so obviously also from the plots, the lower line where ED attendances actually decrease over 4 years, that's improving population health. And that's probably quite an obvious result, maybe, to people here, that actually if we had healthier people, we wouldn't have so many emergencies, people needing emergency care. A very rough bit of maths, and it is a rough calculation that doesn't include or factor in the cost of improving population health. But yeah, this could obviously save quite a lot of money over 4 years. Cool. And then just to wrap up, so yeah, I've applied this model to ED demand, but the architecture for combining data that varies at different temporal frequencies could be used in lots of other places. I've currently got a master's student applying it to some other publicly available health data. A healthy population means fewer ED attendances, it's obvious. I'm currently working on applying this model locally, so it's obviously useful to see what might happen globally across CCGs, but I mean, where it could really be used is within the ICS to understand what they might want to do in the future. And I think I'm out of time, so I'm going to stop talking. I'm a big fan of open source, open science, so all of the code and the data is available on GitHub. I'm an academic, so I wrote a paper, so if you scan the QR code, you get to see my paper, you don't have to read it. Cool, thank you.
Thank you, Charlotte. Excellent. So we have a lot of questions for you. So if you could keep your answers brief, that would really help us with time. So how can these results be practically used in decision making in the NHS?
So I think that would be applying the model locally. So I think at the moment, as it is, I've used publicly available data, and it's not particularly useful for. Yeah, it's not generally useful as it is. But locally, if you apply this to a lower level geography, you could identify groups of people that a policy or some sort of intervention that could ultimately reduce at your local trust. You could reduce ED attendances by identifying something that's relevant to your local population. Yeah.
Next question. Did you look at the impact of seasonal variation at all?
No, but because I'm using months, so I predict February next year from what happened in February last year and the year before, then you saw the seasonal variation in the forecasting plot. So it's kind of just naturally learned from the data, it's inbuilt.
Great. And last question from online. Let's have a look. So does the analysis put into consideration things like the future change of the workforce? So, for example, having more GPs and stuff like that.
No, but that's a really interesting one, and that I mentioned I've got a master's student working at the moment, okay. So they're doing something like that. Great.
Do we have any questions in the room? Charlotte? Johnny, of course. Great. Pete, could you?
Thank you very much, Charlotte. Can I ask, whenever you include population health in a forecast, you're always going to end up with missing drivers or confounding factors that we just don't understand because the data is not perfect. How can these be reflected in this sort of forecasting? Especially, I was interested, you're multi-level. Would you be able to put a dummy level in for essentially unknowns.
Could you repeat the start of that question again?
Yeah.
Sorry.
So whenever we use population health data, there's always going to be some form of confounding factor we've not addressed. There's always going to be some data quality we've not picked up on. There's some missing drivers for the forecasts. And you showed your forecasts are explaining 75% of the variation. So there's always something missing. It might just be stochastic, or it might be something that we just don't have the data for. Is there any way to start to address picking up what level of information we're missing from our forecasts? I was just interested with your multi-level approach. If you could almost put in a dummy GAM model or something similar that would start to pick up, is there a pattern that we just aren't seeing in the data but exists somewhere in these forecasts?
Yeah, I mean, that's an interesting idea. I want to have a think about it before giving a definite answer, but maybe we could talk afterwards.
Sure.
Cool, thank you. So, just get this. Ah, got you. Great. So, it's the last speaker before lunch, and so Paul is an experienced analyst and data scientist who's worked as a civil servant since 2020. He now works at DART, which is Digital Analytics Research Team. Used to be the analytics unit until a few weeks ago. And since joining the NHS in January 2022, he's done work on the NHS app, forecasting demand, and a lot of work on geospatial, which we're very excited to share today. So over to you.
Thank you for a wonderful introduction, Mary. I'm very conscious I'm eating into your lunch break, so sorry, terrible choice of words. I'll get on with this as quick as I can. Okay, today I'd like to talk to you about a project that took place in March this year. The project was to create a geospatial tool using Python to really solve a plethora of use cases. One example is if you're looking to cite a new NHS site, like a GP practice or a diabetes centre, where would you want to do this and what do you need to take into account to do this? So, identifying existing sites, catchment areas, substitutes, next best service, working out access, time to travel for patients or service users, and delivering this visually so you can impact and deliver to a non-technical audience as well. Mattia Ficarelli and I were given a week, just 1 week, to do the project that you're about to see how far we could get in this time. Mattia is a software engineer on our team who worked with us for over 2 years, but he's recently left the NHS, so you're afraid you're left with me for this project. So scoping. What's out there currently? We didn't want to reproduce an existing piece of work. There's no value in us wasting NHS time to rebuild something that's already been better resourced. So what is out there? ShapeAtlas.net is a wonderful piece of software that was built by Public Health England. It's a strategic health asset planning and evaluation tool. Not very easy to say, but good acronym. It's a brilliant piece of software. Has everything from data from LSOA layers to age breakdowns for areas in healthcare service locations, but it is closed. So what's our differential? We wanted to produce a piece of software or code that anyone could run in the NHS and adapt to their own needs, and keeping it flexible, open, using open source tooling and freely available data. I'll come back to this later on in the presentation when we discuss current use cases. So the split between Mattia and myself. Mattia had done some previous work on GP practices before using the Epica dataset. He wanted to see if he could develop this further and take into account travel times to GP practices, specifically walking times. He then also decided to look at different means of transport and identifying times of travel depending on time of day. I focused on two further functions, both of which used Mattia's work as a platform, a springboard, and tried to take that development further. Could I identify possible gaps in services using the travel time code that Mattia had deployed? Could I then combine modes of transport, so potentially walking public transport for an end user and see where their shortest route functionality may be to a GP practice? Practically, this piece did prove to have a few problems. I mean, how do you stop your computer crashing when you're running OSMX, MNX nodes and edges on a very dense area? So I think London and GP practices, how many are there? So for a proof of concept piece like this, we decided to use Cambridge, a smaller town, for mapping and data size issues. Technical aspects of this work had to be reusable. Open source, non-proprietary. So GeoPandas, GeoJSON files, isochrones, Folium, all of these harness the ability to really turn a geodata frame from isochrone polygons into GeoJSON files. And the plan was to go away, work separately, but build on each other's work. So I'll run through the 4 areas we took this forward, then delve a little deeper into one of them, given the time limitations on the presentation. GP practices in Cambridge. Mattia used the Folium library to map Cambridge postcodes CB1 to CB5, they're the blue area in the left diagram, and then added GP practices for these areas using the coordinates longitude and latitude. Folium gives you the ability for an interactive map, and you can turn on the layers one by one. He then added OSM M and X nodes and edges and the data run for Cambridge. And then on the right you see the walking times colour coordinated for GP practices. He then subsequently built isochrone polygons, one of the picture on the left. In the centre of each polygon, where the red is, that's a 5-minute walking time around GP practice. Orange is 10, yellow 20. And we had to estimate walking time, and he used 4.5 kph. He converted the polygons to GeoJSON files, overlaid these on a Folium map, and here's where you get the interactivity. On the right you see GP practices with the polygons overlaid, and you can turn on 5, 10 or 20-minute walk for these distances and see where there may be gaps or how impactful any gaps in service may be within Cambridge for these. So whilst OMX is a really useful package, it does assume free flow travel times, and you have to fix the speed at which you may go through a city. I'm sure you're aware, but in major cities such as London, free flow speed is rarely achieved, especially during rush hour. In this section of the project, Mattia explored combining Uber movement data with OSM and X to estimate travel times between a GP practice in St John's Wood and St Thomas's Hospital. The left picture shows a rendering in OSM and X of nodes and edges for central London, and the right, the Uber movement data overlaid both for free flow and for peak rush hour, and the table gives you the times that he calculated for this. Part 3, this is the part of the project, my part of the project. I wanted to see if I could identify gaps in services using open source tools and freely available data. I live in the East Midlands, my in-laws live in Lincolnshire, so I thought let's see what we could do with A&E services and the next level, what you might call urgent care centres in what is a pretty sparsely populated area of the UK. On the right, on your right is the 4 24-hour A&E services in Boston, Scunthorpe, Grimsby and Lincoln. When I was conducting my research for this part of the project, I couldn't easily find NHS datasets with different hospital departments. So, for example, maternity units or urgent care centres. I think that has changed now, but this was done back in March. So the problem evolved from being a catchment area and coverage issue one to being twofold. How can I find the next level of services and layer on top of what you might call first level A&E emergency care, and then add in Mattia's code for time to travel via road in what is a sparsely populated and in some senses remote part of England. The code solved the problem. I had my hospital data set. A little investigation showed me, unsurprisingly, we had 4 in the largest populated towns and cities in Lincolnshire. But it struck me, why can't you just search for what you're looking for and then add this in Python? Why do we have to have this closed frame approach limiting us by which data sets are available? So I looked into an API key using Google Maps search and wrote some code, which you see here, to output the results, but purely here just with longitude and latitude. The top cell here is the search box that comes up in my VS Code, and ran around the previous slide's code. And when I ran Urgent Care Centre Lincolnshire, you get the results laid out as before, and you could use this for anything. Adding those in to the previous map, the blue circles are now the urgent care centres overlaid on the same OpenStreetMap Folium map with the A&E services in green. On the right, we've added in driving times at, I guess, 40 miles an hour, because it's more country roads. So that would be how far you may be from an accident emergency or an urgent care centre should you need to jump in your car and drive. The fully rendering isochrones, taking it back to what we have with the Folium map, you can turn on those layers here 10, 20, 30 minutes as well. So part 4, I was trying to combine, I guess, modes of transport here, and also when you look at somewhere like London, that map on the right took about 8 hours to run just to produce all these onto a Folium map. So you can imagine the practicalities of trying to do this, and this part of the project did remain incomplete, I'd say, after 1 week's work. We took it quite far, but couldn't calculate full shortest route functionality with multiple layers of transport during that time. But that brings me to the part of the project of where we are now. Since publishing the repo, and this is up on our NHSX GitHub page, and we have github.io as well for an explanation and a walkthrough of this. We've had 2 asks. I currently manage a PhD student with ESNEF Trust, that's North East Essex and Suffolk Trust. He is looking into diabetes and inequalities data. As part of his investigation, he wanted to see where are GP practices that have diabetes specialisms or diabetes nurses. That's not easily available information. So we've reproduced that code and run it for GP practices and found out, is there any link to where GP practices with diabetes nurses, are they performing better in diagnosing or sending people for referral to a diabetes centre? Second ask came from the ESNEF Trust as well. Can we calculate multiple shortest route functionality for our patients? Can we add that into potential appointment examination of when people are missing appointments? So we've started to be asked for some use cases around this repo. And everything I presented so far was dormant, I guess, from March, but it's recently become reactive. Current areas we're working on. Very lucky to work with some talented individuals in the Dart team who are giving up their time. Our BI developer, Ollie Jones, is turning part of this project into a Streamlit app where we hope to host, at least if it's run, sorry, I can't say hosting, I'll get into trouble for that. We can give you the code for you to host it on your computer. But there should be pages within this, and we're going to keep on adding. That's the first page from the first project I showed you. We will keep on adding functionality to this, so we can not just tackle individual use cases, but you can hopefully adapt this for your own use as well. Next area, we're trying to solve maximum coverage location. So when you do want to score a site, think what McDonald's do when they want to put a new McDonald's in a town, or Aldi. Why can't we do that for the NHS and effectively give you a grid, score population, score a variety of other metrics, and hand you a tool that does that for you? Pfizer's going to be working on that, and Mary, once she is finished being too busy with the conference, will be giving up some of her time as well. Thank you in advance. Third part, multiple shortest route functionality. It's a very crude map of Cambridge with Adam Brooks Hospital at the bottom there. I wrote this at the weekend, I think it was after a football match on Sunday. But you can now just put in an address. It doesn't have to be longitude, latitude. And this is just one piece of very basic Python code now that gives you the distance and works out 4 different addresses for you. That's to address the use case we're asked for. We're going to be reformatting, refactoring this, and hopefully adding this to the Streamlit app as well. And lastly, this is the part of the project I call the Big Solve. We're very lucky to be working with Google Health Partnership, of which Adam and Nick are here today, so thanks for coming. They're giving up 20% of their time each week to help work with us. And we're trying to reduce the amount of time it takes to load and run this product. Everything I presented to you today takes multiple, 20, 30 minutes at least, if not hours. The big solve for us is turning this from something that is relatively unusable unless you have a lot of time in your hands into taking it into seconds. So they're going to be currently working on Volanite diagrams and sharding and loading different areas of the UK that can be loaded and loaded a lot quicker. And I guess the functionality that you're all used to when you use a mapping tool. Can we reproduce that type of analysis and have that working within this as well? Additionally, the picture you see here is adding LSOA data in, which is another area that Max has been working on from Google Health as well. If we can add all these types of scoring and different types of metrics into this, we can effectively build that max coverage location with this as one of the scoring metrics that can go into that calculation alongside travel times as well. We're not limiting to these 4 areas. We'd like to be able to add to them going forward and to address further use cases as they come up. And hopefully the more this work gets known, the more use cases will come out of people in this room and elsewhere. We want it to stay adaptable and be out there and be flexible and be current and stay needed. So if you do have any ideas or any use cases or contributions, please get in touch. I've only put my email out there, not my LinkedIn or GitHub like everyone else does, so a bit underprepared. But please get in touch if you have any collaborations, if you'd like to add to it. It is open source and on our GitHub repo. And lastly, I should say, this is a proof of concept piece of work, but it is something we'd like to be able to deliver over the next few weeks and into next year. Thank you.
I have a few questions for you. One of them is, so this project's really exciting because it's our first Python community collaborative project outside of working with each other. So we're going to work with Google Health, who have traveled very far to come here. I wonder, Paul, what do you think is the benefit of doing open source collaboration with tech companies?
I think the answer's in the question. Because it's open source, Adam and Nick know about this. And without that, we wouldn't have this interaction, we wouldn't have this ability. There's no point of us trying to learn from each other if we can't share what we're trying to learn about. I've learned more from speaking to other people about things like this project and other projects just because we keep all our code in the open and have that ability to deliver. You also, the use cases that come out are not the ones I would ever have anticipated so far with this type of project. I completely expect this to be a one-week piece of work and then go to sleep, and it's come back to life because of the fact we've been able to share it in the open and keep it open source.
Great. I've got another question, which is, what are the, this is very technical, what are the benefits of the expected pipeline? Oh, sorry, not that one. What areas of the project would you develop if you had unlimited resources? So unlimited computational capacity, unlimited people, unlimited money. How would you develop it? The dream.
How long do I have for this? Ideally, we could host. There are samples out there. There are similar styles of projects out there that are hosted, and I don't mean things that we're familiar with, use on phones every day, but GIS, WQS, I think he's a professor, that's his GitHub tag. He has a similar type of geospatial streamer app that's out there. I'd love us to be able to host something like this. It has a plethora of use cases, which I think the more you send it out to people, they'll probably come back and feed into this. And then you can just build a tool with multiple pages that you can keep adding to as time goes forward.
Are there any questions from the in-person? Okay, Mark. Pete, can you?
Thank you. I could have walked over myself, actually, but never mind. Very interesting presentation. As someone that used to live in Cambridge, I don't know if you visited Cambridge and Addenbrooke's, the road infrastructure into Cambridge is terrible. Trying to get on time to the hospital as a doctor, it was difficult. The main road coming in from the south was always chock-a-block. Addenbrooke's, and now Patworth, which has now moved to Addenbrooke's, is a very big site. And I'm wondering, so you were looking at where should we build new GP practices and so on. My question is going to flip things on its head. Where would you move Addenbrooke's to if you could, for better road infrastructure and better access for patients and ambulances which get stuck in delays because of roadworks and just traffic volume and so on? Maybe you can't answer that, but would there be a way of something, maybe a way of looking at how to see where it'd be better to put it?
I think you've hit the nail on the head with this. One of the problems we've been talking about this morning, and it's come up throughout the project, is data. Access to data is the actual problem here. We don't have a lot of free flow. Data for travel assumes free flow. We don't even have tube time travel data. That I found on a Stack Overflow from a Freedom of Information request. So we're a little behind some other countries. In France, the RTP, I think it's the Paris Metro, they publish their travel time data, bus timetables. Again, I think there's now a requirement that they have to be, if they are for a public service, have to publish their timetables. But again, that's not realistic. Like you say, it's taken into account delays. Getting access to this data is the type of thing that changes this project. And I think that's something that's going to have to be an ongoing and iterative process, because it can be so variable within cities, let alone when you start talking to bus timetable data where I live in Rutland. Well, is there a bus at all? Like, you struggle to find the data that's out there. So I think this is going to be something we continue to learn from. And all we can do is really submit Freedom of Information request when we don't have that data, if it is there. But that's a big learning curve. That's something we need to tackle as well.
Any last questions? Johnny, last question.
So it's not a question, it's just to emphasize this is a NHS PyCom community project, which means this is a challenge for everyone else who's in NHS PyCom to consider getting involved. If you are interested in just the work, interested in learning some of it, if you have some ideas, this is not supposed to be we would like it not to be our team working with Google Health, we would like it to be NHS PyCom working with Google Health. So please take the challenge up.
Thank you very much.
Okay, great. Thank you.
Thank you. All right, everybody, it's lunchtime, which is great news for everyone. So please come back here at 2 o'clock. You're allowed to eat in here, so the food's in the lobby out there, and we'll see you at 2. Thank you, everyone.
Thank you, Pete.
Crackle on the speakers just in that last talk.
Don't close this. This is a lie. This laptop. Sorry.
I'll pop back a little bit early as well, just to make sure.
Yes. Oh, right. Oh, wow. Almost as far as you can go. Milton Park is one of those sort of green spaces you're constantly sort of astonishing it exists. It's much bigger than you think. They seem to do quite well. I grew up in Oxford, which is full of green spaces. Turn a corner and you're in a field somewhere. Then I moved to London, obviously, all the parks. I did find that model important. In friction. Yeah. And interesting from a sort of a subject matter as well, because there's a product I'm working on at the moment that's it's tangentially related. Actually, see if I can keep it down or something like that. Do business on stations. Yes. To the extent that I don't know, it's one of those things where my sort of natural reaction is going to be full, no matter what you do. Throw more money into these, you know.
You do see this in healthcare, kind of as kind of consumer-led demand idea. Well, A&Es is probably their way to go there. Just go there and go to the GP.
Yeah, the problem I'm looking at the moment is the interface with social care. So particularly around domiciliary care. So if the care worker turns up at somebody's house, spends 20 minutes knocking on the door, ringing around, phone the police, and they're in A&E, we already know about it. You know, all the information is there. We've just got to join it up.
So rather than the idea of step down care, out of
It's, yes, that's going on as well, but this is more the sort of where is the capacity in the care system already being wasted that we can free up. Yeah, that's the problem.
And that's good. It's got data sharing.
Oh, one of the things that's most fascinating about it actually is how undersurveyed it is, how little data there is around domiciliary care. course it makes sense there are economists around. Wouldn't there be?
So do you sit in
CTO, yes. Yeah, I mean, that's innovation lab. Yeah. It's been interesting actually, because I only joined in August. Fresh faced and new to the NHS. Learning all sorts of wonderful stuff. I mean, it fairly radically changed between my interview and when I actually started. So. Well, exactly, yes. And that's one of the most interesting things I was hoping to get out of his talk. If he's saying that's going into production. It's a struggle with that with everything.
history suggests.
Yes, yeah, no, absolutely. I mean, you can see the argument of, don't want to train everyone on a specific system. Skills aren't transferred to anything else. But even if that was true, even if that was a, straight down the line, cost benefit, the training costs are too high, it still feels like there ought to be a way for us to, to root ourselves around that problem while still being able to deliver stuff, the sort of stuff he's talking about. Because he's done that with, taking on face value that does what he says. 2.5 devs for a couple of years. That's a tiny team and a relatively short time scale. And if what he's talking about is knocking sort of weeks of email back and forth about problems from a patient timeline, savings in that are just astronomical. It absolutely beggars belief that we're not. The sorts of costs that's incurring aren't being recognised. specific thing I'm working on.
Hi everyone, we're about to start in about 20 seconds, so please do settle down. Craig is going to host the rest of the conference, so yeah, please take your seats.
Hello, good afternoon. Welcome back to the second half of the NHS Python conference. So this afternoon, the first speaker, Daniel Schofield, good friend of mine, old colleague, back in the DART, as it's called now, Data and Analytics Unit, NHS England. So, Dan, away to you.
That's great. Thank you. And let's get this going so I don't speak for too long. Thanks, everyone, for coming. Hope you had a nice lunch, settling back in. Please feel free to doze, but don't snore. So today I'm going to talk about connecting research to NHS operations. My name's Dan Schofield. Thanks, Craig, for the intro. I'm a senior data scientist in the DART team. I've had quite a lot of DART today. You've had a lunch sandwich with DART. I joked with Paul earlier that he was the starter. You've had lunch, and I was the dessert. But it turns out you also got dessert and coffee, so I'm the washing up. So there we go. So today, I'm going to talk a little bit more about how we're trying to do this within our team. So, hi there, I wanted to put Troy McClure here. I don't know anyone who watches The Simpsons, but unfortunately that's copyrighted, so I can't use that. So I'm going to have to act my best Troy McClure. I work in the DART team, and we do a lot of work trying to think about things that are happening both in research and in industry and how we can bring that closer. And one of the ways that we've really tried to do that is through the PhD internship scheme that Sarah mentioned earlier. Thank you, Sarah. Shameless plug again. And I'll try and draw attention at different points about where you can, as a community, feed into this going forward. So, what am I going to talk about today? Well, the current connections to academia first, how we've connected within the team. I'm now going to tell you something about Python at that point, because of course this is a Python track and I should probably mention Python. And through that I'm actually going to go through a few of our example projects from the PhD internship scheme and some of the useful packages we've found there. Then I'm going to do a bit of a wrap up, and then there'll hopefully be some time for questions. You may note that I am quite a big ex-KCD fan. Randall Moore is excellent, and this is a nice Python comic that he had, so you can find that online if you're more interested. I don't know if Python makes you fly, I can't say. Okay, disclaimer. Other programming languages do exist and are really, really good. I am talking on a Python track because I think Python is great for some of the stuff we do, but there are so many great languages out there, so I'm not saying don't use other ones, and if anything, probably some of this stuff, once we got it more established, might fit better into other programming languages. So, connecting to academia, it's not new. We're not saying it is, and actually, the way we've been looking at it is thinking about where we can actually connect closely as a team, and also try and then draw this back into NHS England and try and grow this out. So there's a long history of collaboration that can be between different academic departments at a trust level, a national level. There's joint funding. There's all sorts of ways you can do this, but sometimes they're mismatched. And actually, the way we found that we feel they're mismatched is actually delivery times. So if you go and ask a PhD student to do something, it's a 4-year program, and actually we've spoken a little bit about earlier. At the end, is there something that's going directly back into the NHS? Is it joined to NHS England the right way? So we've really focused on this specific bit. I should also say the title is about research, and there's a lot of really great research going on in industry. And I won't talk about industry very much today, but I just wanted to sort of flag that we appreciate that industry is also putting a huge amount into research. The Academy of Medical Sciences have a policy program enhancing the NHS academia interface, and they highlighted 6 recommended outcomes as part of that program. I just want to draw attention to the top left, providing dedicated research time for research active NHS staff. I class myself as a research active NHS staff member, so I'm glad that I have dedicated time to this. This concept of fully integrating research teams across academia and the NHS. And then finally, the one at the top, creating a healthcare system that truly values research. I put the wrong ones in light blue. My apologies. So we set ourselves a challenge within DART. And actually, we were the analytics unit back then, and you'll see also NHSX popping up throughout here. So just so you know, it's all maps to the same thing. We wanted it to be attractive for academia to engage with, so there had to be some kind of reason why they'd want to do this. We wanted to value the individual's experience, so whoever was joining and working with us as part of an internship scheme that we were going to put on, data science internship scheme I should also mention, should get an experience in both ways. So they should enjoy their time with us, but we should also get experience that they have and bring it in-house and understand better from that. How to produce tangible outcomes that build into a research program that we hope to sort of establish and grow. The bottom four are a little bit more about the kind of things that we needed to really think about internally. Fast setup and delivery of short-term projects. These are 3 to 5 months. I'll talk a little bit about that next. They have to lead to further collaborations if we can, or look at how we can integrate them into the system. High risk of failure or reducing scope. This stuff that we're looking at isn't always easy, often goes wrong, and actually the thing you thought you could do, you can't. So, reducing scope isn't necessarily a bad thing as long as you just don't let the scope creep too far. And quite often we may have lags because of data access, IG dependencies, things like that. So we had to try and avoid those where possible and where they were going to cause a big impact on the delivery of the project and the experience. So the scheme itself, we wanted to recruit PhD students to sit in permanent roles within our team for 3 to 5 months and work on established individual projects. I think that word established is maybe misplaced here. We were obviously trying to, and actually I'll allude to that in a little bit. These are projects which we have established now, but at the beginning, of course, they weren't established. So it's a slight misnomer at that point. They actually sit as Band 6 Agenda for Change colleagues within our time. We have roles that they fill, and they interview through a competitive approach. And they are then directly supported by one of the DART data scientists. So you've met Paul, Johnny, myself. There's also another colleague of ours, software developer Kevin, who is also supporting. A note here, we did consider master's students, and actually we've had a lot of interest in master's students. And I'm not saying that they are not generally self-autonomous and don't need to fit their placement in, but we found that PhD students works. It's a good balance that we've achieved. You can find out all the details about the scheme there if you are interested in applying. The projects. So we can kind of think of these 4 boxes as going around top left, top right, bottom left, bottom right. Really, it was about how do we come up with ideas, how do we make sure they connect to things. But the one I really want to draw attention to is this, suggestions from analytical peers, academic departments, NHS organisations, or individual PhD students are considered. So that is a call to the community that sat here with us today. If you have ideas for projects, and on the next slide, I believe, is a link to our projects. They're all out in the open. If there's anything that you're interested in, you've got ideas around, or maybe a project within your trust, within your teams that you think would be good to have some dedicated time from a PhD student, do let us know. My email address will be at the end. And the rest of this slide, is just about really how we've tried to have a feedback loop of defining the projects, talking to people about them, and then making sure that it comes back in. And that can be the PhD students themselves. They might come and say, oh, actually, I do this stuff, and I think this would be worthwhile for you to do. Oh no, my slide hasn't worked. What did this used to say? Well, let's not worry about this one. So we'll not worry about what happened down here. And this is unfortunately the link. So I apologize. We'll make sure on the slides that are shared, you can see that link. I think a lot of what I've spoken about already is really what we're trying to achieve. These projects have to have value to the NHS. They have to be of interest to students and departments. Identify tangible outcomes as soon as possible. They've got to be flexible and pliable because things don't work. We get that. And we've got to try and avoid too much vagueness or scope slippage. It does happen. We accept this as well. But of course, trying to avoid it as much as possible is great. At the end of all the projects, we try and make them open. And that's one of the biggest challenges, especially when you're working with data that could be, slightly more private. How can we separate the project and the methodology out from the data? And sometimes that's easy, sometimes that's hard. But we want to make it open and as reusable as possible. And yeah, we want to align it to what we're going to call our research strategy areas. And we sort of have 4, but maybe 5 or 6 or 7, I'm not sure. Probably the most important thing, as I said before, the individual. Successful intern projects rely on treating each individual intern and managing their project in such a way that gets the best outcome for all. This takes a lot of energy and amount of time, and actually having a dedicated member of the team working with them has been really, really great. And actually, it was mentioned by Sarah earlier, we get a lot of learning in the other direction. I've learned a lot working with PhD students about what they're doing in their PhDs, and sometimes about just what they're doing as part of the project. We have to value 2 parts, I think, in turn. That's their previous academic experience, what they're bringing to the table, but also that we can give them a good internship experience. And both aims, yeah, absolutely time and consideration from the part of the supervisor, and we spend a lot of time trying to focus in on how we can get the best out of this. And we take feedback at the end of every 3 to 5 months period with a PhD student and say, you know, what could we do better, what could we do worse, sorry we can't do anything about the admin. That's one of the other things. So I said I was going to pivot hard into what does this have to do with Python and another XKCD for you. It's a bit dated now because you can see Python 3.6, which is unfortunately not really supported anymore, but I think it still rings true. Maybe we've got a little bit better at it, and a few people have talked about ways of dealing with environment management. Anyway, Python is a great language for projects like I'm describing here. It's great for prototyping and development, as well as being able to push stuff through to production. There are a huge number of useful libraries, actually, like new ones that I can't even keep up with. Every day I'm like, well, this would be good, and then I'm like, 96 tabs on my phone, 97 tabs on my phone. So it's getting pretty, you know, it's pretty great. But of course, that's because people are writing stuff in the open from both research and industry that others can build on top of, and that's really great. Also leads to really great community support as well. You know, you're not ringing someone up and saying, oh, I need the help. You can just have a discussion. People can say, this is good, this is bad. Okay, maybe some people get a bit upset about it, but not too much too often. And the pain refers to the diagram. Like, you know, I think we all know if we've played with Python that this is painful sometimes. So I'm going to talk through 3 projects now. I kind of have a project template slide, which is about the project in question, and then I have a slide about one of the packages we used in the project. So, and kind of why. So here, this first project is with Jamie Burke, a PhD student from the University of Edinburgh, and it's about transforming healthcare data with graph-based techniques using Sale Databank. Sale Databank is a TRE. You've heard a bit about those over the course of the days, and we're looking at cohort data within their TREs and exploring the use of directed hypergraphs, an extension of simple graphs. Actually, before I go, how many people have heard of hypergraphs here? Okay, that's good to know, because I was a bit like, do people know about these? Okay, I'll do a really quick intro to hypergraphs. So here we have nodes and edges in a normal graph, E1, E2, E3 being the edges, A, B, C being the nodes. A hypergraph allows you to basically make an edge that joins more than 2 nodes. So here we can see, and this is actually a directed hypergraph, A and B are joined to C. That's in the directed case. In a normal hypergraph, you would just be ABC has an edge around it. And what that actually allows us to do when we want to look at multimorbidities, to go beyond comorbidities, is actually model them in the side of this graph. It's really great because you can take that degree up to 3, 4, 5 nodes, all connected with a single edge. Okay, so you can probably see, got double back there, probably see where I'm going with this. It gets complex in terms of computations. Every time you increase from, say, a simple graph to a hypergraph to a directed hypergraph, and your number of nodes is, so here I've chosen 13, which happens to be the number of nodes we use in the Charlson, which is a way of collecting diseases, disease codes together into disease groups. But the issue is, in a simple graph, 78 possible edges. In a hypergraph, 8,000 possible edges, well, greater than 8,000. In a directed hypergraph, greater than 1.5 million possible hyperarcs. So hyperarcs is basically when you put arrows on hyperedges. This means that if you imagine going to something like the Alex Hauser, which has 26 diseases, I believe, these numbers get crazy. So you want to do this on your computer, it's not going to go so well. So in comes number. Number is not the only way of doing this, and probably you should be writing some stuff in a more, a compiled language from scratch. But what number allows us to do is if we have something written in NumPy in Python, we can basically add this lovely little decorator, JIT, just in time, and a few other things like no Python equals true, gil equals false. There's loads of arguments. The docs are really good. And basically, it just speeds it up. So actually, this is a really bad example because it doesn't speed it up in this case. But if you scale this out to, you know, NPA range of 1 billion, it actually does speed it up. And you actually do pretty well out of it, pretty much for free. Apart from number can be a little bit fiddly at times. But yeah, nearly free. Anyway, and that basically allows us to do these computations, calculate weights and stuff around our networks in our lifetime, which is kind of important. I mean, Jamie, as an example, has got some stuff that was taking, you know, we're talking days down to like minutes with this. So it's possible with the right kind of combinations of this stuff. A little nod to JAX as well, it's a Google package. And this is kind of a direction that they're moving with a lot of their large linear algebra stuff for neural networks. Similar kind of thing going on, I think, under the hood, but don't hold me to that. Just so you know as well, the LLVM compiler library is actually an open source, community-supported program. Okay, project 2. Developing large-scale language models with NHS incident data. So Chris Maney, who spoke in the R track and was actually chairing yesterday one of the sessions, spoke to us, and the NLRS, the National Learning and Reporting System data, collects NHS incidence data from Datix, which was also mentioned yesterday, and that is across on a national level. There are lots of incidents, and some are severe and some are not. And clinicians have to, at the centre, have to try and review these and make sure that there aren't any emerging problems. So there are lots of really good examples on the website of where they have used this data to identify something in the system, and they've been able to do an intervention off the back of that. But there is so much data coming through, they need a way of sorting it. So we turned to a project with Niall, Niall Taylor's just finished, a PhD student at the University of Oxford, looking at large-scale language models that have come out last 5 years. I could probably give a whole talk on that, but let's not. And looking at how we can basically use these models to learn useful representation spaces or embedding spaces for these documents to help clinicians find the documents that are similar in some way. And similar is a loose term here. But basically, it was taking a model, fine-tuning it in an unsupervised way, and then looking at ways of evaluating these new models and new representations, looking for failure modes. And actually, to do that, we used a package called Checklist, which I would really recommend, and I'm going to talk about on the next slide. Just a couple of things to note at. Hugging Face Transformers, amazing package. If you want to do anything in the NLP space these days, you'll probably be using it. And Declutter is a really cool thing that came of Alan AI last year, and it's using contrastive learning to learn better embedding spaces. And that's basically saying, should these things be close together or not, and then using that as a learning mechanism to put them close together or not. Turns out it's really good. Okay, next slide. So, Checklist. What is the point of Checklist? Well, Checklist is basically taking software testing to natural language processing models, or language models, I should really say. We basically had a new domain that we wanted to put this on. A lot of the open language models, they don't work on healthcare text. Some of them work on biomedical stuff, but they definitely don't work on NHS text without at least pre-training them a little further or maybe doing some kind of fine-tuning. We actually put some downstream pseudo tasks. Ask me about that later if you want to know a bit more. But basically, this allowed us to have a supervised task. And then we employed Checklist to check whether our NLP model was behaving itself if we made a change. Checklist comes with 3 kind of ideas around testing. Minimum functionality, does it do the thing I expect? Invariance test, if I change something in my sentence that shouldn't change my prediction, does my prediction change? So for instance, changing gender should not change the severity of an incident. And finally, directional expectation test, harder to do in a patient safety thing, but you can imagine this in a sentiment analysis model. If I add a negative sentiment on the end of a positive sentiment, it shouldn't get more positive, it should get more negative. Thus, that is checking that the directionality of your expectation has changed in the right way. And finally, I added this similarity of embeddings test. This is one we're working on, but it's not done yet. Basically, this allowed us to develop a suite of tools to test the models that we were building on patient safety-like things. Okay. Patient safety-like things through a nice interface, and actually means you can scale it pretty well. I'm going to speed up slightly through this one because I realize I'm running over a little. Project 3. This was Kai Zhang and Sarah Hickman. Kai's a PhD student at Imperial, and Sarah was just finishing her PhD at Cambridge. She's gone back into healthcare now. She's from a medical background, but she's doing a PhD in AI. Automating text descriptions from imaging. So this was all about trying to learn the same representation space for images and text, such that you could use that space to generate text given an unseen image. So this is built around some work from OpenAI called CLIP, Contrastive Language Image Projection? The P I've forgotten. But anyway, it's a good paper. There's a really good blog about it there. And this is this way of doing it. You have a text encoder and an image encoder. You basically work out from a contrastive point of view whether the image and the text should be close together or not. We were looking at this for X-rays or radiology reports and basically saying, can we learn something useful? And there were lots and lots of really good stuff out there to help us do this, and the CLIP package was really good, although in the end we wanted to change it in a certain way. So we didn't actually get to use CLIP directly, we actually used a slightly different package. But finally, just to say, this report and the code is actually online. The other 2 are coming. Watch this space. In Project 3, PyTorch Lightning is the thing I want to bring up here. So PyTorch Lightning wraps PyTorch. It's a way of basically removing all the painful boilerplate that PyTorch has. and also allows you to be very flexible on the type of hardware you're using, and that's why it was really important for us. Because you've got images and text, it gets pretty heavy duty on GPU usage. So what we actually did was, through PyTorch Lightning, we were allowed to basically write the same code that would run on a CPU, a GPU, or a multi-GPU setup, although we didn't use those very often. Final thing, this really relies on distributed data parallel, which comes from PyTorch. Really, really cool bit of way of distributing your data across multiple devices, so keep an eye out for that. So really, really short on time, so I'm going to be quick through this one. We're trying to join research to operations. So far, I think we're not quite there, but we're really thinking about how we can do this more and more going forward. I'm really going to pull out just 3 from this list of 8. Please feel free to read it quicker than I will be able to speak through it. We want to end the work with a release. It stops us letting the scope slip and actually only allows us to reduce it because we want to release at the end and we're not waiting around to release it. We have to work with potential stakeholders to develop both push and pull. A lot of our projects have come from push, but we want to pull, and hence call out to the community. If you have ideas, please do come and let us know. And then really we want to develop this short feedback loop from operations about needs. You know, a colleague of ours says benefits not features mentality, and I think that's really important here. At the moment we're doing a lot of prototype stuff, but we may start to make some toolkits. I know I'm at 20, so quick on the wrap up. We're currently finishing our 3rd wave, as I mentioned. Niall's just finished, Jamie's just at his end, Kai and Sarah have both finished. We've got 11 projects completed across a wide range of topics, and we just really want to continue this scheme, increasing the focus on working with trusts, other national NHS organisations, to produce outputs and further grow collaborations with academia. Again, ideas, please. And finally, Python has played a key role in all of this. As you saw, you know, Python was at the bottom of everything. The thing I find it really useful for is going from ideation or prototyping into a useful output, hopefully by others. We'll see. Utilizing and combining open source frameworks in not new but different ways. I never claim anything to be new because I then find it online and be like, oh, it's not new at all. Someone's done this. Seeing what is happening at the edge. You know, Python is really great from the point of view that people are doing stuff in Python at the bleeding edge, both in research and industry. And it means we can share our projects in a consistent way, which we feel is adding to, you know, the community of healthcare professionals using coding languages and how they can use them, you know, producing a growing knowledge base. And that's it. And only 1 minute over.
Thanks, Dan. Thank you. I actually remember interviewing some of these candidates for the PhD project, and they're all absolutely excellent. So if you were a PhD candidate today, how would you distinguish yourself in order to get one of these?
That's a really, really good question. I think if I go back to the slide where I'm actually going to go back to the slide, sorry. We go back to the slide I was talking about what we want the candidate to experience. Half of that was about them getting knowledge of how we work and getting used to the NHS and those types of things. But the other half's about what they can bring. And often when we interview, it's about thinking through the idea, thinking through the project, and thinking where you might take it, and actually being able to run with that, be self-autonomous. And that's one of the things I think is really important. I think that comes a lot from doing a PhD. You kind of left your own devices sometimes. And the other side would be just thinking through how you're going to do the project. We like to have a bit more of a, you know, maybe more like an agile structure around things. And I think just candidates that come with a good idea of like the timelines that they're going to keep to, how they're going to do it, where slippage might happen and how they can avoid it, they do very well as well.
Great, thank you. So online, Mohammed says, there is mounting evidence that by incorporating research into NHS operations, effective patient care and health outcomes may be enhanced. But can the NHS achieve service demand and financial goals while funding research at the same time?
Yeah, I mean, I think that question's bigger than our team. We're a small team doing this. You know, there are sort of 3 or 4 of us that spend a portion of our time on this. We'd love to scale it and we'd love to see how that works out. I think for how small we are, we're not going to be able to answer that question. I do think there has been shown evidence that bringing research in allows you to make a lot of really great steps forward, which will hopefully make the whole system better. But again, it's a very big challenge, and I recognise there are other things that people need to be doing.
Thank you. Is there any questions in the room? Dan? Sarah, looking pensive.
On that last point, research costing money, do you think our researchers are cheaper than bringing in consultants, though?
That's a really good question. I think I'm going to dodge the question and say something slightly different. I don't want to think about it in terms of cost, but I want to think about it in terms of knowledge, especially with the language modeling stuff. I don't think, at least my understanding is, I don't think many consultancies are pushing beyond what is going on in academia or going on in some big industry players out in the open already. Absolutely, there'll be some IP they're keeping quiet about, but you can really get a lot of knowledge out of people coming from PhD backgrounds because they're working on this every day. So cheaper, I don't necessarily want to comment on, but they absolutely are at the cutting edge of a lot of this stuff, and they bring that in-house. And yeah, fair enough, it comes to me, but we write a report about it that then goes out into the open, and hopefully other people can learn from that, or our team. So yeah, and actually yes, they are cheaper, buddy.
I think it's my turn again. Sorry, I'm always asking questions, but may I flip that question on its head? Can we afford not to do research? Maybe just expand on that bit. Of course, I'm going to say that these kind of things, I'm a researcher myself, I'm working at university, I've done a PhD myself before, but there's so much we can learn and so much we can do better if we put a tiny bit of money into doing some research. And I think it's fantastic what you're doing. Why are we not spending more money on it?
Matt, very kind words. So I'll even dodge this question slightly as well. I'm not dodging it in the sense that I don't agree. I'm dodging it in the sense that I think the problem I've often found is what people decide is research in the NHS. I think we do a lot of research every day, and probably at the front line, people are doing observational research without even realizing. It's just about how you maybe establish a program out the back of that or develop an app or something. So yeah, I absolutely agree we need to make sure that we're drawing research as close as possible and using it in the best way. But I think we also need to recognize that we're doing it a lot already. Maybe it's just not called that.
Great, thank you. Round of applause for Dan. Okay, next on the lineup, David Sogbati is the Chief Analyst of the Health Economics Unit. David's got experience as a computer scientist and has worked for several national, regional and ICS providers in the NHS. He's going to be talking to us about both R and Python. So for those dual programmers among you, should be a good talk.
That's a good place to start. Fantastic. Mike. Perfect. Hello, hello. My name is David. Very nice to see you. This is a very weirdly shaped room for this kind of thing. But it's great. And I do like that we have some green on our right. So I worked at the Health Economics Unit. We are part of Midlands and Lancashire CSU. Quite diverse team. There's a bunch of data scientists, data engineers, health economists. It's exciting to have people with so many different skills and such a varied background. I usually shave. I don't like not being shaved. Last week I had to have a couple of injections and I had a bad reaction, so I've not been able to shave. So you can see that I have a white beard growing. When I studied computer science, I still label myself a computer scientist, but I think I come from a generation where the labels between computer scientist, data scientist, software engineer were a little bit blurred. We work with the NHS, work with charities, we also work with the private sector, somewhat controversial, but that gives us the opportunity to look at a range of very diverse projects. Oh, sorry, I forgot something very important. We also work with universities. So lots of very, very different people that we have connections with, and lots of different projects, lots of different tools we need to use. Yeah, worked with startups, worked with NHS. This picture is monstrous, and someone did some photoshopping which made it even more horrific, so I'm so sorry. So very, very lucky. Very lucky to work on a variety of projects with lots of data and lots of interesting questions to answer. some of them more traditional, like looking at risk stratification, looking at problems that we've already solved in many different ways, but we're still looking for perfection. But also we're looking at more unconventional, newer problems, and something that we're quite passionate about is impactability modeling. So the idea that we really want to understand in our patient population, in our population, which interventions are actually going to work, instead of just throwing lots of money at the top of our risk pyramid, actually really figuring out how we match patients and interventions. But today I'll mention something else that we're quite interested in, and that's creation of synthetic data. We were hoping to start work on a very ambitious project soon, but we don't have the funding. So if you have any spare money in your pockets, please come talk to me. I absolutely don't want to be controversial. I'll try. I also try not to swear. I tend to swear always at conferences. I have a slightly complicated relationship with some of this marketing, this packaging of some of the conferences, because on one hand, I'm a strong believer in the power of communities, and I think something like this is extremely important. I love that I've been speaking to lots of different people, and there is such a variety of levels of experience and interests and sub-interests, and but we've all worked with R at a certain point, and some people in this room have just started learning and are writing their first lines of code. Other people are super masters. But as Dan, I think Dan said earlier, let's not forget that there are other languages and they're great. I agree, but I'm going to take it one step further. There are other languages, and they are essential. As we move towards bigger, more complex projects, really understanding what is in our toolbox, and in the first place, actually buying the right toolbox and having the right things to use is going to be absolutely crucial. So for me, personally, it's not so much about R Python, it's about building great projects, building the right flow for whatever project we are working on. And I left my phone in my bag, so I don't know how much time I've been speaking so far. I might need some help with that in a moment. A few, maybe 15 years ago or so, maybe less, somewhere between 10 and 15 years ago, I was at a programming conference, not too dissimilar to this one, and I went to talk about Facebook, and they were telling the most bizarre of stories, at least for me, for someone who had more limited experience at that point. It sounded so weird. So that they were growing quickly. Yeah, we know that Facebook has grown a lot, and one day they were struggling. They were really struggling to keep up. So their code base was pretty much all PHP, and as many scripting languages, PHP does what it does really well. It's not always the most efficient, right? Just getting problematic. They kept on buying servers and servers and servers and server farms. It was a struggle to keep on scaling up. So they had a big hackathon, and someone came up with the weirdest idea. So we get the request from the client side, from the browser. We take the request, We take our PHP code, we pull we translate the PHP code into C++, we pull G++ out of our sleeve, we compile on the spot, we execute the software on the spot, and then we send back semantically equivalent responses. And that cut down the processing requirement by about 50%. I find that outstanding. First of all, how did anyone come up with something so bizarre? But it's a great example of how sometimes we'll have in our wonderful teams, we'll start fostering one element, one part of our skill set. And we'll get to a point where it's a necessity to break out of that. And the solutions are not always the most straightforward, the most intuitive. But I think this is now discontinued. I think Facebook has a completely different technology under it at the moment. But I found it very interesting, and that spirit of really trying to understand what's actually going to work has very much stayed with me. Now, let's talk about this problem. There's another problem that I think is quite fun. Why on earth would I want synthetic data in the first place? There's a few reasons. One, we are a growing community, right? We have more and more people, and we want to keep on expanding. We want to bring on board more people. Ideally, we want to train the new data scientists, the people of our future with healthcare data, because we fully appreciate that healthcare data are unique in some ways. Human beings are complex. There's a lot that goes into a human, and healthcare data reflects that. So ideally, we'd really like really good synthetic data to support training. I think it's something that I strongly believe in. But also, juggling many projects, I see a lot of a lot of IG processes. I have a lot of conversations. I go to a lot of panels, defending projects, trying to get access. Sometimes just because we want to test an idea, because we want to create a prototype. So if we had a really, really good, comprehensive data set that could help us test things, so that could help us speed up research and development, I do think that it could really, really help. Once again, if you have any money lying around, just let me know. Something that is quite tricky about synthetic data is how will you think about the evaluation? So synthetic data is going to be based on something that already exists, and absolutely you want to make sure that it cannot be reverse engineered, that it cannot be, that is not going to breach anyone's privacy. But also you want it to be loyal, you want it to be realistic. You want to have a good, high fidelity. So it is a technically interesting problem. But some people, and maybe some of them are in the room now. Oh, something else has appeared there. Oh, sorry. What we would like to do, really, is to take this data set. So I have a good relationship with the KID people, the Kent Integrated Dataset people. So a lot of the IG panels that I go to are often with them. And if you ever do end up with them, they're actually pretty good at their job, in my opinion. They will ask a lot of questions about your project, but they're usually sensible questions. So it's a population of about 1.8 million, and it covers quite a lot across many different tables, right? So what we're trying to create is a large description of a population across a multi-table data set. Once again, appreciating that healthcare data, the data that we tend to work with day in and day out, are complex, and want to make sure that when we train people and that when we test our ideas, we do that with something that is realistic, that feels like the real thing. Here we go. So some people might be in the room here. So some colleagues have done already some work on this, and it's really, really good. So the Skunkworks lab, does it still exist in that label? Maybe it has changed title, maybe not. Has created a tool that does that. It's based on variational autoencoder. I don't know if it's something that you encountered before. You have a layer that learns, it's an artificial neural network layer that learns about the properties of data set. And then it's usually called the decoder layer that takes samples and generates something new from it. I think I've seen it somewhere, I've seen it described somewhere as generative layer. I think I personally prefer that technology, that terminology. The bottom line is, this is a technology that has been tried and tested on a number of similar problems. So variational autoencoders are used to generate a number of synthetic things online. So this is good. This is a great starting point. However, when we start looking at large multi-table data set, things start getting a bit tricky. There are relationships across tables that we need to preserve. So we started looking at how we could potentially be running multiple models, keeping some hyperparameters consistent, but also introducing some constraints. So for obvious reasons, I want to make sure that we don't create a data set where we have an, I don't know, a 95-year-old man with that is currently starting to suffer from postnatal depression, because that's not very realistic. So this is something that we would like to do, as I said. At the moment, we are very much in wishing stage, trying to pivot back into what goes into work like this. Now, I fully appreciate that a lot of this interaction between technologies is probably already very, very, very common in many of your roles. But building it deliberately, I think is something that we really, really need to make sure we do instead of keeping on developing with what we know. SQL is ever, and I appreciate that probably it's at the beginning and sometimes in the middle and maybe even at the end of many of your projects. It's very, very likely that our chain will then go through R. I think we found R great for a lot of our exploration of data. It's something that we've been using consistently and that we are very comfortable with. Here, somewhat provocatively, I've decided to include Prolog for identification of constraints. My background is very much in symbolic AI. Now, there's a lot of this that could be done as well in some Lisp dialects or many other languages. The point I'm trying to drive here is really making sure that we can build that integration. Now, the Python bit. So I do think that the core engine of the project is very much going to be in Python. That is where the biggest strength is going to be for that type of technology. But then, once again, going back to R for an interface. Don't get me wrong, there's a lot of great stuff that can be done in Python in that sense. But we do have probably slightly better tools in R, and we definitely have more expertise in R. Which brings me to my next next point, which is, I think Sarah mentioned this morning, tech time and training, which I really liked. And I think I might start stealing. Getting all of this in place is absolutely fine. It's absolutely feasible. But it does take a bit of time. Now, I'm absolutely not advocating that every person in every team should learn every possible language. But making sure that we give people time and space to broaden their horizons, I think has huge benefits. Making sure that everybody can expand their toolbox is crucial, especially when projects start increasing in complexity and the technologies that you're using become more numerous. QA, for example, gets trickier very quickly. And I'm sure we've all stumbled upon a poorly designed QA process before. But also there is the tech. And none of this is rocket science. And all of this is pretty straightforward once we wrap our heads around it. And once we give people the right tools, and once we let people explore the tools that are available to them. But we should not underestimate how easy it is to just fall when we don't need to fall, because there are plenty of options available. So focusing on R and Python, there are so many options, so many ways when your project grows and you need to pass data and between the two. For very simple stuff, we don't even need to do anything sophisticated. Jupyter notebooks have been in my life for less than other technologies, because I'm very old. And I think most Jupyter kernels tend to run Python or R, but there are script of scripts kernels that you can implement that will allow you to mix and match as you need. But also, you can use Reticulate to call Python from R. You can use RPY2 to call R from Python. And let's not forget about the beauty of scripting, whether it's terminal, PowerShell, or if you're using batch files. I know that those are the nuts and bolts, the simple things of the old guard, but they're still extremely, extremely effective when we need to start bridging gaps between technologies, and we want to make sure that everything is flowing smoothly. I believe I might be almost at time. Okay. Do I have time for any questions, or am I? Oh, okay, fantastic. So, I think it's great to be here, and it's great to have a main room full of people talking about R, and it's great to have some space where the Python community and the R community can come together. But let's not forget about the wider ecosystem, and let's make sure that as we develop our capabilities, we have our eyes open, and we're not restricting ourselves. And I know that for many of you, that's going to be very obvious and natural. But in the NHS, we are quickly training the next generation of data scientists, and the last thing we want to do is to create too narrow a foundation. And yeah, let's all think about what Sarah said about tech time and training, as that's going to be crucial to make sure that we can build robust tools for the future.
Thank you, David. Giving our camera guys run for their money. Can you just
Sorry.
Thank you. Yeah, so just looking at your modular workflow, we have this kind of same problem. Do you need someone, if you're going between SQL, R, Python, and back again, do you need someone who knows the entire kind of workflow?
Good question, and am I close enough to the mic? I would argue that that can be highly dependent on the team, on the type of project, and on the side of the project. I tend to be a big proponent of everybody having a bit of understanding of what comes of everything. I want people to be able to communicate and to feel comfortable about what each other is doing, but at the same time, there is a time and a place for specialization. So there will be times where someone will be a big expert of a very specific subsection of a problem or technology, and will have a very, very superficial understanding of everything else, and that in many teams is okay. But broadly speaking, I tend to also be a proponent of having an overview and not falling into blinkered thinking. The broader your knowledge base, the better conversations you'll be able to have, and working as a team in something bigger is always going to be crucial.
Great, thank you. We also have a question from online. Michael Lane asks, what, in your opinion, is a minimal viable setup for deploying Python if you were a new data science team?
Sorry, minimum viable?
A minimum viable setup. How would you set it up?
Ooh. Once again, that depends a lot on the application and your current environment. So, if you're doing, I'm working with data scientists and machine learning specialists, my heart went straight to telling you all about scikit-learn and TensorFlow, etc., etc. I don't think that's the right answer for many, many teams. So I think for me, really having an understanding of the type of problems that you want to work on, and really making sure that you become very familiar with the tools for those problems is a good starting point. Once again, and then branch out. Don't stick to only one type of problem. But you know, get to know your libraries. Code, absolutely. Write a lot of code. This is a speech that I give very often when I talk about any technical topic. So just did a number of sessions on population health management. So we talked about all the algorithms for segmentation, etc., etc. And what I usually close with is, this is all completely pointless and useless. You learn all of this stuff by sitting down and writing code. You can read books, you can go to lectures, whatever. Coding, you learn by coding. This is very important, but you need to do it. So for me, it's all about understanding what you want to do when you grow up, and really familiarizing yourself with the tools that you think are going to be most useful.
Great, thanks. Any questions in the room? Dan, straight away.
Thanks for the talk, really interesting. A comment and then a question. The comment is the synthetic variational auto-encode was actually a PhD project. So David Brind and Dom Danks, and then the Skunkworks took it on. So just had to give them a shout out for that great work. The second thing is, so a lot of what you're talking about here is going beyond a single language. Often when we talk as data scientists about this and talk about environments, we're told we're not software developers, we're not infrastructure engineers, we're not people who maybe should go beyond a single language or a single setup. How do you feel about that statement?
So that is why I'm giving this talk today, because I've been given that speech more times than I felt comfortable. I did not labor this point too much in the previous slides, but what we do as analysts, in the NHS, everybody's an analyst. You know, the word as an analyst is used a lot. And over the last few years, what we do as analysts has grown a lot in scope and complexity. Now, when I joined the NHS almost 10 years ago, finding a line of R in the trust I was working in was water in the desert. Now this is expanding and getting into more and more environments. My opinion is that this growth in complexity will continue. So the types of problems we'll be wanting to look at will become bigger and more interesting. The solutions we want to deploy will become more multifaceted. And what I absolutely don't want to see is for us to say, oh no, but we're not software engineers, we're just sticking to R or to Python, and we're not going to learn more because we're not building those big complex products that, like, you know, Facebook or Twitter or Windows or whatever big package you want to think of, because I absolutely think that there is scope for us to keep on growing, and we should absolutely learn from good software engineering.
Thanks.
Great. I've got one more question from online. Will Brown says, how do you and your team deal with unit tests in a multilingual team?
That is fantastic. So we're a fairly new team. I think the team was assembled maybe 18 months ago or so, maybe 2 years. My post was created only this year. I joined in May. And one of my first missions was to support the development of a QA strategy. So really understanding how we are going to make sure that everything we deliver to our partners is of outstanding quality. One of the big principles that we agreed on is that every time we start a project, we will set up a QA board. Now that sounds
pompous. It doesn't need to be. If it's a tiny project on a problem that we've already solved a million times, a QA board is your friend sitting next to you who has already solved the problem many times and can look to the code with you. If we're looking at the big, revolutionary, multi-million project that will save the NHS tomorrow, now we need to bring in a bigger pool of experts. And once again, as complexity grows, as we use more technologies, as we use more interesting maths, we need to make sure that we bring in the right people. Now, unit testing is absolutely crucial, and it needs to be matched to each component of your problem. But as we grow, really making sure that we have the right person coming in to write the right tests, and we can really understand what the limits and the potential pitfalls of different points in our chain are is going to be crucial. But I think that that question potentially can go beyond. I think having a strong QA culture in general is very important, and strong unit testing is something that can really support that.
Great, thanks David. Round of applause. Danny here? Danny?
Thank you so much.
Okay, next up, Danny Gamal from Google, data analyst. Danny is a clinician and data scientist at Google and is helping develop their clinical products and healthcare data services.
Thank you. Maybe you could hear me here. I don't plan to do too much walking. So thank you very much for the introduction, Craig. So really pleased to be here. My name's Danny Gamal. I'm a clinician and data scientist in the Google Health team. You might have met some of my colleagues in the room. We're all a group of people really passionate about the NHS, probably more so than we are technology. So we're already looking for ways that we can collaborate, learn and share ideas here. And so today I just want to share some of our learnings from evaluating FHIR clinical data quality with BigQuery and DBT. So I'm sure that probably everyone in this room has got their hands dirty with data quality. It's not always the most glamorous problems, but it's something that's essential to every model, every project. But it's only really in the last few years working in Google on our Care Studio product that I've had to think about data quality at scale. And that's what the challenges and the learnings from that I want to share with you today, and also to signpost some of our code that we're hoping to open source very shortly. So in that first slide, I already mentioned 4 tools that not everyone here will be familiar with, which is probably not the best way to start a presentation. So I'm just going to run through at a very high level each of these for grounding. So first things first is we have Care Studio, and this is a tool that we've built at Google that enables clinicians to search over the patient record and extract relevant clinical information for the clinicians. It's built upon a data platform in which we integrate and standardize data from different clinical systems. And so that brings us nicely to the second item here, which is FHIR. So this is the data schema that we standardize to. So FHIR, for those who are not aware, is an open international standard for defining a sort of de facto way of representing health data as we share it across systems. The third one, BigQuery, is probably a bit more familiar. This is Google Cloud's enterprise data warehouse, and this is where our data platform lives for analytics. And then the fourth tool along, which you'll hear me mention quite a bit in this talk, is DBT. So DBT is an open source tool written in Python that basically sort of knits together your Python scripts, your SQL scripts, and puts them together into a package and a data pipeline. So it's something that really ties in with what Sarah was talking earlier about reproducible analytics pipelines, and we're starting to use that in our work. So over the last few years, there's been a bit of a shift in the landscape, which I think is a really exciting one for all of us in this room. Clinical data is starting to be liberated at a great scale, of course, with all of the necessary IG controls in place. But we're going from what was previously, probably saw lots of this in different trusts, in different places, this sort of idea of isolated data extracts, ad hoc, pulling and reproducing data in different places. We're sort of moving away from that to this multi-use data platform, trusted research environment sort of model. So this is great and it has many benefits, but in terms of data quality, it brings some challenges. And these are the challenges that fell on my team and my colleagues. And one of the first challenges when I think about this is that when we think about how we would define data quality, what does it mean? Most of the definitions will be something around the adequacy of the data for how it's going to be used. So it's much easier to apply that principle in the sort of data extract isolated project. You know exactly what matters for your model, for your project, you know what doesn't matter, and you might even be able to clean up some of the data yourself in your own extract. As we move to the clinical data platform, we hit other challenges. The first thing is, data's coming from different sources. We're transforming data. So whenever we do that, there's a risk of data loss or clinical misrepresentation. So we need to be on top of that and making sure that's been done correctly. Data might be streaming, it might be dynamic. That brings its own challenges of updates and deletes. And then also the point I alluded to earlier is, by definition, the data platform is multi-use. There'll be lots of different users, different applications, and they all have different requirements. So with this comes different teams, different stakeholders, and potentially even clinical safety implications if applications are built on top. So how have we gone about tackling this? Well, it's broadly a mix of these two factors. So there's, of course, the technical side of things, of how do we measure many things and measure them many times, almost constantly, as the source data is coming in and can change. But like all data science projects, there's always a human side to this. Always need to remember that data doesn't actually do anything by itself, it's just information. So this actually needs to lead to action. So in this talk, we're in a technical conference today, so I will go deeper on the technical slide, but I'm just going to have one slide just to give an illustration of those human factors. So here are just some examples. So the first thing is around frameworks. So we've developed our own sort of validation framework that we call the 3 Cs. And this is centered around conformance, completeness, and clinical integrity. I think there's lots of subtly different frameworks out there. I don't think it sort of matters too much, the difference between them. I think it's just important in this to have something that makes sense to your team, that makes sense to stakeholders, that guides the process of validating data. Playbooks in the middle. Playbooks is a huge part of the culture in Google, and it's needed because things break at inopportune times. We don't want to rely on individuals, so things need to be documented very well. And it was great to see a talk earlier really emphasizing the importance of good documentation. And then finally, we have responsibilities. So, when I think back to some data science projects I might have done in the past, I might have been able to go through a whole data quality cycle of finding an issue, investigating it, finding the root cause and fixing it, all myself without any handovers and anyone else even needing to know about it. In the world of the data platforms, the TREs, this is just not going to be the case. We're going to have different roles, different responsibilities, different end users. So there needs to be organisation and coherence around roles and responsibilities. So now onto the technical side. So this is our problem, is that we need to be able to script hundreds of metrics, maybe even thousands, depending on the size of the data platform. We probably need to be running these every day, give or take, depending on the use cases. In our case, we need to be able to deploy and run this for multiple different partners who might have subtly different requirements. And we want to be able to run these metrics in which way that we can actually drill down after the metric is run to find out what's the root cause of the anomaly. And then finally, the last point about highlighting anomalies, it's just not going to be feasible for a human to be reviewing hundreds or thousands of metrics every single day. So we also need a mechanism to direct our attention when something needs looking into. So this is where BigQuery and DBT come into play. So BigQuery, we've of course been using for many years. It's a Google Cloud product, so BigQuery changed my life many years ago. But DBT has only really come into my life very recently, and this is kind of how I feel about it. Because I still sometimes struggle to articulate to my colleagues exactly what DBT is or what the benefits we're getting. Because on face value, it is kind of simple. The main thing it does is what's described here. It takes your SQL scripts and your Python scripts and it runs them in the right order. So it sounds pretty straightforward, but I promise you, if you start using it, it's a lot more transformative than that sounds. And the way I kind of like to think about it is it lets me, as an analyst, without a computer science background, be able to build an analytics project in a way that a software engineer might. So building on principles like modularity and testing and version control in a much more sort of easier and reproducible way. So let's get into our DBT project. So DBT projects, you can kind of think of them as this nice little package of various bits of analytics code that are all designed to sort of interact with each other and work together. And there are many different components to this, probably more than that's on this slide. I'll just go through the key ones. So the first thing is our metrics themselves. They're the meat of our project. we've developed around 180 different data quality metrics over fire data. So these range from very straightforward counts, referential integrity metrics, to slightly more involved clinical metrics, like we might calculate things like midnight bed occupancy to validate that that's accurate of the actual state in the hospital. Documentation, I've already stressed the importance of that, so that's where the metadata comes in. So DBT is excellent for providing a very structured way of defining metadata for metrics and tagging metrics, which makes it a lot easier for debugging and investigating. In the middle, we have macros, and these are really the most powerful part of this. And I probably don't need to explain to a room of Python users, the importance of don't repeat yourself and pulling out code that's going to be repeatable into functions. But this isn't something that's natively part of SQL, and it might not be something that people who are often writing SQL queries are used to. So this really has transformed sort of how I write my SQL queries with DBT's macros. We've also developed a framework for building patient cohorts, and I'll come to that in a couple of slides. And then finally, we've built the first version of our anomaly detection model. So this is just a time series model, just using off-the-shelf tooling available in BigQuery. And the idea here is to identify daily metric values that deviate significantly from expectations based on the historical trends. So now that we have our metrics all nicely packaged together into this project, it's as simple as running the command dbt run to just execute this over our entire pipeline. So when we hit dbt run, our metrics will be running over our data platform, the FHIR data platform, and persisting outputs into another BigQuery database, our metrics layer. Then from then, the outputs can be easily consumed by any data visualization tool. So we've developed a prototype tool in Looker Studio to visualize these metrics, but really you could hook this up to any visualization tool that your organization uses or that you prefer to use. So just got a couple more slides. So for these last two, I'm just going to zoom in a little bit into a bit more of the detail. So on this one, we just have an example macro from the project, has medication request. So we can see here that this is a bit of SQL code that's a little bit convoluted. If anyone's worked with FHIR data in the past, they might recognize the codable concepts and the need to unnest these nested and repeated fields. So it's a little bit convoluted, and it's also something we're going to want to use again and again. This is a common thing. We want to see if a patient had a particular prescription in a given time window. So a good candidate for a macro. So now that we've pulled this out into a macro, we can use this whenever we want to ask that question. For example, when we're constructing a patient cohort. So here we have a SQL query that's trying to extract patient IDs meeting certain criteria. So here, what would have previously, without DBT, been a pretty long and complex query is now about 10 lines of pretty repeatable and very readable code. So we can see our has medication request function there. And then if you can see at the bottom, it's a little bit faint, we then, with a little bit of the sort of DBT magic of how this all stitches together, we can run our whole pipeline over this particular cohort. So again, the dbt run command, but this time just providing a variable saying I want to run these metrics over the hypertension cohort. And it's these sort of things I found with DBT that it's really excellent for running subsets of metrics, cohorting, and all of these sort of clever bits that fit together. So finally, just a quick demonstration of a screenshot from the Looker Studio dashboard we've built. So this is the overview page. And as you can see here, we've just built a few different pages to enable users to explore the latest anomalies from the anomaly detection model, or drill down into particular metrics, or view the metric definitions on the right-hand side there. So that's everything today. Thank you very much for your attention. As I said, we're looking to open source this, and it's coming very soon. I'd really love it if anybody is interested in any part of this. It might be that you have FHIR data in BigQuery and this is perfect, brilliant, get in touch. It might be that you're just interested in DBT and how these reproducible pipelines work. So yeah, please do get in touch. And I'll leave these take-home messages up there and invite questions.
Great, round of applause. Thank you. So, as a data engineer, I can't really let you go without asking a question about DBT. You mentioned about Python and SQL, but if you've already moved to PySpark, what's the advantages, or how does DBT fit in with that, going backwards or forwards?
Well, That's a good question. As someone who hasn't used PySpark before myself, so I probably couldn't tell you the pros and cons. Yeah, I mean, the advantages of comparing to, having just SQL scripts or just Python scripts or even a Python notebook, we found it is for that sort of use case of building a pipeline that we can easily package and deploy. That might be something I'm not 100% sure on the PySpark side, but that's like how we're open sourcing this, the idea being it can be published as a package, put out there as a DBT package, or somebody could clone the whole thing, or they can pull that into their own DBT project to use all of our macros, all of the things like we had in the sort of patient cohort strips. So that's where we're seeing some of the benefits.
Great, thank you. Any questions in the room? Well, we've got another speaker lined up, so sorry, these are the quick fire presentations. Thanks, Danny, again. Round of applause. Okay, you're just setting up 1 second. Ready to go. So German's from NHS Scotland and come all the way down from Edinburgh today to see us. So late entry into our schedule, but we've managed to fit him in. So over to you.
I think I'll use the mic here. No, thank you for that, and thank you for inviting me to the conference. It's great to be here, and can I just say that it's great to see Python logo beamed up on the big screen there, all over the stadium grounds. So it's great to see, put a smile on my face when I walked in. So what I'm going to talk about today is exhibit and synthetic data. First, I'll sort of give a brief introduction to synthetic data. I'll try not to repeat what David already sort of covered in terms of the use cases, etc. Then I'll sort of look at the exhibit features and use cases for it was developed. I'll try to fit 2 live demos if I can, but we'll see how we're doing for time. And then there's Q&A and some future plans for exhibit. So what do we talk about when we talk about synthetic data? And the key takeaway from here is that I think there's not one synthetic data, it's a spectrum. And Office for National Statistics put out a really nice graphic illustrating that, showing sort of how synthetic data goes from sort of structural level to a replica level. And as the granularity and the level of detail increases, so does the analytical value, but also the disclosure risk. So the closer your synthetic data is to the real data, the more controls you have to put around it to make sure that the information is not leaking and to make sure that the patient identifiable information is protected. Another point is that synthetic data is typically context and domain specific, and so are the challenges and the approaches that you might take when looking at synthetic data. So generating synthetic data for images, for example, will be completely different to generating it for text or for just your standard sort of relational sort of table style data. And synthetic data needs to evolve just as the real data or the products evolve. So if you've built a dashboard that uses synthetic data and then some visualizations change over time, then you need to rebuild that synthetic data to make sure that your dashboard is still looking good. And one thing that I sort of think about when I sort of think about synthetic data is that it's about replicating the logic behind the data, so that your data types, your distributions, relationships, rather than data itself, data points themselves. And of course, there'll be synthetic dragons out there. Source control and observability, sort of making sure that you know all the steps that your crown jewel of confidential data sort of takes all the way to the synthetic stage. Stakeholder trust and explainability of the algorithms that you apply to generate the synthetic data. And again, this sort of has to be almost done in 2 steps and for 2 audiences. One is a technical audience, and another one is more on the information governance side, on the policy side, where you need to explain in plain English what you've done to ensure that the confidentiality is protected. Data linkage across multiple tables, particularly involving time, is very challenging, as is sort of preserving row-level relationships in your data. So an example would be if you have a hospital stay consisting of multiple episodes, you want to preserve that relationship in your synthetic data, and it's not straightforward to do. It's much easier to preserve column-by-column relationships than it is to do row relationships. And with multiple tables, again, the challenge there, for example, is if you have a table with patient information that includes date of death, and you have admissions table, and you don't want to have patients who have passed away in one table, appearing as new admissions in another. So there are challenges there. And some tools like SDV, for example, they'll typically sort of join those tables and then sort of disaggregate them. So there are approaches there. And then, of course, accidental matches and disclosure control. To give you an example, in Scotland, there's a community health index number, each patient's given that, and it has a certain logic to it. So it includes patient date of birth, a code for a cipher for their gender. So if you're using synthetic data approaches to synthesize chi numbers, it's pretty much inevitable you're going to have collisions with the real stuff just through business logic, if you follow that business logic. So that creates extra dangers when looking at it. So Exhibit, what, why, who, and how. Exhibit is a sort of is a Python command line tool. It generates data from a set of user instructions that are stored in a text editable file, in a YAML format. So it's human readable and editable. The original purpose behind sort of Exhibit was to help with sort of dashboard presentation, because I was in a team that was going out to events promoting our dashboards that were using confidential data, and we had quite a few dashboards, quite a few data sets, and rebuilding those data sets that would be okay to show to external audience was a challenge. And this sort of gets around the problem of sort of handcrafting these anonymized data sets using new code every time you sort of have a new data set to tackle. Exhibit is fast, it's flexible, and it doesn't require any programming knowledge to use. And that's another, I guess, differentiating point from some of the other tools, is that all you need is a text file, and you edit that, and the conditions that you put on your synthesis, they're expressed in natural language. So you want to say, okay, make this column the same. So make the values in this column the same. So you don't have to write any code for that. So that's abstracted away. And as sort of the project developed, I've realized that there's also room for more advanced users who would want to use Exhibit as an importable library to be integrated into existing scripts. So there is that functionality as well. So key features, you can rapidly iterate on synthesis options. So if something doesn't work, it doesn't tell the story that you want with synthetic data, you can just change a few parameters and then rerun it, and it's very quick work. You can create custom distributions using weights and probability vectors. You can use regular expressions to anonymize, sort of to create almost like lorem ipsum style fields. If you want, for example, to test load volumes, then you can basically create a lot of text fields really easily and quickly. You can add columns derived from newly synthesized data. So an example, I'll show you an example of that later. You can preserve relationships, and relationships could be sort of paired, hierarchical. They could be custom relationships, so that you, for example, ensure that in the sort of example that David used earlier, that certain age groups will only ever have certain diagnoses. And again, this is something that you can learn with a machine learning model, but you already know that. You already know that logic. In the same way that you already know that, you know, discharge date follows the admission date, not the other way around. So you don't need to learn that, you just need to specify it. You can add outliers to any subset of the generated data. So this is, again, helps with the storytelling. And again, depending on your use case where you use the synthetic data, if you're using it in a dashboard, you want to show how your dashboard sort of draws the insights from the data. And you almost plant those insights into your data, into your synthetic data. Or, for example, if you're a researcher and you're testing your hypothesis, you can insert that hypothesis into your synthetic data to make sure that if your code finds it, well, you know it's there because we put it in there. So then when you run that analysis on the real data, if it finds it, well, that's good. You can also generate geospatial data using H3 hexes. An example of that would be something like this, where you can basically create Latin long pairs for, say, GP practices based on the number of sort of regions that you set. So if you have health boards and you want to create fictitious GP practices but want to locate them in realistic places, then you can do that. You can augment synthetic data with compiled machine learning models and custom functions. So you can combine some of the simpler sort of methods with more advanced methods and sort of mix and match. So how do I get sort of my hands on it? You can install it with pip. So pip install, exhibit, and if you want to have access to all the latest changes, you can also just clone the repository from GitHub, get it that way. I've just updated it just in time for the conference, so it should have all the update things in there. How do you actually use it? So once you've installed it, it has a fairly slim list of dependencies, so it's not going to bring like everything. In the folder, in the demo folder, I have an inpatients dataset, which I've downloaded from the web, so it's open data. And it's a dataset that is at quarterly level. So quarterly level, individual hospitals in Scotland with their code, a couple of measures, then number of stays, length of stay, average length of stay, and then some patient details. Couple of things sort of that are notable about this data set is that some of the relationships. You have the paired relationships with the health board code, health board name. You have hierarchical relationships with one health board, many hospitals. You have dependency sort of column that is average length of stay, which is length of stay divided by stays. And then you have obviously the date field. So when I press exhibit from data inpatient CSV, if I don't give it any additional parameters, and there's a sizable list of them that you can sort of customize what comes out, it will produce a YAML file that looks like this. Which is a specification. And it will have a number of sections, and I'll sort of quickly go through them to give you just a brief overview of what they do. So you have the metadata, which is just the number of rows, the types of columns that you're seeing in the data set. You have the random seed. So one thing about Exhibit is that once you have the spec nailed down, if you run that spec again and again, you will always be guaranteed to get the same data sets out. So it's great for reproducibility. Each column type has its own sort of subset of parameters. So for categorical columns, you'll have sort of this original values parameter, which will have all the values for that column, their probabilities, and the weights for the numerical columns for each of the values. So in this case, for example, all other things being equal, the length of stay for this age group will be much greater than for this age group. But of course, these things will interact between each other. You have the number of unique values, you have the miss probability, which means that you can introduce missing data if that's what your tests require. So for example, if you have a scenario where you are testing for the presence of null values and how your system copes with that, you can introduce that artificially. But of course, there are different null values, which we'll cover. There's a paired column, and that will appear here with the paired values. Sometimes you'll have more values than you can sort of practically look at in a specification. So like for this location name and code, there are 48 hospitals. So rather than list them all there individually, they're sort of stored in a database that comes with Exhibit. For numerical columns, you have some distribution parameters, so you can target the scaling of those values to either target minimum or maximum or the sum. You can again introduce misses, like the null values. For dates, you can control the frequency, the number of unique values, the probability. And another useful option there is that if you want to build complete time series, so if you want to, for example, in your visualization, you want to toggle between different sort of categorical values, but you always want the complete time trend. So setting the cross-join values to true means that there's always going to be a value for that. So that's the sort of the columns section of the specification. There's also constraints allowing duplicates or having some basic constraints with values in one column being always greater than values in another column, or custom constraints. And there's a number of them, like making null, making not null. This is useful, for example, if you have two columns, like readmissions within 7 days, readmissions within 28 days. If you have readmission within 28 days, the readmissions within 7 days can't be null, because that will at least have one in there. So some of these we would make creating those patterns a lot easier. There's linked columns, in this case health board name and location name, and derived columns, as I said, you can do like average length of stay. I'm not going to cover sort of too much more around that specification, but there's a lot more you can do, and you can see from the parameters. For example, if you want to erase all the distribution information, you can set the equal weights flag in the command line, and that will make sure that all the weights, all the probabilities, they're all equalized, so that all that specific information is erased. I wanted to show quickly the way to use Exhibit as a script. And you import the library, you create an empty specification, which is a dictionary, that looks like this, which is very similar to the YAML sort of spec that I showed earlier. You set the number of rows that you want, and in this case, what I sort of demoed here is, imagine that for this conference, we want to generate data around what people tweet about. And we have, we can start with just the user IDs, so let's have some user IDs, and we'll set the frequencies so that most people sort of will tweet 1, 2, or 3 times, but there's a small percentage of people who will tweet 10. So if we generate that data set, we have, okay, so that's our data set with just 2 columns, and then we can sort of start building on that. We can add the channel with just 1 original value, so Twitter. We can then add the track, R or Python, with probabilities, so that we have more R, tweets about R than Python. We can then sort of add text, and that's that regular expression that I talked about. We add the number of likes between 0 and 100. And then we sort of add the date, and the date column will be just day level 4 days. So we add those, we generate the data, that's how it looks. It takes seconds to generate 10,000 rows of that data. Of course, there are some rules to that sort of in that scenario, so that your user name is matched to user ID. So you have to make sure that they're the same. So we basically say, okay, for each user ID, the target column username has to be the same. And for the tweets, we'll sort of make it almost the same, so that typically people will tweet about the same sort of thing. So we'll want to add that as well to the mix. When we do that, it takes slightly longer, but not by much. And then what we'll see is that, for example, for this user, they've tweeted mostly about Python, but there's a bit of R in there. And then that person was unlucky enough to have 0 likes for his tweets. So that's how you can use Exhibit in a script. And I've only got what's next for Exhibit, which is to look at sort of changing the specification from YAML to HTML to make it a bit more user-friendly, investigate streaming generated sort of data, and the usual bug fixing, performance improvements, and more, because software is never finished. Thank you. That was me. Hopefully I didn't run over too much.
The microphone's just run out of battery, so thank you. Is there any questions in the room or did you want to mine? Impromptu.
It was a really last question, right? It was more about what schema do you generate the synthetic data in? I think it's a really cool work, and but did I misinterpret that? Is it you input the schema each time you want to do it? So you could say.
Yes, so it depends. You can either generate it from the data you feed it, so you have your source CSV or something, and then Exhibit will automatically generate that specification for you, and then you can manually edit it bit by bit, or you can just write it from scratch. As long as you follow that format, with the sections and the keys and the YAML, so that it understands it.
Have you tried that with like an EHR schema or health schemas? Or?
Well, it's because it has to accommodate the general aspect of it. Because the moment you lock yourself into a certain schema, a certain format, you can't abstract it. You can't make that abstraction work for other domains or other contexts.
Yeah.
And this is the difficulty with synthetic data, is that with this tool I wanted to avoid getting sort of penned into one way of doing things. And this is why you can basically use your own models, as long as they sort of expect the data frame and then they output a data frame, you can sort of tie them into this. And then you can do whatever you want with it. You can create custom profiles for diseases, and that will just work. But you don't have to share it, essentially. You just keep it to yourself.
Good, that's it.
Mm-hmm.
Okay, great. Thank you. Round of applause. Sorry, technical. Thank you. Great. Well, we're going to have a little bit of a break while we set up for our virtual stream. So if you just come back at about 5 to 5, we will get on with that pretty quickly. 5 to 4, sorry. as we're getting everyone on the internet connected up. Are we live? Yep, I think so. Hi everyone. We're going to start again. We've got 3 more presentations. These are all coming virtually through the power of the internet. Hopefully Teams, Zoom are all going to play friendly with us and work together. So we'll see how it goes. First up, Darshita from, she's a co-founder and CEO of Atari Labs. And she's got a presentation for us today. We're going to start again. We've got 3 more presentations. These are all coming virtually through the power of the internet. Hopefully Teams, Zoom are all going to play friendly with us and work together. So we'll see how it goes. First up, Darshita from, she's a co-founder and CEO of Atari Labs. She's got a presentation for us today. We're going to start again. We've got 3 more. Hi, Darshita, could you start us off? Thank you.
Sorry, should I get started with the presentation?
Yes, thanks.
Okay, great. So, hello everyone. Many of you might be aware of R Shiny, which is a package that makes it easy to build interactive web apps straight from R. Today, I'll be introducing a shinier alternative to R Shiny for Python developers. So a little bit about me. My name is Darshita. I'm the maintainer of the open source project Atri Framework. It's a new full stack web development framework. A few months ago, we released a beta version of this framework, and we have been receiving great feedback from developers across the globe, and we wanted to take this opportunity to also present it to the NHS group that's present here. I'm also the co-founder and CEO of Atri Labs, which is the company behind this open source project. I've worked in machine learning and data science fields in academia and industry. After studying engineering during my undergrad, I worked in quant finance and then moved to academic research at MIT. I later dropped out of my graduate program at MIT to work on my startup full-time. One fun fact about me is about one of the personal projects that I'm doing, which is that I'm editing and managing the publication of a set of novels that my grandfather wrote over the last 5 decades. So it's a really cool piece of family history, but also supporting the literary work that he has been doing and bringing it in front of people. So the way I've structured this presentation is, firstly, I'll quickly introduce what Atri Framework is, which is like, what is this alternative to R Shiny, how we can use it in Python. Then secondly, I'm going to give a quick demo of a dashboard, a multi-page dashboard that I've built using one of the data sets provided by NHS. Third would be showing you how it has been created. So giving you a behind the scenes look into how its front end has been created using a Atri editor, and also how the backend has been created using Python. So front end would be basically any UI component that you see in the dashboard, how that has been set up. And then backend would be, for example, how the data, for example, flows into the charts, how user actions are handled, and how we actually respond to all of that. So to do that, I think best place to go would be the open source project itself. We have been building an open, it's under GPL3 license, and all of the development is happening under this repo in GitHub under our organization name Atri Labs. It's called Atri Labs Engine. and everything that you need to know about the project has been kind of introduced here. So I'll use it as a starting point for our conversation as well. So very quickly to introduce what this framework is and what it intends to do. It's a full stack web development framework, which means that it supports front-end development, it supports back-end development, and it also provides support for quick deployment. So on the front-end development side, because it's for any size of web development need, be it someone who wants to write React code and who is a full-time web developer versus someone who lies on the other end of the spectrum and wants to build front-end visually using our visual editor. All like that entire range and the entire spectrum of development is supported by this framework. Backend development is supported in Python at the moment, but we are planning to add support for Node.js soon. So it's again going to be not just limited to the Python world or JavaScript world, as is most web development technology that comes out. And then third is deployment support. So we are adding one-click support for deployment at your platform of choice. If you want to deploy it through GitHub pages, if you want to deploy it through AWS, etc., we can do that using this framework. One common question that we get is, what can I actually build using it? So anything, it's a general purpose framework, so anything that lies in web can be created using it. So I can quickly show you an example of some of the websites that have been built using this framework. So this is like a e-commerce website that has been built using the framework, and all the backend is also hooked into it. And then there are things like personal blog that are also that have also been built using this framework. To contextualize how it's different from other frameworks, I think one of the biggest things that we should know is that I briefly touched upon, that most new web development frameworks are limited to the JavaScript world. So they are not, but we know that a lot of development is now happening beyond that world as well. So for example, people who are backend developers and use Python, people who are data scientists and use Python, or are people who are machine learning engineers, they also need to do backend development. For example, for even simpler things like sharing the results of sharing the intermediate results of their work to things like creating, fully interactive web applications or fully interactive dashboard applications natively through Python. So that is one of the biggest differences that we see as compared to other frameworks that you see in the market. And then it comes with a suite of productivity tools such as visual editor, asset management tools that I'm going to quickly introduce to you. And the goal is to significantly reduce development time so that you don't have to worry about lots of things that go on behind the scenes, and you can just focus on your getting quickly to production. So that is that. In order to get started, it's very simple. You just write one line pip and install a3, and the visual editor becomes available in a local host. And once we click build and run, the app itself becomes available. So let me actually go to the demo and show you exactly what we have built. So let me go to the login page first. Okay, so this is the dashboard. It has a simple login page. My credentials are already saved here, so let me log in. And when I log in, I am taken to this dashboard. What this dashboard is showing me is it's taking the monthly hospital episode statistics dataset. It's provided by NHS Digital. And for a given treatment specialty, it's showing me firstly, what has been the activity monthly by admission type. So if I, for example, zoom in to say 31st January 2021, I get a breakdown of the different kinds of cases that the different types of activity that all the NHS, the entire NHS has observed in this month. So what are the number of emergency cases? What are the number of FAE cases, FCE cases, ordinary admission episodes, and so on. This chart, for example, shows what were the appointments. It shows a breakdown of the types of appointments in the last 6 months. So the number of appointments that were attended, the number of appointments that were canceled, and number of ones where people didn't show up. And this chart shows the percentage FCEs with procedures in the last 6 months. Again, for this specialty that's selected here, which is 100 general surgery service. And then finally, this is another view into the patient activity data in rolling 12-month basis and year-to-date basis. I can see in the last 12 months and compare it with the previous 12-month cycle and see what has been the change in each of these activities. If I want to see the legend, I can click here and get a deeper understanding into exactly how these things have been defined. So FAE is the finished admission episode, but exactly how it has been defined is available here, and so on. Like all the different terms that you see in the dashboard can be explained by the legend page that's again linked with this dashboard. And if you want to see exactly how this app has been created, then it's also linked with the GitHub repo. So again, it's open source, and you can see, like you can get access to the entire code and you can play around with it. So coming back to this app, one of the things that happens here is that if a user, for example, chooses a different treatment specialty, then they see like all this data set gets updated, and we see all this information with respect to this specific specialty, which is ophthalmology. I think we can now quickly, I'm conscious of time, so let me quickly go and show you the behind the scenes look into how this dashboard has been prepared. So I mentioned the visual editor, which is one of the productivity tools. This productivity tools ensures that you don't have, like you can build most of what you see without having to code. So that's a really cool feature, but it also ensures that you stick to the latest web standards, so that for example, your work looks good in all the different screen sizes, which is one of the important requirements for web applications. And it also ensures that you kind of stick to the other principles that have been provided by all the different browsers. So this is the editor that's linked, that basically generates this app. And if we quickly take a look into exactly what's happening here. So there are 3 different pages here. So this is the home page, which is basically the login, then dashboard and legend page. This is the component manager, which helps us to add any component onto the front end. Asset manager shows all the different images that we have in our dashboard or in our app altogether. If I click on any component, like we call each of this a component. So this is a text box component, and you can see the variable name or alias here. If you want to change anything that has to do with its style, so for example, if I want to change, like in this case, we have applied a font, we have applied a weight and a style and a color. So this entire thing has been provided through this style panel. this is what we call a custom panel, which is basically overriding the exact text that appears in this text box. And then you have this other panel, which is for actions. Actions are, for example, more important in, say, button, where you expect a user activity and so on. So you can see that all these charts have, like the charts here are displaying a dummy data because we just dragged and dropped, for example, a bar chart onto the canvas. And we haven't really, in this specific case, we are just creating the front end through the editor. So like this is all dummy data. But then comes the interesting part as to how do I actually hook my data from Python directly to the app. So that simply, like we can do that very simply by going to the project repository. So this is the project repository, and I had launched the editor from this project repository. So everything you see inside this NHS demo folder has been auto-generated, except for this folder, which is called backend. It includes all the different functions that that help us in data processing. If you want to add any backend to any page, then we need to go to its main.py file. So if we look at, like if I collapse this, then I see that inside routes, there are 3 main.py files. One is inside the dashboard page for, so that you can apply back into the dashboard page. And similarly, you see one inside the legend page, and then one here, which is for the home page. So again, this is auto-generated. It represents the life cycle of these 3 functions represent the life cycle functions. So init state helps us in providing data that we want as an initial state of the app. So whenever we publish the app, then by default, if we want that app to show a certain data set, like if we want it to show certain data, then we'll provide that data through init state. Handle page request is when we want a user to, the data that we want a user to see when they load a specific page in the browser. And handle event, as the name suggests, is to specify what to do when a specific user activity happens. So if I go to the dashboard page, then here we don't have anything in init state, but inside handle page request and handle event, we are calling a function that we wrote called setFilter. And setFilter basically modifies all the charts according to the value that was selected from the dropdown. So if it's handle page request, meaning if someone is loading the page in the browser for the first time, then we want them to see all the information with respect to general surgery service, treatment specialty. It can be anything, but for the purpose of this discussion, it's said this way. But handle event is when someone wants to, like if we want to handle how to take the data in from the user, then it's very simply let me show you one. Let me basically rewrite this to demonstrate something again. So okay, let me go back here. So this is the dropdown that we are talking about. It's renamed to specialty dropdown because it's helping us select specialty. So if we want to access anything, if we want to access any property corresponding to any component that we have in our front end, we do it using this AT object. AT object is, it provides us access to all the components that we have, and it allows us to access data, manipulate data, override data, and so on. So in this specific case, what I want to do is that if someone has selected, like if someone has changed the dropdown, then do something. So all I have to do is, write this chained operation for any component in a thread. So you don't really need to know the documentation. So the moment I write at dot, then I see I see a dropdown of all the different components that are available in this page. So in my case, I want to access the data that specialty dropdown has. So I just selected it and then I press another down. Now I can, access the styles panel, the custom panel, and the actions panel again. So let me go and select on change. And now what I want to do is, call the set filter function, provide them this data model so that it can manipulate all the components by accessing the AT variable, and provide it the value that the user had actually selected. So again, to access the value that the user had selected, we have to go to the component. So we'll do at dot name of the component, which is specialty dropdown, dot custom. And when you press dot, then we again see a lot of options. We see displayed values, we see all the available values, but what we are interested in this case is selected value, because we just want to know what the like one specific treatment specialty that the user had selected. So I basically did that.
I've got to move on. Can you just wrap up? Thank you.
Yeah, sure. So this is basically how you write backend in a thread. So it's again very simply using chained operators, and like you can create your own functions the way that I've created here. And to manipulate any component, you just do at.component name. And if you want to change, like depending on what you want to change, if you want to change the custom property, then you do custom dot name of the property. If you want to change styles, then you proceed accordingly. And the moment we save this, the results automatically reflect in the A3 app that we have running in our localhost. So I hope this gave you a brief introduction into what this framework is, how it can be used in Python. So let me conclude with that. And thank you for listening. And if you're interested, you can check out the open source project that we're building, start it, try it out, and let us know any feedback that you might have.
Thank you. Round of applause.
Thank you.
Thank you, Dash.
Yeah, sure.
So give me 2 seconds. Oh, skipping to the end. Sorry. Hold on. So hopefully you can see the first slide now. Is that right?
Yep, thanks.
You can't see my notes, so yeah. Hi everyone. I'll try and keep this a little bit shorter so we get us back on time. So I'm Alistair Jones, a senior data scientist at NHS Digital, and today I want to talk about our work on generating artificial healthcare data and how this enhances patient privacy. And mainly, I really want to point you towards our recently published code base. So there's a link on screen, and I'll talk more about what you'll find there later in the presentation. So just to give an overview of the talk, so I'll give everyone an idea what NHS Digital is, if I can get my words out, and particularly kind of around how researchers and analysts connect to the data that we hold. This will set the scene for me to talk through artificial data, what it is, and the main benefits it will bring for patients, users, and the wider kind of organisation and NHS. And the main focus of the talk is really on our artificial data generator. So this is our code base for generating artificial versions of NHS Digital assets. And finally, towards the end of the talk, we'll just look at how we want to take this forwards and hopefully open up some avenues for possible collaboration. So I'm aware that many of you will already know, but I just want to briefly outline what NHS Digital does. So we're the national provider of information, data, and IT systems for commissioners, analysts, and clinicians in health and social care in England. So we're responsible for things like the NHS website, the NHS app, spine services that let data flow between trusts, and NHS Mail in the within the wider NHS. And loads of other things. But NHS Digital is also the custodian of England's national health and care data. So the data sets that we hold cover a range of different care settings. So from primary care, so GP data, to secondary care, hospitals, and to community and social care settings as well. And the key point is that none of this data is ours. We don't own any of it. It belongs to patients, so it belongs to you in the audience, and it belongs to me, and so we need to treat it with the utmost care and respect whenever we interact with that data. So NHS Digital provisions access to patient data for a small number of approved researchers and clinicians from kind of partnered institutions in order to improve patient care and the NHS service as a whole. Access to this data is managed through the Data Access Request Service, or DARS, and naturally NHS Digital is extremely protective of patient data. So these access requests are very thorough and can take a long time. So we're talking months, if not years, and they require a lot of paperwork and approvals and a lot of effort on all sides. So when researchers come in to access that data from outside, they connect with the data through the trusted research environment. And this is a way to bring the researchers to our data rather than sending it out to them. So we've touched on that in previous talks today. And obviously this is a much more secure way of doing it than sending out extracts. Prior to coming in to the TRE and accessing that data, prospective users of the data have to rely on public-facing documentation and data dictionaries, and that's quite hard for them to really know what they're applying for and what it's going to look like when they get it. And it's really difficult to answer kind of certain questions that they might be asked in those data access requests. So around data minimization, what fields do you need and how are you going to use them, and what kind of questions are you going to ask about that data? So what if we could help these users out? What if we could give them something that looks like the data they're requesting in an environment that's kind of similar to the TRE? And would this help them understand what they're actually going to apply for and streamline this whole process for them? So this kind of brings us on to artificial data, and that's our answer to some of these questions. So artificial data gives users something that looks similar to real data. So it has a similar structure, so the same field names and data types, and broadly the same univariate frequency distributions, but it's completely anonymous. So by design, it lacks statistical relationships between fields, and it wouldn't be possible to perform representative analysis or build statistical models that would transfer onto real data. And by doing this, we eliminate any risk to re-identification. So I know someone earlier showed a nice slide from, I think it's from the ONS, about the kind of spectrum of artificial data, or a spectrum of synthetic data. So we're definitely towards the kind of low fidelity end of that spectrum. We've actually steered clear of the word synthetic data just because there's this kind of, it's open to a bit of misinterpretation, and it can mean quite a lot of different things to different people. So we've kind of stuck with artificial data as the term we use. Now, who benefits from this? I know we've touched on this in previous talks as well, but for us, there are two primary benefits. The first, and probably the most important, is the enhanced patient privacy that comes through having access to artificial data. So artificial data helps minimize the amount of personal data that gets processed. And this obviously benefits patients. Artificial data promotes the use of real data only when it's absolutely necessary. The second benefit comes in the form of efficiency gains and burden reduction. So analysts and researchers will have quicker and easier access to something that looks like the data they're interested in, so that they can kind of start their project work, they can start developing their understanding, building analytical pipelines and scaffolding code bases. And if they want to go and apply for real data, they could use this data to inform their DARS applications. And so this helps overall streamline that process for them. We, as an organization, also benefit from both of these things. First and foremost, we've got a duty of care to our patients to minimize the processing of their personal data whenever possible. And we benefit from the efficiency savings by having a smaller number of well-informed DARS applications that will be easier for us to process. So I just want to give a quick example of the type of data that we generate. So we've already touched on, or some of the previous presentations have touched on HES. So this is a data set of all the hospital events that occur in England. It's one of the largest and most widely used data sets that NHS Digital holds. And the key thing here is it's event-based, so patients can kind of reappear multiple times, where each record represents a distinct event in a hospital setting, so a diagnosis, an admission, a treatment, or and so on. I've shown an example of a cut of our artificial data at the bottom of the screen, and I don't know how it looks on the big screen in real life, but I just want to point out a few features of this data. So firstly, there's some features that make it immediately clear that it's actually artificial data, like the HES IDs, which index unique patients, all begin with test. And that's just to show that there's no overlap with any real IDs. No real IDs ever appear in this data. There are some more interesting features, though. So if you can see rows 1 to 4, they all share the same HES ID. And so do rows 5 to 7. And so what we have is patients that reappear in this data across time, or seem to reappear. We've got the IDs arranged in such a way that they do. And we've also got patient characteristics that stay the same over time. So when we resample from these patients, they come back and they likely have a similar set of characteristics. But that's not always the case. We've actually accounted for errors in this data as well. So you can see in row 2, there's a different date of birth from the other rows for that patient. And what we want to really do is produce this anonymous data, but still give users a flavor of what the real data is going to look like. Data sets aren't perfect, and there's all sorts of weird things that can happen, and we want to kind of represent that. So on to kind of the main focus, I want to talk about the artificial data generator itself and what it does. So on this slide, I've got a kind of high-level logic of that. So the first step is the metadata scraper. And this collects anonymous aggregates of real data on a column-by-column basis. So we take values for non-identifiable fields. So we throw all of the IDs away. So only non-identifiable fields are aggregated to produce univariate frequency distributions. So essentially, we build a load of histograms. And no statistical relationships between fields are preserved. So we'd know, for instance, how many males there are in a data set and how many 50-year-olds there are, but we wouldn't know how many 50-year-old males there are. and small numbers are suppressed to ensure that this data is anonymous. So following this, we have a data generator step that randomly samples from this metadata, again on a column-by-column basis. It essentially picks a value for each field and sticks those values together to make something that looks like a real record. And then we just do that a lot of times. And then we stick some dummy kind of IDs on the end based on a template pattern. No actual values appear for any ID fields, as I said. And then finally, we just apply some basic tweaks to this data to make it appear more realistic. So we swap birth and death dates to make sure they're kind of ordered correctly. So generating data in this way leads to artificial data that's anonymous and has the kind of right structure and univariate frequency distributions, but it also lacks record level integrity. So I think someone gave the example earlier, and they actually gave the same example that I'm going to give, which is you could have, or I think it was a similar example, you could have geriatric diagnosis codes by pediatric patient records and vice versa. Or you could have, I think it was a 95-year-old man with a postnatal diagnosis, a postnatal depression diagnosis. So yeah, it's that kind of describes that kind of that lack of record level integrity. We do also have a way to generate artificial data tables and make it look like they're related to each other. So if you generated multiple tables, you'd have IDs that you could carry over. And so what you'd be able to do with those is you'd be able to take two artificial data tables and join them and get a similar number of records before and after that join. But the referential integrity wouldn't stretch beyond that. I'm not really going to talk more about how that works here, but if you're interested, then please feel free to reach out to me after the talk and we can go through it. Now, here I want to just look at some of the features we've put in place to ensure that the artificial data is completely anonymous and how we provide that assurance that there's been no accidental disclosure of personal information via the metadata that we create. So the metadata scraper gets run in a separate environment for each data set that it interacts with. So on screen, you can see that dataset 1 sits in a completely different scope to dataset 2, and there's no interference between those scopes. Nothing can bleed between the two. So everything is completely isolated from one another. So we produce the aggregates of dataset 1 in its own environment and the aggregates of dataset 2 in its own environment, and so on. And once we've done that, we've then put in place a checklist based on consulting with our chief statistician and the disclosure control panel at NHS Digital. And so what happens is a member of NHS Digital staff who is approved to access real data reviews that metadata against the checklist and gets sign-off from a senior manager. And this is similar to how NHS Digital releases stats publications, and it helps provide that assurance that the aggregated data is in fact anonymous. So we expect that it should be based on the code we've written, but we put that check in place to give it that sign-off. After the metadata has been approved in that environment, we move it into a different environment where it can be fed into the data generator. So the data generator is completely isolated from any record level data. It never gets to see it, and records don't get fed into the data generator at all. Only metadata that has been signed off through this process. So here, I mean, I guess this is kind of the main point of the talk. I don't want to dive into any code in any detail, but I just want to point you towards the code base that we've recently published. So this is what we use to generate artificial data. And we've been working to put this code out in the open for a while with this talk in mind. Unfortunately, we managed to get it out earlier this week. So you'll be able to find it at the first link shown on screen or on our organization GitHub. I want to quickly highlight as well just the second link on screen, which details the process that we've agreed with our senior leadership within the organization for putting code in the open. So we've got a review and sign-off process in place that teams need to complete before they release code to ensure that nothing risky is included in the repo. So please take a look at that link as well if you're interested in publishing your code, or reach out to us and we'd be happy to talk you through it. But just back to the code base. So we've developed the code in Python, so hence the PyCom strand. And this leverages the PySpark API to aggregate big data sets and generate large volumes of artificial data in a scalable way. And partly this design is down to the fact that we use Databricks at NHS Digital. So if you've not used it before, Databricks is a cloud-based platform for working with Spark primarily. But this design also allows us to match the scale of real data sets in the artificial data we generate. So for instance, data engineers might be able to use this data for volume testing, where previously they might have had to use either real data or completely kind of garbage fake data. So we're now giving kind of catering for that use case. Again, I don't want to delve too much into kind of code and implementation details in this talk, but if you're interested, then reach out to us after. I do want to highlight a few of the technical requirements and constraints we've been working within. So previously I said, we want to completely isolate the aggregation step from the generation step, and we want to insert a manual review process in between these two. So to implement these requirements, we've used a framework that our platform developers provide to analytical staff at NHS Digital, and that's called code promotion. And essentially, this is a way to bundle up data pipelines into something called projects. So a project encompasses everything you'd need to build and run a data pipeline. So all the code, the tests, the description of the databases, the jobs, everything. And so using HES as an example, we've got 4 of these projects, each of which tackles a different aspect of the problem we're faced with. So the first deals with scraping the metadata from HES. The second is used to administrate that metadata, so move it into the safe environment if it is deemed safe to do so. A third is used to generate the artificial data from the safe metadata. And then a final one is used to present that artificial data to users. And each of these projects only has access to a set kind of permission scope. So only the metadata scraper step interacts with real data. And the data generator step only ever interacts with approved metadata. So I just want to kind of set some expectations for if you went to this code base and you had a look around, just set some expectations for how you might be able to use this, or more precisely what kind of the limitations are. So we have developed this entirely in Databricks, and in its current form, it will only work in Databricks. So code is written in Databricks notebooks, so it doesn't work like usual Python files. And that's not to say that isolated kind of functionality wouldn't work. So if you had your own PySpark and Python environment, you'd be able to copy the code into there and use different bits of it. But the kind of pipelines and the file structure as a whole is designed for Databricks and would only work there. So this means things like, you can see on line 22, importing code in Databricks is a bit weird. You use this kind of magic run command, and the Python interpreter in a non-Databricks environment wouldn't know what that means. So you'd struggle kind of downstream from that. So unfortunately, we've kind of had to be pragmatic and work within the constraints of the environment and the tools that we've been given. But we do have plans to extract the reusable logic out of our code base into its own package, so that people could reuse this across environments. And I'll touch again on this shortly. So a big kind of elephant in the room that I've been ignoring thus far is, can you access the artificial data, and how so? And at the moment, the answer is no. Unfortunately, access is restricted to internal NHS Digital systems only. Well, sorry, I say no. So if you are an internal analyst at NHS Digital, you can access it through the data access environment. or if you're an external researcher from a partnered institution, you can access it via the trusted research environment. But the reasons for this kind of restriction on access are historical and complex, and I don't really want to go into it. We know that the artificial data is anonymous, as it's defined by GDPR, and we strongly believe that the real value of this data comes when you make it publicly available. So we're currently working with our information governance colleagues to gain the approvals we need to put this data in the open, and that will probably be via the NHS digital website. So we're hoping to have this within the calendar year, but watch this space, and we'll keep people updated.
Thanks, Alistair. We're going to have to move on there.
In terms of where we want to take the code base, there's kind of two sides to it. So we've got approval to produce artificial data for... Sorry?
We'll have to move on, sorry. We've got one more meeting.
Okay, no worries. What I can do is I just finish on this link. If anyone wants to reach out to us, then please, we've got some email addresses on screen, so get in touch and we can talk to you about it offline, I think. But yeah, thanks everyone. I'm sorry I've overrun a bit. Yeah, enjoy the rest of the sessions.
Okay, thank you. So we've just got one more presentation to go. Last but not least, ZK from Sweden. So just go and see.
All right, so can you see the screen?
Yeah, thanks.
Okay. All right. Hi, good afternoon all. My name is Zeki. First of all, thank you so much for inviting me to this conference, and thank you so much for giving me this opportunity. First of all, let me introduce myself. I'm a data scientist. I'm currently working for DataTerra Tech as a data analyst, and at the same time, I work for Yandex as an IT mentor. I have 5 years of experience in IT, especially data analysis, machine learning, deep learning, statistics, and data visualization. I have received my master's degree in business administration and management from Naval Postgraduate School, California, United States, and my bachelor's degree in electronics engineering from Air Force Academy, Turkey. Now, currently, I'm located in Turkey, but I'm working for a Swedish healthcare data company, which is DataTerra Tech. I'm mostly, in most of my projects, I use Python. And I have mostly worked with manpower data. Now I'm working with healthcare data, and I love it. Okay. I'm here today to talk to you about our solution at DataTerra to detect data quality and data sensitivity by using Python and its libraries. I'll follow the outline presented on the screen, introduction and problem statement, data quality inspector model, sensitive data detection models. Basically, we have 2 models here. First one, CNN model, and the second one, name entity recognition model, and further study. I'm going to keep it short since we are running out of time. So let me tell you about DataTerra and what we try to do at DataTerra and why we build these models. So as you know, the demand for high quality data is growing, and it's becoming crucial due to rise of artificial intelligence. DataTerra runs a data marketplace for the healthcare sector by providing verified samples of training data sets. And we try to deliver a safe, trustworthy marketplace platform experience by supplying high quality, real life healthcare data to clients. And we try to enable them to build accurate AI models. So, as you know, up-to-date and trustworthy data are key inputs into overall development of AI models. So we try to make sure that we have high quality data that we can provide to the customers, and we leverage artificial intelligence to determine data sensitivity as well as data quality to ensure that data is highest standards in accordance with GDPR norms. So I'm going to talk about in the following slides also. So before data is integrated into our platform, it is subject to artificial intelligence based tests to determine its value and suitability for our platform. So that's why we try to build a data quality inspector model to detect the quality of the data sets, and sensitive data detection model to detect whether data includes sensitive data. So, you know, General Data Protection Regulations, GDPR, defines data concerning health as personal data related to physical or mental health of a person. And also it includes a provision of healthcare services which reveal information about this and you know, health status. So such data, like healthcare data, provide more significant information about a person and so receive special protection. So we need to be sure that the data in our platform doesn't include sensitive data. So that's why we build a sensitive data detection model. So before talking about sensitive data detection models, I'd like to talk about data quality inspector model, because high quality data is a must for our platform. Like, this is like the first step. We need to be sure that data is high quality data before we run our models. So there are a couple of metrics need to be considered in terms of data quality. These are completeness, accuracy, consistency, validity, timeliness, and integrity. So in our model, we've looked at a couple of metrics: missing values, duplicated values, multicollinearity, and erroneous values. And we had some assumptions. For example, the criteria for high quality data that we use: overall missing value percentage less than 5%, overall duplicated value percentage less than 2%, no multicollinearity between columns, and overall erroneous data percentage is less than 2%. So these were our assumptions. And this model, for this model, we used a couple of Python libraries, very helpful. First one is Y-Data Quality. So Y-Data Quality is an open source Python library for assessing data quality throughout multiple stages of data pipeline development. And the second one, KLib. KLib is a Python library for importing, cleaning, analyzing, and pre-processing data, and standard Python libraries like NumPy and Pandas. All right. So let me show you the results of what this model gives us as the output. So as seen on the slide, the output of the model gives whether data is a high quality data based on the criteria mentioned. So as you see, for this sample data set, we measured missing values, duplicated values, multicollinearity, erroneous values. And for this sample data set, it says this is a low quality data because we have you know, missing values for one of the columns, and the percentage is like more than 80%. And also we have multicollinearity between columns. One more important thing about data quality is the domain knowledge. So domain knowledge is always needed for more accurate assessment. So this model will be evaluated by experts in our team who have domain knowledge, like a physician or a doctor with the background. So we are not just going to use this model, but we are also going to have our experts looking at data. All right. And now, from now on, I'm going to talk about sensitive data detection models. So we talked about GDPR. Basically, we have two models for detecting sensitive data. These models aim to capture sensitive data like name, email address, password, phone number, date of birth, etc. For a given data set. We have built two different models in order to detect sensitive data for different scenarios. First model is a deep learning model, which is a convolutional neural network model, and the second model is name entity recognition model. So this is an NLP model by using transformers. So we've used Python libraries. First one is TensorFlow for the first model, convolutional neural network model. So TensorFlow is a foundation library that can be used to create deep learning models directly or by using a wrapper library. And Keras is a high-level neural network library that runs on top of TensorFlow. So we've used two of these libraries for the first model, which is convolutional neural network model. And for the second model, we've used a Presidio analyzer and Presidio anonymizer, and also spaces. So Presidio analyzer is a Python-based service to detect personal identifiable information like name, credit card number, location, bank number. So as you know, these are considered as sensitive information in a text. And next one is Presidio anonymizer. This is a pretty cool library. Presidio anonymizer is a Python-based module for anonymizing detected sensitive data in text with desired values. And the last one is Spacy. Spacy is a free open source library for natural language processing in Python. So it features name entity recognition, post tagging, dependency parsing, or so on. Okay. So now let's look at the first model. So the first model uses convolutional neural network. So this model is trained with sensitive and non-sensitive data sets, and model can detect name, credit card number, username, password, phone number, email address as sensitive. And the output gives the probability of sensitivity for a given sentence. So actually this model looks fine with textual data, like a sentence-like data. Let me show you one of the outputs of this model. So let's say we have this simple data here, consists of sentences. When we look at the first sentence, his name is John, so it has a person name in it. So the model says this data is more likely sensitive. So the sensitivity is around 99%. Her name is Janet, again, 99% sensitive. Date of birth, it says this data is more likely sensitive. Phone number is blah, blah, blah. It says this data is more likely sensitive. It's same for username and password. When we look at the last sentence, DataTerra global data source for AI models. So we have no sensitive data in this sentence or in this phrase. And the model says this is less likely sensitive, like the percentage is like around 18%. So this model can understand if that sentence has sensitive data or not. All right. Okay. Now let's look at next model, second model, which is name entity recognition model. So this model uses Presidio analyzer and Presidio anonymizer. So anonymizing the data is optional. Name entity recognition models are pre-trained models, so they don't need to be trained. That's really a cool thing. So entities such as credit card, IBAN code, email address, bank number can be detected and anonymized. As I told you, this is optional. So output gives detection of sensitive data for chosen entities. So we can also choose entities, so like which entities we would like to detect, or maybe all of them. Okay, let me go ahead and show you one example here. So again, we have this simple data sentence. It says, hello, my name is Zach, I live in Istanbul. So we have phone number in this original text. We have credit card number, we have passport number, bank account number, SSN number. And when we run our model with this sample data, it gives us the anonymized text. So it can detect Istanbul as location, Zach as person, phone number as phone number, and it can anonymize it. All right. And when we try this with a data set, data frame, so we are mostly going to work with data frames. For a given input data frame, output can be seen on the screen. So let's say we have this data frame. On one column, we have credit card numbers. Another column, we have SSN numbers, salary, and name. So the model can detect credit card numbers as sensitive, and it anonymizes this column. It says this is credit card, and it anonymizes. And then SSN again, so it says this is a sensitive data, and it anonymizes. Salary, so as you see, salary is not sensitive data, so it keeps the original column. And name, again, is sensitive, and the model says this is sensitive, and it anonymized it. All right, so models I have mentioned in this presentation are for textual data. So we've mostly worked with textual data so far. Next, we will be working with image data, like X-rays, like dermatologic images, or so on. We are planning to detect image data quality and image data sensitivity by using Python. So Python has some, cool libraries for all of these. Now, for example, for data quality based on the metrics, we are going to use BrisQ library. And for data sensitivity, like as seen on the screen, sometimes healthcare data images like this one may have some sensitive data embedded on it, like a text information on it, like name or sometimes ID number or so on. So we are going to use PyTesseract library. So this is used to extract text from the image data. And then we are going to merge previous models with this model, with CNN and NER models, NER models, so that we could detect sensitive data on image data. All right, I think that's pretty much it. So thank you so much for listening. All right, thank you.
Thank you, everyone. Can you hear me? Yeah, great. Thank you, everyone. You made it to the end. Thank you. Okay, I'd just like to thank a few people. Sarah for giving our keynote presentation.
So far?
Keynote presentation. Okay. No, we're gonna wrap up. So. Yeah, sorry. Yeah, the PyCom team, Pete, Kabir, and Faiz back there, and Ivor, who's been brilliantly, and his whole team have been doing the camera work all day, made this entire thing possible.
All right, you guys have any questions? Thank you.
Can I just ask, so Pete, Kabir, could you come? And Faiz, could you come, please? Ivor, could you come, please? Great. And Oliver and Simon, thank you so much. You're at home, like, helping us out, so come on, Kabir. Cool. Thank you all so much for your help. This has been months of work, and I'm really, really glad that we've managed to do it, and quite successfully so. Thank you so much all for coming. I really appreciate it. But can you give my colleagues a clap, please? So we finished exactly on time, which I'm so impressed about. And yeah, I have no final thoughts to say. Thank you so much. It's a privilege to lead this community. And I'm really grateful people came in person and traveled from their homes. So I'm really, really grateful. I'm sure you have to catch your trains now, so I'll let you go. Thank you all.